Welcome to this immersive course on Spring Boot and Spring Data JPA, two pivotal technologies in modern Java development. Spring Boot simplifies the process of building standalone, production-grade, Spring-based applications with minimal effort, while Spring Data JPA is a powerful tool for simplifying data access operations in Java applications, seamlessly integrating with databases. Buali Ali designed this course to provide a comprehensive understanding of both technologies.
Welcome, future Spring Boot masters. Are you ready to embark on an epic journey through the world of Spring Boot and Spring Data JPA? Join me for an immersive 13-hour tutorial where we demystify the complexity and unlock the full potential of these game-changing frameworks. Why Spring Boot? Well, in today's market, it stands tall as one of the most sought-after frameworks. Mastering it can truly be a game changer for your career. Consider this. The demand for skilled Spring Boot developers is soaring, and it shows no signs of slowing down. Top-tier companies worldwide are actively seeking professionals like you. Picture landing that dream job, or better yet, forging your own path to success armed with Spring Boot expertise. So, how do you grab these opportunities? It's just straightforward. Join me on this course. Now, let's take a sneak peek into the incredible journey that you're about to embark on. So this course is composed of two main parts. First of all, Spring Boot, where we will discover and unravel the secrets of Spring Core, Spring Boot, Dependency Injection, Spring Profiles Magic, RESTful APIs, data persistence, DTO Pattern, robust service layer, data validation techniques, testing paradigm, Mockito, and much more. Then embark on a journey into the heart of Spring Data JPA, where you'll gain a comprehensive understanding of repositories, relationships, and the art of playing with inheritance. Delve into the intricacies of embedded entities, ID generation, and master the art of querying data with named queries and specifications. And of course, much more than that. We will dive deep into the magic and learn the ins and outs of Spring Data JPA, unraveling the secrets of repositories, relationships, and inheritance, from embedded entities to advanced querying with specifications. We cover it all. Get ready to take your data persistence skills to the highest level. Before we dive in, I would like to invite you to join me on my YouTube channel, where I publish exciting and engaging content every week. Join me there and be part of the great community we are building right now. You can find all the links in the description of this video, as well as this is the ID of my YouTube channel. Finally, a big shout out to freeCodeCamp for giving me the opportunity to share this awesome content with you guys. And I'm really honored that my video will be here to help you improve your skills. Now, with no further ado, let's get started. What is Spring Framework? The Spring Framework is an open source framework for building enterprise Java applications. Spring aims to simplify the complex and cumbersome enterprise Java application development process by offering a framework that includes technologies such as aspect-oriented programming, dependency injection, plain old Java objects, and so forth. Even with all these technologies, Spring is a lightweight framework that can be used to create scalable, secure, and robust enterprise applications. At a macro level, we can consider the Spring Framework a collection of sub-frameworks such as Spring Webflow, Spring MVC, Spring ORM, and so forth. Core features of Spring Framework. The IOC container, or the inversion of control container. IOC container is one of the core features of Spring that provides a streamlined way to configure and manage Java objects. This container is responsible for managing the lifecycle of a defined Java object, significantly increasing the configurability of a Spring-based application. IOC use dependency injection or dependency lookup patterns to provide the object reference during runtime. AOP, Aspect-Oriented Programming. AOP aims to provide more modularity to the cross-cutting concerns, which are functions that span across the application such as logging, caching, transaction management, authentication, and so forth. And then Data Access Framework. So Spring simplifies the database communication process by providing direct support for popular data access framework in Java, such as JDBC, Hibernate, Java Persistence API, also known as JPA. Additionally, it offers features such as resource management, exception handling, and resource wrapping for all the supported data access frameworks, further simplifying the development process. Finally, we have Spring MVC. So the Spring MVC enables developers to create applications using the popular MVC pattern. It is a request-based framework that allows developers to easily create customized MVC implementations that exactly suits their needs. The core components of the Spring MVC is the dispatcher servlet class, which handles user requests and then forward them to the correct controller. This allows the controller to process the request, create the model, and then provide the information for the end user via a specified view. Spring Beans. A Spring Bean refers to an object that is managed by the Spring framework in a Java application. The term bean is used in the context of the Spring framework. The Spring framework creates these beans, manages their lifecycle, and organizes their dependencies with other beans. It takes care of the instantiation, configuration, and wiring up of objects, saving developers from a lot of manual work. Also, the Spring Beans can be configured using XML, Java annotations, or Java code. Lifecycle of a Spring Bean. First, let's understand the lifecycle of an object. So the lifecycle of an object means when and how it is born, how it behaves throughout its life, and when and how it dies. Similarly, the bean lifecycle refers to when and how the bean is instantiated, what action it performs until it lives, and when and how it is destroyed. So the bean lifecycle is managed by the Spring container. When we run the program, first of all, the Spring container gets started. After that, the container creates the instance of a bean as per the request, and then dependencies are injected. And finally, the bean is destroyed when the Spring container is closed. Now, let's see how we can configure a bean. So first, we can use the configuration annotation, which declares a class as a full configuration class. And here you need to note that a class must be non-final and public. Also, we can use the @bean annotation, which declares a bean configuration inside of a configuration class. And the method must be non-final and non-private. So it can be public, protected, or package private. And here is an example. So we see we have the appconfig class annotated with the @configuration annotation, and inside it we have a payment service which has the @bean annotation. So this will return a new payment service implementation, and we can pass any other dependency. For example, in this case, we have the account repository as a dependency for the payment service implementation bean. Also, let's see a full example where we can declare multiple beans. So again, we have the appconfig class annotated with the @configuration, and inside that we have a payment service bean, we have account repository bean, and a data source bean. So the data source will return the data source connection to our database, for example, or our data source. And then we have in the middle the account repository, which is also a bean that takes a parameter, or as a parameter, the data source bean that we already created. And finally, from the top, we have the bean payment service that takes the account repository as a dependency, and Spring will manage all that. So Spring will know that we need to create a data source first and then pass it to the account repository, and then we create the account repository bean and pass it as an injectable bean to the payment service. Spring component sample. So the Spring component contains class level annotation that marks a class as a Spring component using the add component annotation. So the constructor dependency injection is automatically done using the add autowired by injecting the constructor parameters. So the autowired on constructor is optional if there is only one constructor. And here we see an example. So we have our payment service implementation class, which is marked as a component. So this means that we want to mark this class as a Spring bean. And then we have a private final account repository, which refers to another Spring bean. And we have a constructor payment service implementation with the annotation autowired. And we have, or we pass a parameter of type account repository, and then we assign the local or the class instance account repository. We assign it to the account repository that we get as a parameter from the constructor. So in this way, we are injecting via the constructor the account repository bean into the variable or the local variable account repository. Spring components. So Spring provides component stereotype to classify classes as Spring components. The subtypes are available as a refinement for the standard components. So the component annotation as general component annotation indicating that the class should be initialized, configured, and managed by the core container. Also at repository, at service, and at controller as meta annotation for the component that allows to further refine components. Own stereotype annotation can and should be defined to support general architecture principles. Now let's understand the bean naming. So here, assuming that we have this configuration class that contains the three beans that we explained already before: payment service, account repository, and data source. Now we see that in the data source bean, we provided a name. We call it DS. So now let's see how Spring is going to name these beans. So first, when we talk about the first bean, payment service, which returns a payment service object. So this we give it a name or a bean name payment service as for the method name. The same for the account repository. If we don't provide a name for the bean, Spring automatically will use the method name as a bean name. So the bean of type account repository will be named account repository. Finally, for the data source, when we provide the name, so Spring will take that one as a name for the bean. So the data source bean name will be DS. So bean naming is really important in case we want to fetch or to get programmatically any bean from our application context. So now we know how Spring names the beans. Beans injection. When we talk about beans injection, we also mean dependency injection. So the Spring framework provides 4 ways to inject beans. So the Spring can configure dependencies on different injection elements. First, we have constructor injection. So the constructor parameter to receive dependencies during bean construction. So we call this also the constructor injection. Then we have field injection, and this field definition to receive dependency injected with the reflection access, also called field injection. Then we have configuration methods with one or many parameters receiving dependencies through method parameters, also called method injection. And finally, we have setter injection or setter method injection. So the Java setter method are specialized configuration method with only one parameter and a defined naming scheme called also setter injection. So the injection target can be referred using 2 different modes. Type injection injects an object of matching type, or name injection injects any object by name. Constructor injection. So here, let's first see the example of the case of a service. So we have here a class called default payment service that contains a final account repository, and then we have the constructor default payment service. So in the default payment service constructor, we are declaring also an object, or we're passing a parameter of type account repository, and like that, Spring will be automatically injecting this account repository bean. Then we have, for example, in case we have a repository, so we see that we have a JDBC account repository implements account repository. So then we have a final or private final data source, and then we have the constructor JDBC account repository, and we pass also a parameter, which is the data source, and then Spring will automatically inject that using the constructor. Also, for injecting beans, we can specify, or we can tell Spring which bean to inject. And for this one, we can use the annotation called qualifier. And here, let's see an example. So here we have a class called application config annotated with a configuration, and inside that we have two beans of the same type. So two beans are of type account repository, and we have a primary and a secondary. So this means that we will create two beans. The first one will be called primary and the second one will be called secondary. But these two beans are referred by type, which is the account repository. So here we can give a qualifier for each bean. So the first one we will call it, or we give it a qualifier primary, and the second one we will give it a qualifier secondary. And when we want to inject one of these beans, we can also on the class level, or for example the service level, let's say we have the default payment service and we want to auto-wire or to inject a bean of type account repository, and here we want to choose, or we can choose which bean to inject. So we can use again the qualifier annotation on the service or the object level. And as we can see in the default payment service constructor, we are telling Spring that we want to inject the bean that has the name or the qualifier called primary. So this is how we can use the qualifier annotation to inject the bean. Also, if we want to define a bean as primary, we can use the primary annotation to define which bean should be primary or should be prior or prioritized for Spring to be injected. So in this case, we don't need the qualifier annotation. So assuming again that we have the application config class configuration class, and then we have the same two beans, but now instead of giving a qualifier annotation, we can choose which is the primary. So for example, we have the account repository primary, and then we give it the primary annotation, and then when we want to inject a bean of type account repository, all we need to do is just to inject it using the constructor or the field and so on and so forth. And Spring will know automatically that the account repository bean, which is called primary, is prioritized bean, so it will inject that one. Unless we want to change, for example, we can give a qualifier, and then when we use the qualifier, so Spring will use that one over the primary. Field injection. So field injection allows direct injection into field declaration without constructor or method delegation. But here you need to note that this type of injection is discouraged because it makes testing of component in isolation more complex, therefore should only be used in test classes. And here is an example. We have the default payment service, which is a class annotated with the @service annotation, and then we have a variable or a field of type account repository, and then when using the auto-wired annotation, this means that we want to inject this account repository using field injection. Method injection. So the method injection allows setting one or many dependencies by one method. So it also allows for initializing work if needed while receiving dependencies. And here we see an example. We have our default payment service annotated with a service annotation, and then we have a method called configure class, which is of type void, and then we have two variables or two fields, which is account repository and fee calculator, for example, and assuming these two classes or these two objects are beans, and then all we need to do is to set the auto-wired annotation on the method level, and then Spring will understand automatically that we need to inject these two beans. So this is what we called method injection. Setter injection. So the setter injection follows Java bean naming convention to inject dependencies. And here we see an example. So assuming again that we have a class called default payment service annotated with the add service annotation, and then all we need to do is to declare our field and then use the setter method to inject this bean. So here we see that we have a public void set account repository, and then it takes as a parameter account repository, and then it's just a classic set method annotated with the @autowired annotation. So Spring will understand that this is a setter injection, and it will inject the field using the setter method. Now let's see the official recommendation for constructor-based or setter-based dependency injection. So I copied this from the Spring Core documentation, and you can see the link down here. So here, since you can mix constructor-based and setter-based dependency injection, it's good rule to thumb to use constructor for mandatory dependencies and setter for method or configuration method for optional dependencies. And here, like, you can read it on your own. And then here, the Spring team generally advocates constructor injection. So it's always recommended, and it's always better to use constructor injection to inject your beans into a class. Bean scoping. So first, let's understand what is a bean scope. So bean scope in Spring Framework refers to the life cycle of a Spring bean and its availability in the context of the application. So when a bean is instantiated or looked up, its scopes determines its life cycle and which other beans can interact with it. So the Spring provides multiple scopes to register and configure beans, and scoping has an impact on the state management of the components. Also, the default scope model is singleton, means one instance per application context. Shared instance will be accessed by other components. Therefore, components must be thread safe. So now let's see what are the bean scopes provided by Spring. So first of all, we have the singleton, and as we mentioned, it's the default. So this is the default bean scope in Spring Container. Only one instance of the bean is created, and all requests of that bean will receive the same instance. This is useful for beans that do not hold state, or where the same state is to be shared by all users or threads. Then the second one is prototype. So this means a new instance is created each time a bean is requested from the container. This is useful for beans to carry state that is specific to the to other user or thread, and thus can't be shared. The third type is request. So this scope is only valid in the context of web-aware Spring application context for a single HTTP request. A new bean is created for each HTTP request. Then we have session. So the scope is also valid only on the context of web-aware Spring application context of an HTTP session. So it's different from the request. So the HTTP request or the request scope is available for the HTTP request, and the session is for HTTP session. So this means a new bean is created for each HTTP session by the container. Then we have application. So this scope is also valid only in the context of web-aware Spring application context for the lifecycle of a servlet context. So this bean is scoped at the application level. And finally, we have WebSocket. So this scope is valid only in the context of web-aware Spring application context for the life cycle of a WebSocket. The bean is scoped at the WebSocket level. So bean scoping is really important if you want to correctly manage your bean. And as I mentioned before, by default, the bean scope is singleton. Now, let's see how we can define a scope for a specific bean. So whether we can specify it by name. So for example, let's say we have bean1 annotated with the bean annotation, and then we can give it the scope annotation, and then we just provide the name of the scope. Also, we can use the annotation to provide the scope annotation. For example, let's say session annotation. So we have a specific annotation for that. Personally, I recommend using the annotation to specify the scope, just to avoid mistakes or to avoid typos. Now let's talk a little bit about some special Spring Beans. So first of all, we have the bean environment. So the bean environment is an environment abstraction. So Spring provides an environment abstraction to decouple application code from the environment with the support for bean definition profiles that allow different sets of beans depending on the environment. For example, we have local environment, dev environment, cloud, prod, and so on and so forth. Also, it helps resolving properties for external sources. For example, database settings from the configuration file, or reading credentials from CLI arguments, and so on and so forth. Environment can also be injected into the code if needed. And now let's see an example. So here we have the application config class annotated with the @configuration, and then we can inject the environment bean. So all we need to do is to create or to declare a field of type environment and then auto-wired. And as you can see, we can get, for example, we have in this payment service method, which is a bean, we have a profile, so we can read or create a profiles of type cloud, and then we can say this.environment.accepts profile, and we can pass the cloud profile as an environment. And then, for example, we can also read some property. So all we need to do is this.environment.getProperty and then the property name. So this is how we can use this predefined bean. Then we have the bean profiles. So a profile in Spring is a named logical grouping that may be activated programmatically or set as active through configuration. So this feature is particularly useful when you have beans that should be active or registered and used in certain environments or conditions. For instance, you may have different configuration for development, testing, and production environment, and you want to make sure that certain beans are only used in one of these environments. This is how we can use this profile bean or the profile annotation. We can use it in 3 different ways. First of all, on a Spring component. So here we have the first one is the default payment service class, and I want this service to be only available for the profile cloud. Then we can use it on the configuration level. So I want this configuration to be scanned and applied by Spring only for the cloud profile also. Also, we can declare the profile on the bean configuration. So this means that a specific bean is only available for the cloud profile. Also, a bean can be active or activated programmatically. For example, let's see this code right here. So first of all, we create a variable of type annotation config application context. So this is our application context. So it's equals new annotation config application context. And then we have the application context and we have a method called get environment. And then we can set the active profiles. And then all we need to do is just to provide the profile name. Then we need, for example, if we have a different package to scan, so we set also application context.scan, and then we can provide the base package. And then of course, don't forget to refresh. So Spring will refresh its own context. And then, for example, we can get the bean which is available for this cloud profile. So we can get, for example, the payment service equals application context.getBean, and then we pass the service class. So also we have another different way to define the active profile. So using the properties file. So for example, we can use the YAML representation and it will be Spring profiles active and then the profile name, or using the application properties, which is also spring.profiles.active equals cloud. So in Spring Framework, the value annotation is used at the field level or method or constructor parameter level for expression-driven dependency injection. This annotation is commonly used for injecting values into variable in a class, whether they are primitives, strings, or complex types. These values can come from properties files, system properties, or they can be hard-coded. And here is an example how we can inject values using the value annotations. So assuming that we have an application config class annotated with configuration, and then we have, for example, we want to create a data source bean, and for that we need the URL, the username and password of our database. And assuming that these properties are stored in a file called database.properties under our resource folder. So first of all, we need to inject or to tell Spring from where we want to read these property sources, and for that we use the property source annotation, and then we provide the class path. So the class path will refer to the resource folder, and then we provide the file name. So it's called database.properties, for example. And then if I want to inject the URL variable or the URL property, which is called in my properties file jdbc.url, I use the annotation at value and then dollar and then curly brackets, and between the curly brackets is the property name. Also, the value annotation can also resolve dynamic expression to access other beans or well-known beans like, for example, system properties. So if I want to get a property from my system properties bean, all I need to do is to use the value annotation, and then I use the dash symbol, and then between the curly brackets I can use the system properties, and then I read the property called user.region, for example, to inject the default locale or to look up the default locale from the system properties. Let's see now some best practices for the Spring framework. So first of all, split configuration. So configuration class can be split into several classes. First of all, to avoid large configuration classes, and also to allow splitting classes based on architecture or other drivers. So the classes can import each other, or application context can be constructed with multiple classes. And here is an example. So for example, we have a first configuration class called service config, and this one, it will configure a bean of type payment service. We have then repository config, and this one, it will contain a bean of type account repository. And then we have a class which is also a configuration class called app config. And then for this app configuration, we need the service config and the repository config. And for that, we can use the import annotation to import the two previous configuration classes. So like that, we are applying the best practices, and we are splitting our configuration into multiple configuration classes, and then we can import only what we need. So like that, we will have a more maintainable code. Spring Initializer provides a simple web UI to configure the project to generate an endpoint that you can use via plain HTTP. All you need to do is to go to start.spring.io website, and you will have this user interface. So the service allows you to customize the project to generate the build system, and using, for example, Groovy, Maven, or Gradle. Also, you can choose the language, whether you want to use Java, Kotlin, or Groovy, and then you can choose the Spring Boot version that you want to use. So here, like at the time of recording this course, the most recent version, the stable one, is 3.1.0. And then we have a set of metadata where we can provide and give the information about the group ID, the artifact ID, the application name and description, and then the base package name. Then we provide the packaging, whether we want to package our application as a jar file or WAR file, and the recommended one is always to use jar file with Spring Boot. And finally, we have the Java version that we want to use. For example, for Spring 3, the minimum required version is Java 17. And if you want, for example, to use Spring 2.7 point something, you can use Java 11 or Java 8. So the project generated by the Spring initializer contains a Spring Boot application, and we will have a demo application.java. And then if you run the main method of this demo application, you will see an empty Spring Boot application starting at localhost and then the port 8080, which is we need for that case the web dependency at least to be able to run the Spring Boot application as a web environment. Spring Boot is an approach to develop Spring-based applications with very less or no configuration. It leverages existing Spring Boot projects as well as third-party projects to develop production-ready applications. It provides a set of starters, POM or Gradle build file, which can use to add required dependencies and facilitate auto configuration. Also, Spring Boot comes with a lot of auto configuration, so depending on the libraries on its class path, Spring Boot is able to automatically configure the required classes. Now let's see why we need to use Spring Boot. First of all, it comes with standalone applications, and also it comes with embedded servers such as Tomcat or Jetty, so there is no need anymore to deploy WAR files. Also, it provides opinionated starters, POM or Gradle, depending on your project configuration, to simplify the Maven or the project configuration, generally speaking. Spring Boot automatically configure the Spring framework whenever possible. Also, it provides production-ready features such as metrics, health check, and externalized configurations. And finally, there is no more requirements for XML configuration or any other type of configuration. It only needs configuration whenever it's required. First of all, let's start with creating a new Spring Boot project. So as we explained before, all we need to do is to go to the start.spring.io website, and you will have this nice looking UI where you can create a new Spring Boot project. So first of all, let's choose our dependency manager. So in this case, we'll be using Maven because personally I prefer Maven because I'm so familiar with the Maven structure and also the XML structure. Then we have the language. So we will be using Java as a programming language for our course. And then let's choose or let's select a Spring Boot version. So here, as you can see at the time of recording this video, the most recent stable version is the Spring 3.1.0, but we will be using the 3.0 point something. So make sure you use the version 3.0 because as for now, like the Spring 3.1 comes with some deprecations, and even for the future, I assume that companies, they will not migrate yet to the Spring version 3 or even the Spring 3.1.0. I will make a video explaining why you need to skip the 3.1.0. All right, so let's select the version here, and then let's provide the metadata of our project. So first, this is the group ID. So the group ID refers to the company, if we may say so. For example, let's take Meta, or like the old Facebook company. Now it's called Meta. So for example, for the group ID, it will be com.meta. So this is the company name. And then the artifact refers to the project or to the sub company. For example, here, let's say Facebook or Instagram or WhatsApp and so on and so forth. So here the com.meta or like the group ID refers to the company and the artifact refers to the project itself. So here I will say com.alibu. Let's use Alibu as a group ID, and here let's say example. Okay, so here it will automatically use the artifact ID as the project name. So let's also keep it example. And here you can also provide a description for your project. So here it's a demo project for Spring Boot application. So this is also fine with us. And also the package name is the concatenation of the group and the artifact ID. And of course you can update or you can modify the package name. And this will be the base package of our application. And then we have the packaging. What is the format or the package format of our final application, whether we want to use jar files, which is Java archive, or war file, which is web archive. And then we need to specify the Java version. Okay, so the Java version right here, if we use the Spring 3.0 point something or Spring 3.1, the minimum required version of Java is Java 17. Alright, so now after specifying this, we can move on and add dependencies. So as explained before, Spring Boot comes with a set of starters, and the starter is already a Spring Boot application, which comes with a lot of auto configuration, which will simplify our life of coding. So here we need to click on add dependency, and then we can filter or we can search for the dependency that we want to use. For example, if we want to create a web application or RESTful application, we can filter or we can search for web, and here you will see that we have the Spring Web Starter, and as the description says, build web including RESTful application using Spring MVC, uses Apache Tomcat as the default embedded container. So for now, let's say that we want to use web. So I will select this dependency, and also you can click and add more dependencies. So for example, if you need JPA, or if we want to implement a persistent layer on our application, we can choose Spring Data JPA, or for example, if we want to use Postgres SQL, we can also search for Postgres SQL, or for example, even for MySQL, and so forth. Okay, so for now, let's start with this simple dependency, which is Spring Web, and then we will see how we can even add manually a new dependency. So here you can either click on this explore button, and here you will see the project structure or the future project that will be generated. And as you can see here, we have the pom.xml selected, and I will explain this in the coming video. So now you can close this one and click on generate, and this will download a zip file containing the project that we already created. So now I will just place this one in my workspace. So it will be here, and then source code, and I will just save it here. So now I have my zip file downloaded. Now let's move on and open this file using IntelliJ. Now start your IntelliJ and then click on open. So if you have already open project, you will see a button right here called open, or all you can do is just go to file and then open. All right, so this will open a prompt right here, and then navigate to the location of your source code and then select the pom.xml. So here I have the example.zip file, which is I already unzipped. And as you can see here, we have this list of files and this src folder. So all you need to do is to select the pom.xml file and then click on open, and then say open as a project. And of course, trust this one and then start. So this will open a window like this containing the project structure that we see right here. And as you can see, we have this structure right here. So in the next video, I will explain everything. But before that, I want to show you something. So before we start exploring our project and checking the project structure, first of all, I want to highlight something, because so many of you have been requesting and asking the same question about the theme or the UI of my IntelliJ. So as you can see here, for example, if I select this file right here, you will see that it's really nice looking, and we have all these icons and so on and so forth. So this is part of the newest version of IntelliJ, and you need to go and activate this UI. So what you need to do, go to IntelliJ and then settings or file settings for Windows users, and then go to appearance and behavior. And here you will see that you have a menu called new UI, and it's in the beta version for now. So here you can click on enable new UI, and then you have this compact mode that you see in my screen right now. So like this, you will have the same UI as me, and this might be also helpful for you to have a better and a nice looking IntelliJ or nice looking IDE, and also it will be easier for you to follow what I'm doing right now. So I'm going to click on cancel, and now let's go back and explore our project. Now, before we move on, let me show you a few things that you might need to set up also your working environment, and in order to use IntelliJ in a good way. So first, let's click on File and then select Project Structure. And in here, you will see in the project, so here you see the SDK. So here you will have a list of SDKs that you can use within your project. So if you don't have, for example, the Java 17, all you need to do is to click, for example, No SDK, or you can click on Add SDK, and then you can click on Download JDK. So this will provide you a list of the available JDKs. For example, if you want, for example, let's say Java 19, and then you can select the vendor or the provider. So it's whether Amazon Corretto and so on and so forth. So you can select that one, and here you can keep the location by default. So IntelliJ will store it in its location, like the location that IntelliJ will choose. And then all you need to do is to click on download, and then you will have it in the list right here. So like this, you won't be prompted or like blocked if you don't have already the SDK or the JDK installed. All right. So this is an important step for you before we start coding or before we start diving into our code. So then click on apply. Once you download the SDK or change the version, just click on OK or apply, and then you will have your SDK ready to use. All right, now we can start to check out our project structure. So here, when you create a new Spring Boot project, you will find this idea it's called idea folder, which is automatically created by IntelliJ. So we can just ignore that because it depends on your IDE. You will have this folder right here. And then we have this .mvn folder that contains a wrapper. And then we have this maven wrapper.jar and maven wrapper.properties. So this means that you really don't need to download manually and install manually Maven, because when you create a new Spring Boot project with using Maven, so it will create, or it will download automatically a maven wrapper.jar file, and you can use this one in your command line to run some commands. And we will see that later on how we can use this maven wrapper, because for example, for my machine, I did not install Maven on my machine. So I always use the Maven wrapper provided by the Spring Boot project. And I would say this is a good approach, because like that, you are not depending on a specific version which is installed on your machine, but you depend on the version which is provided by the Spring Initializer. So then we have this source folder, which contains two main subfolders. We have this main and we have the test. So first of all, let's check the main folder. The main folder contains also two subfolders. We have first of all this Java folder, where we will have all the Java files of our applications. All the classes and objects of our application will go into this Java folder. And then we have the resources folder. So the resources folder contains two subfolders, static and templates. So the static is, for example, if we want to put some static files like HTML files, or we want to build, for example, a UI for our REST API that we will be building. So we can move or put all the files in here, but I really don't recommend that, because we need to think REST. Okay, so we need to have a REST API, and then if we need, we can create a front end using any front end framework. And then we have these application.properties files. So by default, it has the file extension properties, or we can also use YAML representation. So the difference between properties and YAML files is just the representation and the way we write things. And the application properties will hold all the properties that are needed by Spring Boot, or even custom properties that we want to read from our application. Okay, so now let's go back to this com.alibu.example, and as you remember, this is the base package, or the concatenation of the group ID and the artifact ID. So here we see that we have this example application, which is a simple class with just a static void main, and it contains a Spring Boot application annotation. So this will be the main class for our application. So if you want to start the application, all you need to do is to run this file by right clicking and then run example application, or just clicking on here, or also clicking on this button right here. So you have multiple ways to run the application from your IDE. Then we can move to the test folder. So this test folder, this is where we have all the test files that we will create. So all the unit tests, all the integration tests, all the end-to-end tests that we want to create for our REST API, they go to this test folder. So next, let's have a look on the pom.xml file. So the pom.xml file looks exactly like this. I'm going to make it full screen. So if we start from the beginning, so here's just providing or specifying the XML version. And here, like we provide also the project and the XML namespace, which is Maven Apache org, and so on and so forth. So this is some information that you need, and also the schema location, and so on and so forth. And also this is the model version of our project. And then we see here that we have a parent tag. So the parent tag contains also group ID, artifact ID, version, and a relative path. So this parent means that this Maven project extends from this parent. Okay, so this means that this Spring Boot application extends already the Spring Boot starter parent, having the version 3.0.7, which we already specified and selected in our Spring initializer. And then we have the group ID that we specified, which is com.alibu, and the artifact, which is example. And then we have a default version, which is 0.0.1-snapshot. Snapshot means it's still under progress, or like in progress. And then we have the name, which is, we mentioned before, it takes by default the artifact ID. You can also change it. And then we have the description. All right, and then it comes a tag called properties, and here we can provide a set of properties for our application. So here, for example, we have this java.version, and we are specifying that we are using the Java version 17. After that comes the most important part, which is the dependencies. So we see that we have a tag dependencies, and this is a list of dependency. So here we see that we have this dependency tag. So also here we provide the group ID and the artifact ID. So for example, here it's org.springframework.boot, and the artifact is the Spring Boot starter web, which is the dependency that we added when we created our project. And also by default, when you create a new Spring Boot project, you will have always provided dependency, which is the Spring Boot starter test, and the scope of this dependency is test. So this dependency will be available only when we run the tests. Also, there is something which is really important in here when we use Spring Boot. So Spring Boot really makes it easy to manage versions. So here we don't need to provide any version, because here if we check, we have already a property called version, and we can provide any version that we want. But when we use Spring Boot, we don't need to provide the version, because it will automatically extend the parent version. So this, in case of an upgrade or a downgrade of the Spring version, you don't need really to worry about the Spring Boot starter's dependencies. All we need to do is to update this one, refresh the project, and then we will have our project totally and fully migrated to the new version that we provided. All right, so this is the application. So now let's start our application and see and try to analyze a little bit what we have. So first, just click on this button right here, or this play button right here, and run example application, or right click on this file and then run example application, or select the file from here, right click, and then run this application. So it's up to you to choose the way that suits you the best. So here, let's analyze a little bit what we have. So here we see that we have this banner right here, and I will show you in a few seconds how we can also change that. Then we see that we have a bunch of logs. So here we have a list of info logs. And as we can see here, starting application using Java 17 with process ID something. And here also we see that we have no active profile set. So then later on, we will see how we can work with profiles. So here, falling back to one default profile, which is called default. And even if you don't provide this profile name, it will be selected by default. Then we see Tomcat initialized with port 8080, starting service. And then we see that we have started example application in 0.5 seconds. and then the application or the Tomcat already started on the port 8080 with a context path which is empty. All right. So now this is not the most important part. First, I want to show you how we can change this banner right here and to make our service or our application looks really nicer. First, let's go to our browser. And here, this is a cool website that I really like, or even you can just Google text banner generator. I will leave you this link in the description of this video. And then, for example, if you type something, let's say Alibu, and then we can choose the font. So here I will choose this one. So I prefer this one, this ANSI regular, or you can use also ANSI regular with shadow. And you can use, like, you can play with it. You can change the character width, you can change the spacing, and so on and so forth. Okay. So here, for example, if we change it to full fitted, you will see that it will change and it will be different from one the other. So once you generate a banner, just click on select and copy. So this will copy this text to the clipboard. Now let's go back to our application. And also I will stop the application right now and reduce this. And now in the resources, so Spring will automatically scan and look for a file called banner.txt. So I will create a new file right here and I will call it banner.txt and I will just paste the content here. Okay. So now if I restart my application, we will see this banner showing up instead of the old one. So here, maybe I will change a little bit. So let's say Spring Boot 3.0.7, just something like that. And here, maybe let's say, all right, let's just adjust a little bit the spacings. And now let's start our application. So now, instead of the old Spring Boot banner, we see that we have a new banner, which is Alibu. And we generally use the banners to give the service name. So when we start the application, we know which service or what is the service that we are starting right here. So as you can see, we have this Alibu and we have the Alibu and then the Spring Boot version, for example, and so and so forth. Also, we have the same logs as we had before, and the application again is started on the port 8080, but which is the default one. And we have also the application started, the example application Java file in few seconds. So let's create our first bean class. So here in the package com.alibu.example, right click and then new and then Java class, and let's call it my first class, for example, or my first component or my first service. Just you can call it whatever you want. So in this my first class, I will just create a public string. It's a method that will just say hello. So this method will return hello from the first class or from my first class, for example, just to know where the message is coming from. So now in order to use this first class and call this method called say hello, what we need to do, for example, let's go to our main method and here let's say first or my first class, let's call it my first class equals new my first class. So all we need to do is to create an instance and then I will use system.out.println just to print out the message. So I will use my first class instance object and then I will call the method say hello. So now if I run the application, we will see that here we have the message hello from my first class. But this is not really recommended when we use the Spring framework because we are not using the power or the core feature of the Spring framework, which is dependency injection. So to do that, let me show you how we can transform this my first class or this simple class to a Spring Bean. So now going back to our example application class file, and here I will create a bean. So this is a bean annotation, and then I will do public my first class, and I will call it, for example, my first class. Okay. And then when I need a bean of type my first class, I need to return a new instance or new my first class instance. All right, so I will just keep this line right here. Now let's see how we can, if I remove this one, so if I remove the instance or the manual creation of the my first class and delegate that to Spring, so Spring will be able to inject and create a bean of type my first class. Okay, so now first of all, let's see what this run method is able to return. So this run method will return a class or an object of type configurable application context. So I will just assign this one to a variable and I will call it context, so CTX, just as a short name. So when we run our application, it will return a context, which is the context of our application. So here, my first class, now I want to get the my first class from the context or from the application context of my Spring container. So here I will just go equals and then context dot get bean. So I have a method called get bean. So actually we have four or five methods of type called get bean, and the first one, for example, it takes a class, then we can pass a name and the required types. Also we can pass the required types and object, or just a string, or just a string name and the object arguments. And the arguments, for example, if I say, or if for example I need a string for or to instantiate my class, and so on and so forth. So it's any parameter or any field required in order to create an instance of my object. But in this case, we can use whether the first one, which is just passing the class, or we can use the second one, which is passing the name and the required type, so it will transform it automatically. Or we can use also the get bean with a parameter string name, but after that we need to cast the object to the required class. So here, since I already know the return type or the type of my bean, I will use the first one, and then it will be just my first class dot class as a parameter. All right, so here, as you can see, I did not do anything, or I did not create a manual instance for my first class object. I just created a bean or transformed this class to a bean, so it will be fully managed by the Spring framework. So now all I need to do is just to restart the application and see if it still returns the same output or not. So as we can see here, we have always hello from my first class. So now this is the first way, or like this is how we can create a bean. Now let me show you a different way how we can also tell Spring that this is a bean. So now if I remove this bean annotation, or even if I comment out or totally remove this method right here and try to run the application, let's see what will happen. So first we have an exception, and the exception is saying no such bean definition exception. So this means there is no qualifying bean of type my first class available in the application context. So we are not able to get or to look up a bean of type my first class. So why? Because we just commented out this bean annotation. So when the application starts, Spring will not be able to find or to instantiate a bean of type my first class. So we said, or I mentioned before, that I will show you a different way or a second way how to use or how to declare a bean in Spring. So now I will just stop the application for now, and then to mark a class as a Spring bean, all I need to do is to add an annotation. So this annotation, I can use the component annotation that we already spoke about before. So when I use a component, automatically Spring will consider this class. So when the application starts up and Spring starts scanning all the packages and all the classes, each time it will see this annotation, it will consider the class as a Spring bean. So now all I need to do is to restart my application. So here, if I restart my application, we will see that we no longer have the exception, and we see the hello from my first class. All right. So now let me also show you the other annotations that we can use the annotation service and the annotation repository, which are a refinement of the component annotation as we mentioned before. So whether using, for example, service, and if I restart again, so we see also that the message is showing up and the application starts with no issues. And also if I go to the definition of this service and then click on download source to download the source code of this class, so we see right here the first thing, this is like the public interface service, and then this annotation or this interface class is already annotated with the add component. So in a different way, the service annotation already extends the component. So both of them are the same thing. So here, as also mentioned in the documentation, you can also see component and repository. So it's the same way if I use also a repository and I go to the documentation, I will see also that it's a component. All right. So whether using service or a component or a repository, these are markdown annotations to mark an object or a class as a Spring Bean. So I will bring it back to service. If I start again the application, so I will have my bean, and I will also be able to display the message that I already returned in here in this say hello method. As mentioned before, splitting the configuration is one of the best practices. So first let's start with a cleanup. So I will remove this service annotation and I will optimize the import to remove the unused one. So also if I use a shortcut, you can use a pop-up right here telling you what was the shortcut I used to do such action. So now I will go back to my example application right here, and then I will open the project and I will create a new application config class. So I will call it application config, and then I will just take this bean declaration and move it to the application config. So now I will bring back this bean annotation and of course import it. And then don't forget to add the configuration annotation to your class, so Spring will scan this class at the startup. So now the application configuration is ready to use. And again, if I start my application, I will see that everything is still working as expected. So we see here that we have the hello from the first class. So now I will also optimize the imports right here. So whether you move it manually or use the shortcut Ctrl-Alt-O for Linux and Windows, or Option Ctrl-O for Mac users. Now let's understand the bean naming in Spring application context. So here, as we mentioned before, to get a bean, we can use the class or the object class, or we also can use another method which takes the bean name and the required type. So for example, here to get this my first class, and just to remind you that in the application config we created a bean, we gave it the name my first class. So if I copy this name and I go back here and pass the bean name as parameter and I run the application, so Spring will also understand that we are looking for this bean. So for example, if I change this one to wrong bean name and I restart the application, it will tell me that there is no such bean. Okay, so no such bean definition exception, and it says that we don't have any bean named wrong bean name, because by default Spring will use the method name or the method that we created here and we annotated as a bean as the bean name. Okay, so now let me bring this back, or let's see a different way how we can name a bean. So here we have a bean, and for example, let's call it my bean. And now Spring, when it scans and declares this class as a bean, it will automatically give this Spring bean or this string bean name as the bean name. So I will copy this one and now I will use it instead. Okay, so if I rerun the application, we see that the application is running, and now we are using, or we are showing the message coming from the say hello method of my first class bean. Okay, so now this is how the bean naming works in Spring Boot. Also, if I go back again and just remove this parameter right here, and for example, I change the name to my first bean, so I can use here my first bean as a bean name, and I can just run the application and it will show the message that we already have in our say hello method. All right, so now let's move on and see more things and more features about how to manipulate and work with Spring Beans. Now let's extend a little bit my first class bean. So here, first I will create a private variable. It will be a string, and let's call it my var, for example. Okay, and now I will add a constructor parameter. So I'm just using shortcuts again so you can see it in here. So here I will select the option add constructor parameter, and then it will propose what will be the variable and say do refactor. And as you can see here, we have a constructor having a string my var, and then this dot my var equals var. And just I will adjust the say hello, so it will be hello from the first class, and then let's, for example, display the my var. So it will be my var equals, and then just my var. Okay, so now we see that we have already one problem. So what we need to do, we need to go back to the application config and pass this my var as a parameter. So here, let's say first bean. And now if I run the application will be running correctly, and it will display here the variable or the value of the my var that we passed to this my first bean. Okay, so it says hello from my first bean class or my first class, and my var equals first bean. Now let's move on and dig more and explore more how we can work with beans. To better understand dependency injection, let's start by preparing the ground up for it. So first I will create a new class and I will call it my first service. So my first service as a class, and this one I will mark it as a service. And then for this my service, I will just create a method. So I will do public string and then say message or tell story, for example. So this tell story, it will just use one of the existing services or the existing beans that we have, which is the my first class in here, to just display the message or like to make a call to the say hello method. All right, so here I will just first need to inject a bean. So all I need to do is to create a private my first class, and I will call it my first class. So I will make this one full screen, and then I will just return. So the bean is saying, or like let's say the dependency is saying, and then I will just concatenate the my first class dot say hello method. Okay, so when I run this class and I run this tell a story, I expect to have an output in my console telling that the dependency is saying, and then we have the hello method or the say hello method that we have right here. So now let's move on and understand in deep the dependency injection and the different types of dependency injection. Now, if we go back to our example application class, and here let's do some changes. Instead of my first class, I will just try to inject my first service, and I will just rename this one to my first service as a variable name. And then I will tell Spring to get bean. I can also remove the name, and instead of my first class, I will just change it to my first service. And here I will just call the tell story. Okay, I will just rename this one. So it's service. And now if I run the application, let's see what will happen. So here we have a null pointer exception in the my first class dot say hello. Okay, so if I click to check the trace, so the my first class is null. Okay, so now I will rerun again in debug mode. So I will just add a breakpoint right here, and I will make later on a special video how we can debug in details. So now just click on this debug example application. And then when the example application here, so first we start by running the application, and then we look up or we try to load the my first service bean, which is already a service right here. So that's why we are able to load the bean. And then we try to call the my first service.tellStory. And this is when the breakpoint hits. Okay, so we are trying to concatenate this string with the string coming from the say hello method. So as we can see here in IntelliJ, we have already a null pointer exception because the my first class is null. Why it is null? Because it's not yet injected by Spring, because we did not tell Spring how to inject this class. Okay, so that's why we have our null pointer exception. So let's resume the program. And now if I go back to the console, we see again we have this null pointer exception. So now let's see how we can inject a dependency using the constructor. So all I need to do here, I will use the auto completion and or the code generation, and I will ask IntelliJ to create a constructor using this my first class. So here I just asked it, and now it also IntelliJ is recommending to make my first class final. So we also add this final keyword. So now all I need to do is to add the keyword auto-wired, and this annotation needs to be on the constructor level. So like that, when I start the application, Spring will know that we need to fetch a bean of type my first class, the one that we declared right here, and it will be assigned to this my first class. So since here in our application config, we have a bean of type my first class, Spring will know that this is a bean, and then the my first service needs this bean to be injected. So it will automatically inject it. So now let's just restart the application. And now I will just restart it not with debug mode. And here we have the magic. So here the dependency is saying hello from my first class, and the my var equals first bean as we specified in our application configuration right here. So now I guess you are able to link things. So this is how constructor injection works. Now let me show you a little bit of enhancement that was introduced by the Spring framework. So now if I go back to my first service, I can also remove this breakpoint. Here with Spring Boot, if we have or if we want to use constructor injection, we no longer need the auto-wired keyword. I will also optimize the imports. So we no longer need the auto-wired keyword or annotation, because Spring, it will try to inject anything that is injectable. So when the application starts and Spring start creating this my first service bean or service, it will first see that in the constructor we need an object of type my first class. Okay, so it will look up in its context if it finds a bean of type my first class. If yes, it will inject it. So now after removing the annotation, I will rerun again the application and make sure that everything is working fine. So here, as you can see, we no longer need the auto-wired annotation. So this is how constructor injection works. Now I will go to my application config and create a second bean of type my first class. So I will duplicate this one and I will call it my second bean. So this my second bean, I will pass a parameter, I will call it second bean. Okay, so now I have two beans of type my first class. Now if I rerun the application and try to fetch or to display the message in here, I expect things not to work. And even IntelliJ is able to highlight this. So if I highlight this one, it says could not auto-wire, there is more than one bean of my first class type. And this is what will happen or what will be displayed in our console. So I will run the application. And here we see that we have application failed to start, and it says parameter 0 of constructor my first service required a single bean, but 2 were found. Okay, and here it gives us more details. So we have my first bean defined by method, so defined by method, my first bean in class application config, and we have the same for my second bean. So also it gives us some actions. So consider marking one of the beans as primary or use qualifier. So this introduces us to the qualifier topic. So now what I will do, I can just come here and add a qualifier annotation. And for example, I will say bean1. I will copy this. And here I will say bean2. So I have the first bean called bean1 and the second bean has a qualifier called bean2. So this qualifier doesn't mean that the bean will be called bean1 and bean2. No, the bean will stay my first bean and my second bean of type my first class, but as an extra information, we will give it a qualifier called bean1 and bean2. Now, if I go back to my first service, I can just come here and add a qualifier information to this bean. So for this bean here, I will just tell it to use the qualifier, for example, bean1 or bean2. Okay, so let's use bean2 because before we used the bean1, and here let's just make sure that we have second bean as a variable. All right, so now Spring will be able to locate or to load or to inject the correct bean using its qualifier. Okay, so now if I run the application again, so we see that we have the message, and now the variable, my var, has a value second bean, which is this bean right here. Okay, so this is how we can use qualifier to inject a specific bean if we have multiple beans of the same type. So as this example right here, we have two beans of type my first class. So now we just give it a qualifier for the first bean and a qualifier for the second one, and then Spring will be able to locate and decide which one to inject. Also, when working with beans, we can tell Spring which one to inject first. So instead of using qualifier, so I'm gonna remove this qualifier from here, and then I will go back to my application config, and I will also remove these two qualifier annotations. So for example, let's say that I have a third bean right here. So I will just duplicate the code and I will say this is my third bean. And then I want Spring, for example, to inject this third bean. So I will just change also the text here. So all I need to do is to use the primary annotation. So this primary annotation will give a higher priority to this bean called my third bean. Now, if I go back to my first service, we see that the highlight from IntelliJ is already gone, because Spring will know that there is a higher bean of these three beans which are of the same type. So when this service, my first service, needs a bean of type my first class, it will look up all the beans and it will choose this primary bean as a higher priority bean, and it will inject that one. So now when I start the application, I'm expecting to have this third bean printed as an output. So as we can see here, we have this dependency is saying, and the var now is saying third bin. So this comes from this primary annotation. So like this, we can define a priority or higher priority to our beans. Now let's see dependency injection using field injection. So I will keep my configuration as it is. I will keep my third bean as a primary, and I will go back to my service. Now I'm gonna remove the constructor. So I don't need the constructor because I will use field injection. So to inject a dependency using the field, all I need to do is to add the auto-wired keyword or the auto-wired annotation to the property or to the bean that I want to inject. Also, already you can see right here that it's already also highlighted, and field injection is not recommended. As I explained before, it's always recommended to use constructor injection or setter injection over field injection. So also the Spring advocates, they always recommend using constructor injection. So now if I start the application, I will get the same output telling third bin. So as we can see right here, so now it's telling third bin. Also, we can mix this in the field injection. We can mix with the qualifier. So here, I will just comment out the primary. And now I will show you how to use qualifier even without having the qualifier name or the qualifier annotation on the bin declaration. So here we see that we have 3 bins, and now I will use the qualifier keyword or the qualifier annotation, and all I need to do is to provide the bin name. So the qualifier will use or will try to look up the bin by its name or by its qualifier name if we provide it. So for example, if I want to use my second bin, I will just copy the method name, because as I mentioned before, when we don't provide a bin name, it will take the method as a bin name. So now I will go back to my first service and give it my second bin as a qualifier. So if I restart the application, I'm expecting to see this second bin. So this is what we see already in here. So the field injection also works with qualifiers, and also qualifiers, we don't need to provide them on the bin level. All we need to do is to use whether the method name or the bin name if we provide it. So for example, if I give a name to this bin, so let's call it, for example, bin 1. And then I will copy this name and I use it as a qualifier, and I restart the application. So here we see that we have first bin instead of bin 2, because the qualifier will be also using the bin name. The next type of dependency injection is method injection. So I will go back to my service right here, and I will remove these two. I will just do Command X to keep them in my clipboard, and I will create a public void method, and I will call it init or inject bins, for example. Inject bins or inject dependencies. So this inject dependencies, it will take as parameter my first class. So here my first class, and I will call it my first class. And then all I need to do is this dot my first class equals my first class. So now all I need to do is to add the auto wired annotation. And here, of course, because we have 3 bins of type my first class, so I need the qualifier keyword right here. So I will just remove this one. And for example, let's say I want to use the qualifier bin 1. And now when I start the application, this method will inject the needed or the required dependencies. So let's try it out. So here, as you can see, we have the message, and here we have first bin. And for example, if I switch to the second one and I use this qualifier with the my second bin and restart the application, we will see that it will print out second bin, and it will be the same if also I change the other one. So here what happens is Spring, when each time it sees that we have this auto-wired annotation, it will try to use that one, whether it's a simple method, a setter, or a constructor, in order to inject the necessary bins that are required for this class. The final type of dependency injection is called the setter injection. So all we need to do is to create a set method for our dependency that we want to inject. If we have multiple, we need to create a setter for each. So here, for example, if I say set my first class, and also I need to provide the auto-wired method. And of course, here we need the qualifier because we have 3 bins of type my first class. And like this, it will be using the setter method to use or to inject this my first class bin. So now if I restart the application, I will see that I have the correct output that I'm expecting. Also, if I switch to bin 1, for example, it will print out first bin instead of second bin. So this is what we see if we restart the application, and here we have first bin. So this is the final one, and this is called setter injection. Also, as I mentioned before, always use constructor injection because this is the best way and the recommended way by the Spring advocates to inject beans or dependencies into a class. As explained before, Spring also provides some special beans. So for example, we have the environment bean, which is a bean that helps us to read some environment properties, some environment system, and also access the application properties and read the properties from there, even reading the command line arguments. So let me show you how we can read the environment or the system properties using this environment bean. So first I will create a private environment and I will call it environment. For that, I need, of course, to create a setter and add the auto-wired keyword. So here I will add auto-wired. So this to inject the environment bean into my first service class. And then I will just create a method. I will just duplicate this one and I will call it, for example, get Java version. So I want to return the Java version used for this project. Okay, so I will remove this one. And then all I need to do is environment.getProperty. And then I know that in the system properties, I have a property called java.version. And now all I need to do is to go to my example application where I have the main method, and I will duplicate this one. And here I will just get Java version. So now if I run the application, we will see that the application will print the Java version. Okay, so here we see that the Java version that I'm using is 17.0.6. For example, if I create another method, let's call it getOS or getOS name. So I want to return the operating system name. So it will be os.name. So this is the property to return the operating system name. And then I will also just display it right here. So I will use or call the method getOS name, and then I will restart the application, and I'm expecting to see the operating system name, which is for my case the macOS X. The environment bean is also capable of reading any property defined in our application properties file. So for example, here if I go to application properties and I will create a random property or a custom property, so it will be my custom.property and I will give it a value hello Alibu students, for example. Okay, so now this environment bean will allow me or can help me read the property from the YAML file. Okay, so here all I need to do, I will create a new method. So I will call it read property or read prop, just to say property. And here I will just copy this property name and I will paste it here instead. Okay, so now I will go back to my example application.java and I will duplicate this one and I will just call the read prop method that I just created. So here if I start the application, let's see if Spring is able to read it or not. So it's the case. So here we have hello Alibu students. So this means that this environment bean will try to read all the properties, whether from the system or even if we provide an application or a property declared in our application properties. So it will understand and scan also these application properties, and like that we can read this custom property. Before we move on, let's clean up a little bit what we created. So here I will remove the environment since we already saw how it works. So I will remove all this code and then I will just move this to the bottom, or I will create or inject it in a constructor. So I will add the final keyword here and then I will say add constructor parameter. And here I will also provide the qualifier name. So for my bean, so it will be qualifier. And then for example, let's say bean1. So this is one of the beans that we have. So this is my constructor and I have now tell the story. So I will go back here. I will just remove all this. So now I will go back. Also, I guess we need to optimize imports, but yeah, I guess I already did it. So now we have our code cleaned up and now we can move on and see what comes next. Now let's assume that we have another application.properties file where we are storing some custom properties. For example, I will create a new file right here and I will call it custom.properties. So in this properties file, I will create, for example, my prop, okay, equals Alibu, let's say, okay, just an example. Now I want to inject this my prop into my first service. So normally, now you get it. If we want to do that, all I need to do is here. So here I will say my custom property from another file. And then I will use the value annotation. And for the value annotation, I just need to use this my.prop as a property name. Okay, so here I will just paste this one. And now let's create a getter method for this one. And now let's go to our example application and try to read this one. Okay, so from another file, if I start the application, so here we see that we have an exception saying that could not resolve placeholder my.prop. Okay, so we are not able to resolve the property or the placeholder called my.prop because it's not in our application.properties file, because Spring is able to scan only a file called application.properties or .yaml. So now how to provide or how to tell Spring that I want to read properties from a different file. Okay, so all I need to do, I need to go to the class level right here, and here I need to use an annotation called property source. So here we see that we have property source and property sources. So I will use the first one, and here I need to provide the class path. So I'm going to make it full screen again. So it's class path and then custom, because we call the file custom.properties. Okay, so now if I run the application, let's see what will happen. So we see right here that we have this message from the previous implementation, and then we have hello Alibu students, because the hello Alibu students is coming from the application properties, and also we have this int which is 123, and now Spring is able to read the custom property from this custom.properties file, because here in this class we told Spring also to load the properties coming from this file right here. So if we provide a wrong file name, of course we will get an exception. So now let's duplicate this one. So let's say custom file 2, for example, and here let's say my prop.2, and here let's say hello Alibu. Okay, so now I can inject multiple files. So here, instead of using property source, I need to use another annotation. So it's just property sources, and this property source, it takes a table of type property sources. So here I will provide the table. So it will be a property source, this one, and then the same again, but here I will call it custom-file-2. Okay, so here I will duplicate this one. I will call it read property from another file 2, just an example. And here I will just move the value and make prop.2, because this is the value or the property that we want to read. And then all I need to do now, just to test this one, I will create a getter for this method. So now if I go back to my main class and duplicate this one and use the 2. Now, if I restart the application, let's see what will happen. So here we have Alibu coming from the custom.properties, and we have hello Alibu coming from the custom file 2. So in this way, we can inject multiple property sources, and we can tell Spring to use that one to load the properties that we need. What we will see now is how we can inject a property from our application properties into our Java class. So for example, let's say here I have a private string custom property, and I will just create a getter for this custom property. Okay, so here create a getter for custom property, and I will use this get custom property just to display this custom property in my main class. So here I will just use get custom property. If I run the application right now, so by this custom property, I want to read this one. Okay, so what we see right here, we have a null value because we did not tell Spring how to read or that we want to read this custom property. So I will close this one. Now I will go back to here, and then what we can do in order to inject a value from our application.properties file into a variable, whether it can be a string or an integer or something like that. So we can use the value annotation. Okay, and the value annotation, it takes as a parameter a string, which is the value. So the value should be in this way, dollar and then curly brackets, and inside the curly brackets, so I can use my custom property. So like this, when the application starts up and Spring starts initializing the beans and the components, anytime it sees that we have a value annotation, it will try to read this property from the application.property or the application.yaml file. So now if I restart the application, I'm expecting to see the message coming from here. So it's hello Alibu students. For example, let's go and let me show you that we can inject also other values. So here I will just duplicate my custom property, and then I will say it's an int, and here for example let's say 1 2 3. Okay, so now if I go back here and I will just duplicate this one and I make it as an int, and here I will say it's an integer. Okay, so I'm gonna make this full screen, and then I will also use the same value annotation, and here instead of property I will say .int, because this is what we created in here. And now I will create a get method for this one. So create getter for custom property int, and here I have the get customer property int. So here again I will just duplicate this one and call this int. So this is just to show you that Spring is able to convert types. So if I restart the application, we see that we have Alibu students and 1 2 3. And for example, if I do 1 2 3 and with a string and restart the application, let's see what Spring will do. So here we see that we have a number format exception. So here Spring was not able to cast this string to an int. Okay, so you need to be really careful with that. So if you it depends on the property that you want to inject, you need to have the correct or the exact type. Spring profiles provide a way to segregate parts of your application configuration and make it available only in certain environments. They can be used to apply certain bean definitions conditionally. For example, different beans might be registered in development environment versus a production environment. So each profile corresponds to a set of configuration that define how the application should run in a specific environment. So an environment might be a development, test, staging, production, or another similar concept. The beans that are part of a profile can be registered in the Spring application context only when the profile is active. This capability can be particularly beneficial in several scenarios. For example, in environment-specific configuration, you might have certain beans that should only be active in development environment and different ones that should be active in a production environment. For example, in a development environment, you might want to use a bean that clears and recreates your database with this data every time you start your application. In a production environment, you would certainly not want this bean to be active. Also, profiles can be used for component switching. You can use profiles to switch out entire component or services. For example, you may have a quick in-memory database for development, while in production you would use a full-blown database server. Also, profiles can be used for toggling features. Profiles can be used to enable or disable features. If you're developing a new feature that's not quite ready to be deployed in production, you can put this in its own profile until it's ready. And in the next part, we will see how we can work in action with profiles. Let's see now how we can work with profiles on the level of the application properties. So for example, here we have our application.properties containing two properties, my custom property and my custom property int. So now in order to create a profile specific application property, all we need to do is to create another file called application-profilename.properties. So what I will be doing, I will copy this one and then paste it. So here, let's say, for example, I will call it dev. So this application-dev properties will be available or will hold all the information for the profile dev. So here in this application-dev.properties, I will change a little bit the values. So here, hello Alibu students in dev environment. Okay. So here, let's keep this one, or let's make it 3 to 1. So in order to see the changes. Now, let me show you how to run or how to set a specific environment while running the application from your IDE. So here, click on this arrow just to have the list here, and then click on edit configuration. And then you see this is the configuration of your main class. And then we see here that we have active profiles. So here we can set multiple profiles to be active at the same time. Okay, so now I want to set my profile or my active profile to dev, and then click OK. So here, Spring, when the application starts, it will see that we have an application properties. So first of all, it will be loading all the information in the application properties, and then it will set the active profiles to the dev. Okay. And then what Spring will be doing, it will be overriding all the properties which are similar in the application properties and the application dev.properties. So here, let me explain it. So at the application startup, Spring will load all these properties in its context, and then it will see that it has an active profile, and it will check that this property already exists in here, so it will override the value using this one. Okay, so now let's go back to our main application, and we know that we have already something to display this property. So all I need to do is to simply run the application, and here we see that we have hello Alibu students in dev environment, and also we have the value 3 to 1. So again, if I stop the application and remove the active profile from this configuration right here, click OK, and then if I run again the application, it will be displaying hello Alibu students, as you can see right here. Also, we can change the profiles using the application properties itself. So here in the main application.properties, so also I want to highlight something. It is always recommended to have an application.properties that holds all the common properties of your application, and then you can change and override all the properties depending on the environment. So here in the application.properties, we can also tell Spring which profile we want to be active. So here, all we need to do, let's put it in the first line. So here we have a property called spring.profiles.active, and here this spring.profiles.active accepts a list of profiles with comma separation. But in our case, we want to set the dev environment as our active environment. And that's all. Now, if I run the application, we will see that Spring will, our application will be displaying this message instead of this one. So let's try it out. So if I click on start the application, and then we see that we are displaying this. Also, let me show you how it will be displayed in the logs. So here we see that Spring is detecting that we have one profile active. So it says the following one profile is active, which is dev. For example, if I set another profile, or let's say test, for example, and custom. All right. And if I restart the application, even if we don't have these environments or these application properties specific for the environments, it doesn't matter. So Spring will not block the application. Spring will not throw any exception if it doesn't find any properties for that environment, because the environment is the developer responsibility. So when you set an environment here, or if you set an active environment, make sure that you have the properties or like the necessary properties and configuration for that environment. So here in the logs, we see that the following 3 profiles are active: dev, test, and custom. So here, let me show you also something which is really important. Now, I will just duplicate this dev properties and I will make it test. So since we already set an active profile test, so here I will just say for the test in test environment. So I just want to show you if the order matters or not. So now all I need to do is to restart my application, and here we want to focus on the output of this one. Okay, so let's restart the application. So here we see that test environment. Okay, we are displaying the properties from the test environment, and here how it works. So let me show you in a different way. So I will set test first, and then dev, and then I will remove test from here, and I will restart my application, and let's see what will happen. So here we see it's displaying in dev environment. So here Spring, first of all, it will start loading the properties from the application.properties, and then it will check the first profile, and then it will override all the properties that can be overridden, and then it will check the next one, and again it will override the properties, and so on and so forth. So you need to really be careful about the order for the profiles. And also this information can be useful for you in case, for example, you set some active profiles and you see that a property is not correctly overridden or is not correctly set. So you may want to check the order of your properties. The active profile can also be set programmatically. So let's do this. I will comment out this property so it will not override our configuration, and I will close all this. And then I will go back to my example application in our main method, and here I will externalize a little bit. So here I will create a variable app equals new Spring application, and for this Spring application I will just pass the example application.class, which is our main class. And then all I need to do here is switching app.run, and we need to remove this. So here after getting the application or the Spring application, what we can do, we can say app.set default properties, and for this property we need to pass a map of type string and object. So we can use collections.singleton map, and here we can pass the key and the value. So the key is the property spring.profiles.active, and the value is, for example, let's say dev. Now if I run the application, we will see that it will display Alibu students in dev environment. And again, if I switch it to test, since we have also our application test.properties, and then if I rerun again, I will see student in test environment. So this is how we can programmatically set the active profile in our Spring application. Next, we will see how we can also have beans which are available only for a specific profile. Now let's see how we can make a bean available only for a specific environment. So let's go back to our application config. I'm going to make this one full screen. And now in order, for example, to make this bean one available only for dev environment and this bean available for test environment, all I need to do is to add an annotation called profile. And in here, all I need to do is to provide the profile name. So let's say this one is, it's profile, not primary. And let's say this bean, my first bean should be available only for dev environment. And again, I'm going to duplicate this one and make the second bean available for the test environment. Okay, so now if I go back to my first service and here I'm using my second bean. So if I use, for example, this bean1 in here, so now I want to inject bean1 in the my first service, and then if I go back to the example application and try to run the application, and here remember that we have our active profile, which is dev, and again, just to remind you before we start, we are injecting the bean having the ID bean1. So it is this one, which is available for the dev environment. So now if I run the application, we see that we have hello Alibu students in dev environment. Now if I switch to test environment, I'm expecting the application not to work because this bean will not be registered for the test environment. So Spring will only register the bean for the profile environment. So now let's restart the application. And let's see. So here, as I mentioned before, we have an issue. So here it says that the injection point has the following annotation. We want to inject a bean qualifier, but these following candidates were found. So we have my second bean and my third bean, because in the application config, we have my second bean available for the test environment and also my third bean available for all the environments. But the bean1 is no longer and is not registered for the test environment, or for the test profile, which is the active one. So we can say environment or profile, it's also correct. So in this way, we understand that Spring, or if we set a bean or even a configuration available for specific profile, it will not be registered for the other profiles. So also, let's try it out with a configuration in here. So also we can set the profile annotation on the class level. And here, let's say all this configuration should be available only for dev. So I can remove all the profile annotations from here, and this means that I want to inject this profile or this application configuration only for the dev profile. So here, if I go back to example application, I'm expecting again to have or to get the same issue, but now we should not also see this one. Okay, so let's try it out and see what will happen. So here we see that again we have the same issue, or like the same explanation, that the injection point, this means that Spring is looking for a bean with a qualifier bean1, but here it says that we did not find any other bean of the same type. Okay, so it's already mentioning consider defining a bean of type com.alibu my first class in your configuration. So here, if I go back again and change the active profile to dev in here and rerun the application, so the application will be up and running correctly. So here you need to be careful how to define your profiles. So now you understand that when you define a profile or you set the annotation profile on the class level, this means that the whole class will not be registered. If you set it on a method level, this means that the specific method will not be registered when the application starts up. REST stands for Representational State Transfer. It's a software architecture style that defines a set of constraints to be used for creating web services. These web services are often called RESTful APIs or RESTful Application Programming Interfaces if they adhere these constraints. REST was first defined by Roy Filden in his 2000 doctoral dissertation. The main idea behind REST is to treat networked resources as objects that can be accessed using standard HTTP methods such as get, post, put, delete, etc. And here are some of the fundamental elements of the REST architecture. First, client-server architecture. This principle establishes that the client and the server should act independently. They can interact with each other, but each side can be developed and updated independently. Stateless. Each HTTP request that happens from a client to a server should contain all the necessary information to understand and respond to the request. In other words, the server should not store any data between requests, which keeps each request isolated and independent. Then cacheable. RESTful architecture allows client to cache responses. Responses must implicitly or explicitly define themselves as cacheable or not prevent clients from reusing outdated or inappropriate data in response to further requests. Then layered system. The architecture allows for layers within the system architecture. A client cannot ordinarily tell whether it is connected directly to an end server or to an intermediary along the way, which can include load balancing, security measures, and so forth. Then code on demand. This is the only optional constraint. It allows the server to extend functionality of a client by transferring executable code. And finally, uniform interface. This is a fundamental to the design of any RESTful system. It simplifies and decouples the architecture, which enables each part to evolve independently. The four guiding principles of the uniform interface are: first, identification of resources, then manipulation of resources through these representations, and then self-descriptive messages, and finally the hypermedia as the engine of application state, or also known as HATEOS. So RESTful API have become very popular in modern web application development due to their simplicity, scalability, statelessness, and compatibility with the web. They are often used to create interactive applications, mobile applications, and web services. However, they are not suitable for all types of applications, and other architectures or protocols such as GraphQL or gRPC might be used to depending on the specific needs of the application. To resume, the REST is the web architecture principles, unique identification of resources, or also known as URI, different resources representation, hypermedia link or link of resources, stateless communication, and finally standard methods such as get, post, put, delete, and responses such as 200, 404, and so forth. When designing a RESTful API, there are some standards that we need to follow. First, the resource should be always plural nouns in the API endpoint, and if one instance resource should be retrieved, pass the ID in the URL. For example, we can have get/accounts, or if we want one single account, it should be a get method /accounts/the ID. Or for example, for deleting one single element, it's delete /accounts/2, which represents the ID of the resource that we want to delete. In case of nested resources, which means resource under a resource, the resources should be accessible as follows. For example, if we want to get the payment from the accounts, it will be accounts/1, which is the account ID, /payment, and then the payment ID. So use the HTTP methods to specify what to do with this resource. With the method get, post, put, patch, delete, you can provide CRUD functionalities. The CRUD stands for create, read, update, and delete. Use HTTP methods, also as known as verbs, to specify what to do with this resource. With the method get, post, put, delete, you can provide CRUD functionalities. And here, this is an explanation how we can design our resources. For example, here, if we want to get if we have /accounts, and this means when we have a get method with /accounts, this means that we want to get all the accounts. Post, this means we want to create a new account. Put, it's bulk update all accounts. This means we want to update all the accounts. And delete, this means we want to delete all the accounts. Now, let's see when we have a single resource. So when we have account / the account ID, then it's get account with ID 1. So for the post, this should be an error because we should not allow that we post a resource with an ID. Then for the put, this means that we want to update an account with ID 1, and for the delete, it's deleting an account with ID 1. Then for the resource, for example, for the nested resources, the /accounts/1/payments, This means when we have a get verb, this means get all the payments for the account ID 1. Post, this means that we want to create a new payment for the account ID 1. And then for the put, this is a bulk update, all payments for account ID 1, and the same for the delete. This means that we want to delete all the payments with the account ID 1. When designing RESTful APIs, we need to use HTTP methods, or also known as verbs. So here we have the following verbs that we can use to design our RESTful API. First, we have the get method or the get verb. This method is used to retrieve data from a server. It is a read-only operation, meaning it does not affect the state of the resource. And then we have the post. Post, this method is used to send data to the server to create a new resource. The data is included in the body of the request. Then we have the put. So this method is used to update an existing resource or create it if it does not exist. The update or new data is included in the body of the request. Then we have delete. So this method is used to delete a resource specified by a URL. Then we have patch. Patch, this method is used to apply partial modification to a resource as opposed to the put method, which is useful for full updates like post and put. This data for the update is included in the body of the request. Then we have options. So this method is used to return the HTTP methods that the server supports for the specified URL. It can be used to check the functionality of a web server. Then, and finally, we have head. So this method is similar to get, but only returns the header of the response, not the actual data. For example, the body. So this is useful when you want to check if a resource exists before trying to download it, or check if it has been modified. When implementing RESTful APIs, we cannot skip talking about status codes. So the response status code, our HTTP status codes are 3-digit codes returned by the server as part of the HTTP response, indicating the outcome of the request made by the client. The first digit of the status code defines the class of response, while the last 2 digits do not have any categorization role. There are 5 classes, ranging from 1xx, which is informational responses, to 5xx, which is server error response. So the first one is informational, the second one, which is 2xx, means success, the 3xx means redirection, and the 4xx means client error. And then finally, as mentioned before, we have the 5xx, which means that we have a server error. Now let's move on and check each one of them. The first category is the success category, which is represented by the code 2xx. So this 2xx has some codes. First of all, we have, for example, the 200, which means OK. So this is the standard response for the successful HTTP requests. When you make a GET request, for example, and the server successfully processes the request and provides the requested resources in the response, it will return a 200 status code. This status code simply means that everything went as planned, and the result data, if any exists, is included in the response. Then we have 2.1 created. So this 2.1 status code indicates that the request was successful and a new resource was created as a result. This is typically the response sent after a post request or sometimes put if you're creating a resource with that method, where a new resource is created and the server based on the data sent to the request. Then we have also a 204, which means no content. The 204 status code means the server successfully processed the request and there is no additional content to send in the response payload body. This is often the response to the delete request, put or post request when there is no particular information to send back in the HTTP response body. But header is useful. In other words, it's a way for the server to say, I did what you asked and we're done. So you don't need to go anywhere else. This response may also be used when the server doesn't want to return any information, like as a result of a delete request, confirming the deletion is successful. The redirection category, also represented by the 3xx response codes. So the HTTP status code for this category, we will mainly focus on one, which is the most important and the most used in RESTful APIs, which is the 304 not modified. So the HTTP status code 304 not modified is a special type of response that is used for caching purposes. When a client sends a request to the server, it can include a header such as if modified since or if non-match. These headers are used to ask the server to validate if the client's cached version of the resource is still up to date. If modified since, use a timestamp to determine if the resource has been updated since the last time the client requested. Also, we have the if non-match. It also works with e-tags or entity tags, which is a token associated with a specific version of the resource. So if the resource has not been modified since the given date time, in the case of, for example, if modified since, or the entity tag still matches, so in this case, if non-match. So the server will respond with a 304 not modified status and not send the body for the response because the client cache is still valid. By utilizing a 304 response, you can save bandwidth and make your web application faster by not unnecessarily resending resources that the client has already cached. So this leverages one of the main principles of HTTP, which is the idea of being stateless but still allowing for optimizing through caching. Client error category, or represented also with 4xx. So here we will check the most used responses, and first we will start with the 400 bad request. This status code means the server was unable to understand the request due to invalid syntax. This could be malformed request or a request with invalid arguments. The client should modify the request before repeating it. Then we have a 401 unauthorized. So this status code means the request requires user authentication. If the user already included authentication credentials, then the 401 response indicates that the authorization has been refused for these credentials. This could be due to a wrong username password, or the user does not have the necessary privileges. This status is similar to the 403 forbidden, but specifically for cases where authentication is expected but has failed or not yet been provided. Then we have the 403 forbidden. So this status code means the client does not have the necessary permission for the requested resource. In contrast to the 401 unauthorized response, authenticating will make no difference. This status code can also be used when the server does not want to reveal exactly why the request has been refused, or when no other responses is applicable. So for all these status code are part of the 4xx class of HTTP status code, which indicates that server was likely an error in the request sent by the client that prevented the server from processing it. As a best practice, the client should, after its request, or authenticate appropriately based on these responses. Now let's see an example how a REST API looks like when we implement it using Spring Boot. So here, for example, we have a payment REST controller, and this is the class where we will expose the resources for a payment object, for example. And in order to make this class a controller or exposed as a REST resource, we need to add the annotation REST controller. And then, as you can see here, we have a method. So this method will return a response entity of type payment information. So the payment information will be the response body of this method called initiate payments. And here, as you can see, we have a post mapping, which is the verb or the HTTP method that will be used to invoke this endpoint. and then it has a value / payment as explained before, the way that we need to name our endpoints. Then we see that we have a body coming within this request, and it's annotated with the annotation request body. And then we have our business code, and then we want to return like the result location, which is, for example, /payment /ID, which is the ID that was returned after persisting or saving the payment into our database. And then we return a response entity.created. So the .created, this method right here will return a status code for the created representation, which is the 201. And then the body, because we can also return a body within the response of this method, which is the confirmation that we created before. Also, in addition to that, we can specify the response code to this method, and this is how it looks like. So here we have a response status annotation that we can use. So to specify the response status of a controller method, annotate the method with the response status, and then we can give it the status code that we want to return. So Spring only uses the response status when the marked method completes successfully without throwing any exception. In the coming parts, we will see in action all what we discussed before. Server error category. So for this class, we will see the 500 internal server error. So this is a generic error message given when an unexpected condition was encountered by the server and no more specific message is suitable. In other words, it means that something has gone wrong on the server itself. It doesn't provide a clear reason because the error could be for a variety of reasons, such as server misconfiguration or uncaught exception on the server-side code, or a server resource issue like memory depletion. Then we have the 503, which is service unavailable. This status code indicates that the server is currently unavailable to hand the request because it's temporarily overloading or down for maintenance. Generally, this is a temporary state. It may include an optional retry after a header indicating how long to wait before making a new request. So both of these status codes are part of the 5xx class of HTTP status codes, which indicates situations where the server is aware that it has encountered an error or is otherwise incapable of performing the request. These types of error are often outside of the client's control and may require attention from the server's operators. That's good, you made it this far. So now before we move on to the Spring REST, let's first clean up our code. So what I will be doing is I will remove all the unnecessary classes and I will just leave this example application, which is our main application. And afterwards, we will start implementing our first REST API. So what I will be doing, I will remove these classes. So just select them and then click on delete and then just click OK. So you click delete anyway, just also OK. And then we will clean up the code that we have right here. So I will just copy this one and make this Spring run. And then let's remove this and also let's remove all this code. And then we need to pass the example.class as a parameter. So now we have our application back as it was, and now I will optimize the imports, and also I will remove these properties because we no longer need them. We will see them afterwards if we want to work with profiles. So now we have our application back as it was. Now just to make sure that everything is working fine, just try to run the application, and all we need to check is that the application is up and running, as we can see here. So the application started on the port 8080 and started example application in some time, like it depends on your machine. So now we are up and ready to continue with our REST API. Now let's create our first controller. So here I will just right click here and then new and then Java class. So here I will call it first controller. And then this is the class that will represent our first controller. So here, in order to make the first controller as a controller that will be scanned by the Spring Boot, all we need to do is to add the REST controller annotation. And in order to have this REST controller annotation, just make sure that you have the Spring Boot starter web dependency in your pom.xml or gradle.properties. So now let me first make this one full screen. In order to create an endpoint, first we need to define what is the verb or the HTTP method for this endpoint. So let's assume that we want to perform a get method. So here we have an annotation called get mapping. If we use this get mapping annotation, so this means that inside this REST controller, we have a get mapping or a get method. So here, let's say, for example, a public string. This method will return string, and let's say, or let's call it say hello. And then all I need to do is to return hello from my first controller, for example. And then, of course, don't forget to give your endpoint a path. Okay, so here we can even work without a path. So let's try it like that, and then let's see how we can enhance this. So I will run my application. So here we also see that the application is up and running. Now I will go to the browser, and as you saw in the logs, the application started on the port 8080. So to access any get endpoints using the browser, all we need to do is to access the local host and then the port number, which is 8080 in our case, and then just hit enter. So here we have a 404 because we don't have any endpoint defined on this URL. So if I add the slash right here, it's also the same. So that's why we need to define a mapping for our endpoint. So let's go back to our IntelliJ, and here in this get mapping, so I will add slash hello, for example. Okay, so this is not respecting the naming conventions, of course, but we will see that in details later on. So now I will restart my application. Again, the application is up and running on the port 8080 with a context path empty. I will explain to you what is this context path later on. So now let's go back to the browser. And all we need to do is to refresh. And here, of course, we need the slash hello. So when I hit or when I try to reach the slash hello endpoint, Spring will go and will know that we have an endpoint called slash hello available after or under the default context path that we have. And this is the message that we provided within our endpoint. So let's go back to IntelliJ again. So here, if for example, I duplicate this one and I create another endpoint, so let's say hello-2, and here let's say, for example, hello2, and here say hello2 from my first controller. And then if I add a response status, we will see the difference. But before adding the response status, let's go to the browser again and inspect a little bit more and see what happens. So here, if you click on F12 or right click and then inspect, so you will have this interface, and then you can go to network. Now if I refresh, we see, and then you need to click on all, we see that we have this endpoint hello, and here this one, let me zoom it in. So here we see that we have a bunch of information. So we have the request URL here. It goes to the localhost 8080/hello, and the method is a get because we in our endpoint we defined it as a get mapping. And then we have a status code 200, and also we have the remote address and a bunch of other information. We also have some response headers, which are the default response headers, even if we don't specify them. Also, we have a request headers, which are included by the browser itself. Okay, so now let's go back to IntelliJ. And here, for example, if I do response status, And here, this response status, let me show you how, like the implementation or the code of this one, what we can pass as a parameter, which is the value right here. It's an object of type HTTP status. So this HTTP status class, it's an enum actually, contains a bunch of methods, okay, or variables. So for example, continue is 100. And here, for example, let's go back. And here, for example, if I search for the 201, you will see that the 201 is created, okay? Or okay is 200. So the default one is 200 if everything goes fine. So now let's play a little bit with this. So let's say that I want to use accepted as a response status for my second endpoint. So here, all I need to do is to provide an HTTP status dot accepted, so it will automatically go to this one and return 202. Okay, so now let's restart the application and see the changes. So again, in the browser, if I access the hello-2 endpoint, we see here that we have a status 202, which is the one that we specified before. So here it's a get method again, and we have a 202 as our status code, which is the one that we already specified as an annotation in here. So like this, we can specify a response status for each method, or we can leave it to the default one, which is 200, but it's always recommended to specify the response code or the response status as the verb or as the method or as the requirement of our application. Okay, that's good. So now you understand how we can create an endpoint and also how we can specify the response status. So now I will just clean up this one. Also, I will optimize the imports, and let's create our first post mapping endpoint. So for the post mapping, it's always the verb and then mapping. So the annotations with Spring Boot are always like verb and then mapping. So for post mapping, get mapping, put mapping, and so on and so forth. So here, let's say post mapping, and let's give it, for example, /post. And then I will just perform a public string post, for example. And here I will just return request accepted, for example, or saved, or like you can say whatever you want. So here for this post mapping, we need, and as we mentioned before, when we perform a post mapping, this means that we want to post some data or to send some data from the client to the server. So the client in this case is our browser or any other tool that we want to use to perform REST requests. So here we need to provide a body, for example. So the body in here, I want, for example, let's say string and let's say message. Okay. So here I will just update this a little bit. Request accepted and message is, and then just message. We will just display the message that we get as a parameter. Okay, so now if I start my application and I go to the browser and try to hit this post endpoint, let's see what will happen. So again, let's check the server is up and running. Now, if I go back to my browser, let me reduce this one and let's try to access /post and hit enter. So here we see that we have an error message. So this application has no explicit mapping for error and so on and so forth. And here we see that we have this post 405, and this is because the browser does not support post requests. So it does not support post requests. This means that the browser address bar right here typically sends get request when you enter a URL and press enter. So this part of the design and specification of a browser. A GET request is meant to retrieve a resource, which is exactly what you're doing when you enter a URL. You're asking to retrieve and view the web page. So the POST requests, on the other hand, are designed to send data to server to create or update a resource. So POST data is sent in the body of the HTTP request, not in the URL. This is the part of the HTTP specification. So now, since we are not able to use the browser address bar to send POST requests, let's see what is the alternative for that. Now, let's see what is the alternative for using or as a HTTP client to send requests to our backend server. So for this, if you are already familiar with Postman, you can skip this video and move on to the next part. But before that, let's first see or define what is Postman. So Postman is a popular API client that helps developer for build, test, and debug HTTP requests. It's used for API development and testing, and it simplifies each step for the API lifecycle, including design, mocking, testing, documentation, and monitoring. So first, let's see how we can install Postman. So it's so simple. Just go to the browser, go to Google, and then just search for download Postman. You will find the first link, which is which is referring to the postman.com website, and then click on download Postman and get started for free. So here, as you can see, we can download the app, and this is how Postman looks like. So also you can change the theme. You can make a dark theme or light theme. And here, depending on your operating system, you will see the download button right here. So here, for example, for my case, I have an Apple chip, or if you have an Intel one, or if you have Windows or Linux and so on and so forth, you can just click and download Postman and then install it. So the installation is quite easy and straightforward. So now let's go back to Postman and start exploring Postman and its different features. So this is how the Postman UI looks like. So first, let's start by defining the theme. So how you can manage and how you can define the theme. So here you see this cog right here, then click on settings, and then you have themes. So for the theme, you can whether choose the system default. So it will be depending on the system layout and look and feel. Also, you can make it a light version, or also you can use the dark one, which is the developer's preferred theme. So I will keep it dark for the sake of this course. Then what we can see in here, we have this plus button. This is when and where we can perform HTTP calls to any backend. So here what we see, we have the URL, or we have the URL that we want, or the URL of the endpoint that we want to invoke. And here we have the list of the supported HTTP operations. And as we can see here we have get, post, put, patch, delete, head, and options. So these are the HTTP methods that we already explained and spoke about before. And here all we need to do is to perform or to paste or type the URL of our API. So here we also see that the history of my previous URLs that I used in here. And so for example, if I use one of these, and since our API is also available on the localhost 8080, and if I try to reach the hello endpoint and click on send, so we see here that we have the response that we also saw on the browser. So also here, this is a get mapping. And here, let's explore what we have in here. Okay, so for depending on the method or the verb that we want to do, we have a list of few things here that we can do. For example, here we can pass request params. And here, for example, if I have, for example, I want to pass a parameter as like first name equals Ali, for example, you see here that it's immediately changing and like doing a binding between this request param or query param and the one right here. So for example, if I add a second one, last name, you see that it's also changing in the URL or in the URL address bar right here. So here, for example, if I say Bu Ali as a last name, you see that it's also reflecting in here. So here we are where we can pass query params. Then we have the authorization tab. So here, if we have a secure backend or secure API, here where we can specify the type of the security we have, and we can pass the values for it. For example, if my API is secured with an API key, so all I need to do is to select API key, and then I paste or like give the key name, the key value, and where I want to include this one as a header or as a query param, depending on how you implement it on your backend. Then we have the headers tab. So the headers tab, by default, we have few headers which are hidden. These headers are automatically injected and included by Postman or even the browser itself, as we saw before. So here, for example, we have the Postman token, we have the host, user agent, and so on and so forth. Also, if I want to specify a special header that I need for my backend, I can also call it, for example, here my header and then value, for example. And then we can also specify description. So this is where we can, where and how we can pass extra headers to our backend. And then we have the body. So this body tab is mainly for all the requests like of type post, put, patch, and that's it. For the delete, we don't need to pass any bodies. So for example, if I have a post request, and here I can I have different types of bodies. So the body can be none. This means that I don't have a body for this request, which is also valid for some APIs or for some endpoints. So I will just clean up the URL. And then we have also form data. So the form data, it's just a key value. And for example, we can pass a text or a file. In case I want to upload a file, all I need to do is to select file in here and then select the file from my system. Then we have also another type of body, which is the URL encoded, which is a key value map. Then we have row, which is the part that we will see and we will use later on, or we can also pass a binary. So we can also select a file and send it. And even also if we have a GraphQL, we can pass the query and the query variables and so on and so forth. So now let's go back to this row. And here, so the body can be whether a text or JavaScript or JSON or HTML or XML, and those are the supported body types. Then we have another tab right here, which is the pre-request script. So Postman also supports scripting. So we can, before sending the request, we can perform a script. For example, I can perform a script, or I can write a script to grab some data or to grab a token from somewhere and inject it or save it to an environment variable that I can use, for example, in my authorization or even in the header and so on and so forth. Also, we have the test tabs. So when I run or when I want to test to test my endpoint, and if everything is working fine, I can perform test scripts here. So that the scripts are JavaScript based, and here, like you can see, for example, that you have some code snippets. So for example, here, if you want to test that the status code is 200, all you need to click on that and you will have the code ready to use. So also you can refer to the official documentation of Postman and you will understand and you will get everything you want to get started with testing with Postman. So here I will just go back to the authorization and move it back to none because we don't have any security. Also, I will just remove this test. And finally, we have some settings. This, for example, if you have some specific requirements for your application or for your backend. So this is where you can specify these settings. But for now, it's not something which is really important for us and relevant. So we will skip this part. Also with Postman, we have a bunch of other features. So here we can create collections, and this is the part that we will cover later on when we implement the test part. So we have here collections. We can create a set of collections, which is a set or like a group of the requests that we want to perform, and we can have them. For example, this is one of the requests of a previous bootcamp that I already animated. So here, for example, we can specify the order and the flow that we want to execute within a single collection, and also this can be part of the end-to-end tests later on. Also, we have API here, so we can switch to workspace, or like we need to set up a workspace, and here, for example, we can collaborate with other teams and so on and so forth. Also, we can define environments. So environments, it's something similar to what we explained before. We can work with environments on Postman too. So for example, let's say I have this URL right here, and I can run it on, for example, on a dev environment, on pre-production, on production, staging, and so on and so forth. So I don't need to change or to switch every time the URL from one environment to another. All I need to do is to set up my environment and just click or select or set that environment to the active one. Also with Postman, we can use mock servers. So users can create mock servers to simulate API responses, which is useful in the early stages of development when the backend is not fully built. So here you can say, for example, when you access this endpoint, return this, and this is what we call mock or mock server. And also mocking, this is a part that we will be covering in this course later on. Also, we have some monitorings, and here we see also the history of all the requests that you perform on Postman. So this is a global overview for Postman, and now let's move on and try to test our post method. Now we can use Postman to perform this post request. So let's open Postman and let's click on this plus icon. And then all I need to do is to specify my URL. So I will use just an old one, and then I will clean up. So my endpoint is localhost 8080/post as we have it in our backend. So here it's a post request. So I need to select the verb or the method, which is a post. And all I need to do is to click on send. So here, let's check. Okay, so we did not start our backend. So let's start it. And now let's go back to Postman, and here, because we saw this message could not send request, so this means that the server is not up and running, so that's why I had to run it. So now let's click on send again, and here we see that the response or the answer from our post method saying that request accepted and message is null. So the message is null because we did not pass any body, because my post endpoint is expecting a string message as a body, so I need to pass that. So as I explained before, to pass a body, click on the body, and then we have the type pro, because all we need to do is to pass a text or a JSON body, or XML. It depends on the body type that we want to expect. But in this case, it's just a message. So it's just a classic test or a normal test body. So here, let's say Alibu, for example, and I will click on send again. But even if I have my body right here, the value of the message variable is always null, even I have a 200 OK coming back from my backend. So maybe let's change this one to JSON and click on send. It's still always null. Let's try with XML or HTML. It's always null as a response. So let's go ahead and check why this is null. Let's quickly restart our application in debug mode, and let's add a breakpoint to the line 19. And then let's send the request again and see maybe we receive correctly the value for this message variable, and maybe we have something wrong with our implementation. So let's jump back to Postman and let's click on send again. So here we see that we have our breakpoint, and don't worry about that, about debugging, because I will make a full video just to cover how to debug with IntelliJ. But as you can see here, the value of our message is null. So this means that we don't have any issue with our implementation. This means that no issue so far, because maybe we missed something, but for this case we are receiving a null. So this means that we are not able to map or to transform the message or the value of the message we received from Postman or our REST client, and we are not able to map it to this variable. Now let me show you and let me explain why. When we work with Spring Framework, we need always to tell Spring and to indicate for each step what is the request body, what is the response body, what is this, what is that. Because Spring is smart enough, is a complete framework, but it will not do the job for us. So in this case, we need to indicate that this parameter we have right here is a request body, or should represent the body of our request or of our method we have right here. So in order to fix that, what we need to do, we need to add one annotation, which is a request body. So this means this is the body of our request, and the request body annotation is used in the Spring MVC to bind the HTTP request body with the method parameter. It's part of the Spring's approach to build RESTful web services and is used in the controller layer where the HTTP request is handled. So as you can see, here we have our request body in our method right here, which is already part of our REST controller. So now let's restart the application in a normal mode and let's test again and see what will happen. So again in Postman, if I click on send, now we see that we have Alibu. So here, let me explain a little bit what happened. So here, when we send Alibu as a message or as a body for our request, then here in IntelliJ, using this annotation, so when we annotate the method parameter with request body, Spring will use the HTTP message converter to convert the HTTP request body into the specified Java object. So here, for example, it can convert JSON data to the request body into the Java object, or if it's, for example, here the case of a string or of a simple string, it was able to convert anything coming from the body of our request to this string message. So here, let me show you something else. Here we see that the type of the body or the type of this row object is text. Now if I transform it to JSON, and here, so here this is how we map or rematch the JSON representation. So our parameter is called message, and then let's give it a value Alibu. Then let's click on send and see what is the output. So as you can see, so the request accepted and the message, it just returned back this object. So for us, it's a JSON because we selected JSON as a type in here and we passed a JSON object. But here in our implementation, the object is of type string. So it just transforms this JSON representation, which is also a string, to just string message. But if I have a complex object or a Java object in here, it will also be able to transform this to the Java object. We will see this in details later on. Now let's assume that I want to post an object that should hold the information or the data of an order object. This means I want to post the customer name, the product name, and a quantity to save it or to do whatever logic we need behind. So let's go ahead and create such class. So here on our base package, right click and then new and then Java class, and let's call it order DTO, or let's just call it order for now. So click enter, and here let's define some fields. So I will have private string customer name, and then let's say we have also a private string product ID or product name, it also works. And then let's have finally public int quantity, and this is the representation of our object that we want to post right now, because in the previous example we just saw how to send a simple string as object. Now let's see how we can send a complex object to our controller. Now if we go back to our first controller class, and let me make this one full screen, and I will duplicate this method, and for the mapping I will call it post-order. And here, instead of having a string message, I will request or ask to have the order object, which is part of com.alibu.example, the class that we just created, and let's call it order. Okay, so here let's say the request accepted and order is, and let's simply say our object order dot to string. So this is going to be the default toString method. Let's see what will be the output. But first of all, let's start our application and go to our Postman and test this one. So first I'm going to start the application. So we will get this new endpoint ready to use. So as you can see, the application is up and ready. Now, if I go to Postman, and here I will duplicate this tab. So just right click on it, and here you have duplicate tab. So here I will just change the URL to post order, and then I will change the body. So here we have the type, it's a JSON, and to represent the object that we created in our backend to a JSON type, all we need to do is the following. So here in this order object, all we need to do is to take these names right here, the field names, copy them, and then go back to Postman. And here I will remove all this and just paste this. So here the name should be exactly the same, so no typos in there. And then I will show you how we can perform the types. So here for string, it should be also in double colon. So let's say Alibu for the customer name, and then for the product name, let's say for example iPhone. And for the quantity, since it's an integer, so it will be just 1. And then don't forget to add a comma after each field. So now let me format this. And now we have, this is the JSON representation of our Java object. So the names should match. And then I will show you how we can also, if we want, change the JSON property names. So we can also do that. So now let's go ahead and click on send and see what will happen. So here we have this com.alibu.example. So this is the object. Now I will restart my application in debug mode, and let's add a breakpoint and see what's happening exactly. Going back to our first controller, I will remove this breakpoint and move it to line 27, since here we receive the order object, and then I will restart my application in debug mode. And then I will go back to Postman and click on send again. So here we have our order object. So let's check what we have. We see here that we have customer name is null, product name is null, and quantity is null. Okay, so I will resume this. Also, I will just go back to my order class and generate the toString method. So here, just use the auto completion. And here we see that we have this toString method, and I want this toString method to include all the fields that I have, and then I will click OK. So here, this will be the string representation of my order class. So if I restart again, just to make sure that we see exactly this toString method or what we expected, let's go back to Postman, click on send, and then I will resume since I have my breakpoint activated. And then let's go back. So here, as you can see, we have null, 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 but we already sent an object in here. Okay, so we sent values Alibu, iPhone, and 1, but we see that we have null values. So let me explain to you why we have this. When we sent our request containing this request body right here with the following values, Alibu, iPhone, and 1, we saw that the response was containing null values. So as we saw, customer name was null, product name was null, and the quantity was 0, which are the default values of the types that we chose. And this is because we didn't create any accessors for our order class. So coming back to this order.java class, we see that we just created private fields, customer name, product name, and quantity. And this is without any accessors. So the accessors are getters and setters, also known as accessors, are mutator methods. They play a crucial role in the serialization and deserialization process. In the context of frameworks like Spring and libraries like Jackson, which are commonly used for serializing and deserializing data and from formats such as JSON. So these methods have specific uses. So for example, the getters, when an instance of an object is serialized into a format like JSON, the getter methods are called to access the current state of the object. The values returned by these methods are then written into the serialized format. Now for the setters, during deserialization, setters are used to populate the field of a newly created object with the data from the serialized format. So now to fix the issue, all we need to do is to generate getters and setters. So I will click on generate, and here we see that we have getters and setters. And also, as I mentioned before, each time I use a shortcut, you will see the green pop-up right here to see or to learn which shortcut I used. So now I will generate getters and setters for all the fields that I have right here. So it will be for customer name, product name, and quantity. And then I will click on OK. So now we have the accessors. So now if I restart my application, I can also leave this breakpoint. I will restart the application, and then I will go back to Postman and send again the request. So here I will click on send, and now let's evaluate this order. So we see that the customer name is Alibu, iPhone, and we have also the quantity if I resume the program and go back to Postman, we see that we have the object that we already sent. So now I guess you understand the importance of having accessors while you use object to transfer data from a client or a REST client, which is in our case Postman, or it can be any other application like a front-end framework like Angular or React or even native JavaScript, and you need accessors to serialize and deserialize the object. So now as a next step, let's see how, for example, I can customize the name of this JSON field. So for example, I want to have a different name for my JSON representation and another different name in my Java object. Now to specify a different property name, and this case can happen, for example, in case I want to consume or I want to send data to a third-party API and the names are not the same as my Java object. For example, we can have a case of a customer name. It might be CNAME, PNAME for product name, and Q, for example, just for quantity. And I want to create a decent and comprehensive Java object with customer name, product name, and quantity. And also I want Java or my Spring framework and Jackson to correctly map these objects. So all I need to do is to use an annotation called JSON property. And this JSON property comes from the package com.fasterxml.jackson.annotation, which is the Jackson library, which is used by the Spring framework for the serialization and deserialization process. So here, let's say that this customer name, I wanted to have a C name, for example, to reference or to say that this is the customer name. But before going forward, let's quickly check the JSON property annotation. And here in the official documentation of this annotation, it says that it's marker annotation that can be used to define non-static methods as a setter or getter for a logical property, depending on its signature and so on and so forth. So here, this is the most important part. The default value is empty, as you can see in here, indicates that the field name is used as the property name without any modification. But it can be specified to non-empty value to specify different name. So here, this is what we are doing right now. And now let's just duplicate this and specify it also for the second property. And I will call this one pname. And let's say, for example, I want to call this as just Q, or let's leave this one to quantity, for example. Okay, now if I restart my application in debug mode and go back to Postman and try to perform the request, let's see what will happen if I leave the properties like this. So I'm going to click on send. So I can also here leave the breakpoint, and as you can see, we have the customer name is null, the product name is null, but the quantity was correctly mapped. So the quantity was mapped because we have this JSON property right here, and it has the same name as the Java property or the Java field. Okay, but for the customer name and product name, the names are different because we specified this JSON property right here. So all we need to do, I'm going to resume the program right here, and I will go back to Postman. And all I need to do is to change this property to CNAME and then product name or P-name. And here, also I left on purpose this name right here with a capital N, also to see if it's case sensitive or not. So let's try this out. Also, we see that we have customer name and product name as null. So yes, the answer is yes, it's case sensitive. So you need to be really careful about that. So here we have CNAME with a small letter or a small n or like a lowercase n. So I will change this one and send again, and we will see that we have correctly the mapping to the correct values that we sent from our REST client. So here I'm going to resume the program, and also I will show you that we have the correct output right here. So now we understand how we can map properties with different names than the Java objects. So now let's move on and see more interesting parts. Since Java version 14, a new type of objects was introduced, which is Java records. We can also use records to represent our objects. So like we did with this order, here it's just a class. We can create records to represent our request bodies. So let's go ahead and try this one. So here I will create a new Java class and then select record in here, and let's call it order record. And within this order record, all I need to do is to create or to declare the same properties that we have in here. So I'm gonna just copy paste them. So here I will use a shortcut to select all the properties. Just copy, and then I will close this one and paste this in here. So, and then I need, of course, commas. And now I have my record object created. So here I have order record, and all I need to do is between these parentheses, all I need to do is to declare my fields, and I don't need any type of accessors like private, public. Okay, so now we have our order record ready. Let's move on and now and create an endpoint that should accept the order or the record as a request body. And now if I go back to my first controller, and I will duplicate this method. Let me make it full screen, and here I will call it post order record, just to make the difference. And here I will call the method post record, and here in this order or request body, it will be order record. Okay, so then I will also use the order.toString method. So all I need to do is just to run my application again and check what will be the output of this endpoint. So I'm restarting the application, and as you can see, the app is up and running. Now if I go back to Postman, and all I need to do is to change this endpoint to order-record, and then I will click on send. So here we see that we have null, 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 because we don't have the same property names. Also, the JSON property works with records. So whether we can fix it on the Java side or we just rename this one. So what I will be doing, I will duplicate this tab, and then in the body I will just use, for example, customer name, and also I will just rename this one to product name. So like this, I don't need to change my Java object. So I will click on send again, and we see that we have here request accepted and the object is correctly displayed. Okay, so now in this case, we saw that we didn't need to create any getters, any setters. We didn't need to do anything for our record. Okay, so here you see that we created 3 fields, and then we had to generate getters and setters because we need those ones. Also, we saw that we had to override the toString method, but for the order record, we didn't need to do that. Let me explain to you in the next part what is the difference between POJOs or plain old Java objects like the order object right here and records when it comes to data transfer objects. Whether to use POJOs or plain old Java objects or records for data transfer objects in Java depends on the use case and the Java version you are using. Java records introduced as a preview feature in Java 14 and finalized in Java 16. So they are new kind of type declaration in the Java language. A record class is shallowly immutable, transparent carrier for a fixed set of values. Values which can be accessed with accessors method that have the same names as the fields. Records reduce the verbosity of Java and make it more suitable for data-centric applications. POJOs have been used for many years in Java for such tasks. They are versatile and work with all Java versions, but require more code to write. You have to declare fields, and then you have to write or generate constructors, getters, setters, equals, hashcode, and toString method. If you are using Java 16 or later, and your DTO are simple carriers of data without any additional logic, records may be a better choice. They provide a concise and convenient syntax and automatic implementation of equals, hashcode, and toString, as we saw in the examples previously. Also, you need to note that records are final by default and all their fields are final, so they can't be used with libraries that require mutable beans, such as some older versions of Hibernate or JPA. if you are using a Java version earlier than Java 16, or if you need mutable objects, or if your DTOs need to include logic beyond just storing data, POJOs may be a better choice. So as always, the right choice depends on your specific needs and constraints. Now let's see how we can pass parameter to a method. So let's go back to our first controller and let's see how I can pass a parameter to a specific method. So here I will just create or copy this get mapping method right here, and I will put it in the bottom. So this works for any type of methods, whether get, post, put, delete, and so on and so forth. So it's applicable and correct for all of them. So here, let's say, for example, path variable. This means that I want to pass my parameter or my variable in the path. So to pass it in the path, here, let's say, for example, my value equals, and then let's concatenate this with the result. So then the first thing that we need to do is in this get mapping right here. So let's say that we have a method called hello. Let's keep it as hello. And now I want to pass my variable in the path. So this means I want to have something like this. So HTTP and then : / and then localhost and then the port number / for example hello / Alibu, let's say. So this is, or I want this one a variable. So it can be Alibu, it can be Ali, it can be Boo, it can be any variable that I want to pass. So here in this case, first all I need to do is to have my variable. So it's of type string, for example, and let's say username, just an example. And now I need to tell Spring that this username will come in the path right here, or I will receive it in the path of my request. So to do that, just go here, whether you have, for example, /hello or you have nothing, all you need to do is / and then curly brackets, and then, for example, let's say user-name. So like this, Spring will know that this user-name is a path variable. Now, all we need to do is to link this one to this one. So here we have two cases. So the first one, whether I pass the path variable exactly within the same name, like the same naming as my variable right here. So it will be just like that. Okay. So Spring will automatically refer this username here to this username right here. So here I will just concatenate my username, or the best case, which I recommend, is to use user-name, for example. And here all you need to do is to say that this is a path variable. Okay. And this path variable, as I mentioned before, whether we use it like this, so the path variable is always needed. You need always to specify or to add this path variable annotation to the field that you want to map, because like this, we will mention to Spring that this username right here, this variable or parameter that we want to receive right here, is the same that we have it here. And first we can mention the same name, so the same variable name, or for example, if I have a different one, so to use it like this, user-name, here this path variable also accepts a parameter. It's called value. So by default it's empty, and by default it will take the variable name as the variable or the default value. So here let's specify it like that, and let's say user-name. So the value we put in here should be exactly the same in here. So what I recommend also, try to have like correct namings. So user-name is more readable than, for example, username like this. Or for example, if you have long complex names, always separating them with a dash is much easier to read. So now if I restart my application and go and test this one, we will see that we have my value equals the value that we will pass in the parameter. So I will just restart in debug mode, and then I will go to my Postman, and in here I will just duplicate one of these, and here I have, for example, hello / and then let's say Alibu. And of course, it's a get mapping. So let's click on the get. So we don't have anybody, so we can click on none. And now all I need to do is to click send. So here we see that I have my value equals Alibu. And if I say, for example, hello, or even with spaces as you want, it's also able to map the value. So here, this is how we can pass a variable in the path. We call it also path variable. Now, let's see how we can pass request params. Now, let's see how we can pass a variable as a request param. So here I will just duplicate this method just to keep the code. And then I will just here rename it to param variable. And I will just comment this out to keep the same URL. So here I will just remove this one. So it will be just /hello. And here the URL or the final URL will be hello and then like this, and then it will be param underscore name, or like this will be the param name equals and then the value. So here param value. And if I have a second parameter, it will be and param name 2, for example, equals value 2. Just an example. Okay, so now let's transform this username to a param or a request param. So here all I need to do, instead of using path variable, it will be a request param. And this request param, whether we can keep the request param as this parameter or this field right here, or sorry, it's param, not part. And or here in the same way as we did before. So let's say, for example, user-name. Okay, so if I have another parameter, all I need to do is to duplicate it or to add another request param. So for example, username, and here let's say last name, and here let's say, for example, last name. And here all I need to do is just to display this plus user last name. And this is how it will look like. Now all I need to do is restart my application and go back to Postman and send this request again. So when we started the application, we have an exception, and this is actually going to introduce us to the next topic that I will explain just later on. But for the moment, I will just comment out this get mapping right here, and I will explain that later on. So let's restart the application again and make sure that everything is up and running. So here the application started, and let's go back to Postman. And all we need to do is just change this one. And as I mentioned before, we have user-name. Also, you can remark that here, every time we type a parameter and the value, it will be reflected automatically in the query params. So here, let's say Alibu. And for example, and then for example, we have user-last name, and then equals, for example, Buali. So this is my last name. And then let's click on send. So here we see that we have Alibu and then Buali as a last name, exactly as we mentioned in our code right here. Okay, so this is how you can pass request params. Now let's move on to the next part, which is how we should name, or how we can name our methods and URLs, and how Spring is already interpreting that, and how requests are dispatched from our REST client to the backend. So now let's understand the difference between path variables and request params. So in Spring Boot, path variables and request params are annotation used for extracting values from the URL of an HTTP request. They are used in the Spring MVC handler methods, and here how they differ. So first, when we start with the path variable right here, so this annotation is used to extract values from the URI path. So it's typically used in RESTful web services where the URL contains a value representing some sort of resources identifier. So the annotated parameter in the method declaration is bound to the path variable of the same name. So as we mentioned before, so here if you have whether Spring is capable of referencing the name that you pass right here as a path variable with the parameter name or the field name, or when you use path variable, also like you need to use path variable, and you can also pass the name right here to match the name that you have in your URL. From the other hand, when we use request param, so this annotation is used to extract query parameters from the URL. So query parameters are typically used to carry context information for the request and are separated from the URI using the exclamation mark symbol and are chained with the AND symbol. So in summary, path variable is used when a value you want is actually part of the URI, while request param is used when the value is passed as a query parameter. In a Spring MVC or Spring Boot application, the framework uses annotations to define which method should handle which HTTP request. So we have the controller or the REST controller annotations are used at the class level to indicate that an annotated class is a controller. So Spring's component scanning mechanism detects these classes and create beans of them in the application context. So then we have the request mapping annotation, or as a shortcut, we have the get mapping, post mapping, put mapping, etc. So this one is used as the method level within these controller classes. So this annotation tells Spring that the annotated method should handle an HTTP request of a certain type, and for example, a post, get, put, and so on and so forth. And when the application starts up, Spring creates a mapping between the URL's HTTP methods and the corresponding controller methods. So this is done by a class called request mapping handler mapping, which scans the controller classes and builds up a registry of such mappings. So when an HTTP request comes in the dispatcher servlet, which is the front controller in Spring MVC, consults these mappings to determine which method should handle the request. So then the appropriate method is then invoked and its return value is used to generate the HTTP response. Next, we will see in the diagram how this is working. So now let's understand in action and even a little bit in details how this works. So in a Spring Boot application or in a REST API application, we have some kind of REST clients, and it can be a mobile application, another REST API, or the internet, or even Postman as a REST client. And then the first step is sending a request. So we call this an incoming request, and the first thing or the first object that will receive this request is the front controller, which is the dispatcher servlet. Then the dispatcher servlet will forward the request to the handler mapping class or the handler mapping object, and this handler mapping will consult the mapping registry, and it will try to find a mapped controller. And this mapping registry, as I explained before, so it will map, or it has a registry of the method plus the path variables and types, and it will refers to a specific method of the controller. Then when it finds a match, it will return the controller and the method that needs to be invoked. And then the fifth step, it will forward this request to the required controller. And then we of course have all the business logic goes along, like service validation, database registration, consulting another API, and so on and so forth. And after that we have the response. So the response will go back to the controller, and the controller will send back the response to the dispatcher servlet, and then it will go back to the customer or to the client of this request. And this is how it exactly works. Now let's have a quick look on this. So for example, if we have a get method with the following path /sampath/string and then an integer as path variable, and for example we have a get sampath/ali/1, so this is correct. Then if we have the same path but with a different verb or a different method, in this case for example a post, so we have post/something/ali/1, so this is also correct because we have two different verbs. So that's why I mentioned here that the concatenation of the URL should be unique. So the concatenation, or like the composition of the URL, is method plus path variables, and here I mentioned type because we need to have different types. So for example, here, if in case I have sampath/string/integer, and then even if I pass a different value, Spring will say that we have an ambiguity, and it's not able to determine which one to use. So you really need to be careful about that, and we will see in action how this works. So this is globally how request dispatching works in Spring Boot. So now coming back to our first controller class, and let's bring this back. So here we have a get mapping, and then it has a mapping /hello, and in the bottom, if you remember, we have a get mapping. So also it has the same URL, so it's /hello. And here we see that request params, they do not interfere, or they do not make a method unique. So now if I start the application, I will get an exception telling me that Spring is not able to determine or to know which is what. So here the error that we have, so we have application run failed, and the exception here, it says that error creating bean with name request mapping handler mapping. So this is the class that we spoke about, defined in the class path blah blah blah, and so on and so forth. And here it's mentioning that, so here in the end of this exception, we see that we have ambiguous mapping, so cannot map first controller method, and the method is com.alibu.example.firstController, which is our class, and then the method called param variable. So this is the method that we are talking about, and then this method, it contains two string parameters, to a get /hello, because there is already a first controller bean method com.alibu.example, and the method is called say hello, which is already mapped. So in this case, we see that this method, even the method name is different, but Spring doesn't refer the method names, but first the ID or the unicity is about the parameter and the path. So you really need to be careful about that. And even if you get such an example or such an exception, you now are able to understand where this comes from. Before moving forward, let's first clean up our code. So first I will remove this order record. I will create one later on if we need to, and then I will keep I can keep this order, we might use it, but also let's just clean up everything, and let's restart everything from scratch. And for this controller, I will just leave the first get method just to have our controller up and working. So here I will just leave this get mapping and this post mapping, and now let me also optimize the imports, and that's it. So now we have our project again clean, and we can start from scratch to introduce and to dig deep in this part. First of all, we need to install all the required softwares in order to correctly and easily communicate and interact with the database. For this course, we will be using PostgreSQL as a database management system. So for you can whether install PostgreSQL on premises. This means you download and install the software, or you can use Docker. So first, let me show you how you can install. Go to Google, and all you need to do is to type download PostgreSQL, and then you just select, because you will have two or more links, like the sponsored links, but then you need to go to the official website, which is www.postgresql.org, and then go to the downloads page. So here you will have the download page for the different operating systems like Linux, macOS, Windows, and so on and so forth. And all you need to do is to follow the installation instructions. For example, for macOS, here you can download the installer certified by the EDB and so on and so forth. Also, for example, if you want to use the postgres.app or homebrew and so on and so forth. The same for Windows. Just click on the Windows link, and then you have download the installer. Also, you can see the versions and what versions are available, and so forth. So this is how you can install PostgreSQL on premises for your operating system. Now, in the next part, let's see, in case you want to use Docker, let me show you how to install PostgreSQL as a Docker image or a Docker container running on your Docker machine. Now, if you want to use PostgreSQL on Docker, all you need to do is to go to hub.docker.com. So this is the Docker Hub website, and all you need to do is to search for Postgres. Okay, so here we see that we have the first image, and always try to look or to search for the Docker official image. So then, in order to install it, so let's say we want to use the latest version. So here we have all the information we need, and here we see that we have this command right here. So all we need to do is to copy this command, and here we see that we have this environment variable, which is important and which is mandatory in order to make PostgreSQL running correctly on Docker. So here we have Postgres password, and you need to provide the password for your PostgreSQL, and the user will be Postgres just like this by default. So then I will show you how we can use this in order to connect to our database and display all the data we need. So all you need to do, just copy this one and run it on your terminal, and also make sure you to have a Docker desktop installed on your machine, and then you're good to go. So I assume if you have Docker and a little bit familiar with Docker, so it will not be a complex task to set up and install a Docker container on your machine. Now let's see how we can explore our database. So here, if you have IntelliJ with the ultimate version, all you need to do is to select and click on this database. Otherwise, you can go to View, and then you will have Tool window, and then you will have Database right here. So just click on it, and it will display this bar right here. So then in this plus, so let me make it full screen. So then on this plus, just click on New to select a new data source. So when you highlight this new data source, you will have this pop-up right here. And then all you need to do is to search for the database that you are using. So in our case, let's search for Postgres. And then when you click on OK, you will have this pop-up right here. So here, all you need to do is like to provide the name. So also you can, for example, let's say test, just an example. So this will be the name of your data source. And then, so if it's the first time that you are using this tool, you will have a link right here telling to download the driver. So just go ahead and click on it. But for my case, since it's already downloaded, so I don't have it anymore. Then the next step is, here we need to provide the information about the host and the port. So the host, it's always localhost, whether you are running your PostgreSQL on premises or on a Docker container. So it's always localhost. And the port, if you did not change it, it's by default 5432. Then we need to provide the authentication. So these are the username and password that you provided when you installed PostgreSQL. So for my case, it's Alibu and then Alibu as a username and password. And now all I need to do is to click on test connection. For the database, just leave the database as a database by default, which is the Postgres. So you don't need to change it. Or if you have different ones, all you need is just to select the database that you want to connect to. So here we see that we have this URL right here, and we will need this one later on. So I will show you again how we can also retrieve it again. So now all we need to do is to click on test connection to make sure that we are correctly, or we can correctly connect to our database. So make sure you have this succeeded message. Otherwise, you need to check the information or the inputs that you provided in here. So now all I need to do is to click apply and then OK. So here, let's explore together this UI. So here, this is the data source that we call test. And here we see that we have a PostgreSQL, it's one of 3. And then we have the public schema. So here also we can select all the databases that we have or that we will create in this. Okay, so now for the moment we don't have any database selected. Later on, when we create our first database, we will be able to select it and display it in here. Okay, so that's it. Now I will show you, if you don't have the IntelliJ Ultimate version, what is the alternative to connect and to explore the database. For the students that they don't have the ultimate version of IntelliJ and you want to have a different tool that will help you exploring any database you want. So I recommend using a tool called dbeaver. So this dbeaver is an open source and free cross-platform database for developers, database administrators, and so forth. So all you need to do is to whether to Google dbeaver or just go to dbeaver.io. And when you click on the link, you will have this interface and then you can click on the download link. But before going to the download, all you need to do, let's first explore the UI. So it looks a little bit similar to the UI that we are using on IntelliJ. So here you have the databases that you can select or the data sources. Also even to connect to a database, you can change the theme from light to dark. Also, you can see the diagrams, you can see almost everything, and even to connect to the database, it's pretty much similar as the steps that we followed together. This is something that I recommend for people that they don't have the ultimate version of IntelliJ, but for me personally, I prefer having everything in one place and in one UI. So that's why I will be using IntelliJ for the database, but for you it should be the same, exactly the same way, even if you don't have the ultimate version. To work with Spring Data JPA and data persistency in Spring Boot project, all we need to do first of all is to add the required dependency. So to add a new dependency, we need to go to our pom.xml and then let's make this one full screen and let's add a new dependency in here. So after the Spring Boot starter web, here open a new tag and then you will have the auto completion dependency. So I will click on it. Otherwise the dependency looks exactly like this. So it's a dependency tag and it contains a bunch of information. So we have first of all the group ID and the artifact ID. So the group ID for most of the Spring Boot starters, it's always org.springbootframework.boot. Sorry, it's org.springframework.boot. So then I will paste this one in here, and then the artifact is the starter name, and all the starters all the Spring Boot starters, they always start with spring-boot-starter and then the starter name. And here, as you can see in this list, we already see that we have data JPA. So this is the dependency that we need for our project. So let's select this one. And then of course it will suggest the group ID. Since it's the same one, we can also double click it or even ignore that. And also don't forget to right click on this pom.xml, and here you have Maven and then reload project. So this will allow and will tell Maven to download all the dependencies, and as you can see here, so now IntelliJ is downloading all the required dependencies, including this Spring Boot starter data JPA. So now if we integrate and add the Spring Boot starter data JPA, we can now run the project and see what will happen. So let's also explore the logs together and see what will happen. So the first thing, the application is not running because we have an issue, and the issue is failed to configure a data source or a URL attribute is not specified and no embedded data source could be configured. So I will explain this in the next video. So now we added a dependency and now we can start configuring our database. As we mentioned before, Spring Boot starters, they leverage auto configuration whenever it's possible. And after adding the dependency for the Spring Boot data starter data JPA, we saw that when we started the application, we had a failing. So here the mention on the description says failed to configure data source and the attribute URL is not specified. This means that we need at least to give some configuration and some details to this starter in order to auto configure the connection to the database. And this is what we will be doing in this phase. And first of all, let's go to our application properties file. And here, as I mentioned before, so let me first clean it up. And as I mentioned before, and in this course, I will be using the YAML representation. So to do so, you have two options: whether to remove this application.properties file and create another one with the YAML extension, or all we can do is just rename it using this shortcut and change the properties to YAML. So you can use whether YAML or YML. Okay, so here I will click on refactor. So now my application file is using the YAML representation. So now let's start configuring the connection to our database. And to start the configuration, first of all, we start with providing the data source configuration. So with the data source configuration is located under Spring, and then colon, and then here you need to be careful. So this is a tab, it's not a space, or it's not 3 spaces or 2 spaces, but you need to use the tab. Okay, so here, for example, if I remove it, I need to use the tabulation, as you can see in the shortcut here, and then data source, and you see here that we have this auto completion already. So it's spring.datasource, and then we need to specify the URL as mentioned in the exception that we have. So here also we will type URL, and we see here already in the description it's JDBC URL of the database. So it's not Hikari, it's not DBCP2, and so on and so forth. So you need to be sure and to be careful choosing the right property. So here I will choose URL, and then where can I get this URL from? So here we can go back to the database and then right click on this data source that we created before, and then click on properties. And here we will see that we have this tab again and this window to configure the connection, and then the URL is exactly this one. So let's copy it, close this one, and we can also close this, and then paste this one here. Now let me explain to you what is, or like how this URL is composed. So here is the connection type. So we want to have a JDBC connection, which is Java database connectivity, and then this is the database type, which is in our case is Postgres SQL, because we want to use Postgres SQL. For example, if you are using MySQL or Oracle or something like that, it will be exactly that one. And then we need the host name of our database, and in our case, since we are using locally our database, it's not a remote one, so it's localhost, or even you can provide the machine or like the remote machine address or IP address, and then the port. By default it's this one, and if you have a different one you can also use it. And finally, this is the database name. And for the database name, I will create a database later on, and I will call it demo_db, and this will be our database. So in the next phase, we will create this database. So first of all, let's continue with the configuration. And then, of course, within the data source, we need to provide other information, which is the username and password, which are the credentials for our database or for Spring Data JPA to be able to connect to the database. And it will be exactly the same as we provided here when we tried to connect the first time to our database, which is in our case, in my case, sorry, it's Alibu as a username and Alibu as a password. So here I will also provide this information. So choose username, and again be careful, it's not Hikari, it should be directly datasource.username, and in this case it will be Alibu, and then password, and also choose the second one, not Hikari, okay, and it will be also Alibu. And then we need to tell Spring Data JPA which driver to use in order to connect to the database, because as you know, to connect to any database we need a driver. So here, if I choose also driver class name, it is under spring.datasource.driver class name, and here I need to provide the class name for our Postgres SQL. And in this one, we just need another dependency to add to our configuration. So let's go ahead and add it. To add the Postgres SQL driver, we need to go again to our pom.xml file, and then we need to add another dependency. So here I will click and add dependency, And then the dependency, it has an artifact ID, which is called PostgreSQL or PostgreSQL. And then the group ID is org.postgresql. Also, we can add a scope, which is, in our case, it should be runtime. So here, this is the scope of this dependency. So it's available on the runtime. And then I click on this pop-up right here, or as I mentioned before, just right click and then Maven and then reload project to reload and download all the necessary dependencies. So now we have our PostgreSQL driver available. Let's go back and continue with our database configuration. So now if you go back to our application.yaml, and in this driver class name, if I just type command space, and here we will see that automatically IntelliJ will propose driver coming from org.postgresql package as a driver class name. Otherwise, you can just manually type org.postgresql.driver, and then you will have the driver. And in case you don't include or you forgot to include the driver, it will be highlighted as a non-found or a class not found exception or error right here. So don't worry about that. In case you forgot to add it, IntelliJ will highlight it automatically. So now the first part is ready, and now I can start the application and see what will happen. So here, let's start the application and check if Spring will be able to locate and start the application. So yes, the first part is done. So let's check right here, and here only thing that we have, the database DemoDB does not exist. So it was able to locate the database using the username and password, but it didn't find any database called demo_db. Also, I want to show you something. For example, if I change the username and the password, or just the username or password, to provide wrong credentials and restart the application, we will see a different exception. So here it will say that unable to authenticate. So here it says password authentication failed for user Alibu DDD. So even if I fix the username and provide a wrong password, we will see again the same exception, fatal authentication, as you can see right here, but this time it will say that password authentication failed for the user Alibu. So here, like we know now, we understand that Spring is able to connect to the database. Now let's move on and create our database and restart the application. So in this step, let's go ahead and create our database. So in here, click on database, and on your data source that we created, we called it test, right click, and then we have new, and then, so let me just make it wider right here. So again, right click and then new, and you see here database. So select database, and then let's provide the database name as we mentioned before, demo_db, and even you will see the SQL query command that it will be executed, which is create database and then the database name. So click OK. So here we see that we have this DemoDB, but it says here that no schema selected. So all we need to do is to click on 0 of 3 right here and select the public schema, which will hold our database later on and the list of the tables that we have. So in here we have empty schema for now, and we don't have any tables. So let's move on and check that. So now let's create our first Java class, which will represent a table in our database. So I will explain everything later on, but first let's start with creating a new class, and let's call it student, for example. And in this case, so here the student will hold the information of our student. So let's say first our student has a private integer ID. So this will be the identifier or the unique identifier of our student. Also, it has a string first name and then a private string last name. So let me make this one full screen, and string last name. And then let's say also our student has a private string email, and finally a private string age. Sorry, the age should be an int. So here, this is the representation of our student. So again, let's go ahead and generate some getters and setters, because as we mentioned before, we need getters and setters. Let's click OK. And then we need for example, a constructor if you want to. So let's create a constructor. And for this constructor, let's use all the parameters except the ID. So this is how we can construct a student using all the fields that we have right here. Also, you can just ignore that, and we can use setters later on to create our user. So now we have our object student or student class ready. Let's move on and let's see how we can transform this student class to an entity, which will be persistent entity, into our database. Before transforming our class to an entity, let's first define what is an entity. So in Spring Data JPA, the term entity refers to a Java object that is meant to be persisted in a relational database using the JPA, or aka Java Persistence API. So any entity represents a table in a database, and each instance of an entity represents a row in a table. So the entity fields represent the column of the table, and the state of an entity represents the data in a row. So to map an object to a database with the JPA, we need to annotate with entity, and the class must have a no-args constructor, which can be public or protected. Also, it should contain an identifier, ID, and it's a best practice also to include the table annotation to specify the table name if the table is not specified, so the table name will default to the class name. So Spring Data JPA uses these entity classes to generate SQL queries and to convert the results of those queries back into objects that you can use in your Java code. So the actual database interaction is performed by the underlying JPA implementation, such Hibernate in our case. So in the next phase, let's move on and transform our student Java class to an entity. So as mentioned in the previous video, we need within Spring Data JPA, and if we want to transform a Java class to an entity, first of all, we need to have an empty constructor or a default constructor with no args. So let's go ahead and generate that one. So here, let's generate a constructor. And to generate an empty constructor, just click or select the class name right here, and then click OK. So now we have our default constructor. Let's move on and transform this student class or student Java class to an entity. So as we mentioned and explained before, all we need to do is first of all to have the entity annotation on the top or on the class level. And here, be careful, the entity is coming or comes from the Jakarta.persistence if you are using the Spring version 3. Also, if you are using a lower version, it will be javax.persistence. So here, let's select this one. And here directly we see that IntelliJ is highlighting the class name. And if I highlight and check what is the error, so it says that the persistent entity student should have a primary key. So we need to specify a primary key every time we create an entity. And to provide a primary key, it's so easy. Just go ahead and choose what is the primary key of your class or of your entity and add the ID annotation. It's all also coming from the Jakarta.persistence package. And now we have our student entity. So now let's go ahead and see if we are able to generate or to manipulate or to start the application within these small changes. So if I click here to start the application, we see that the application is up and running. And also let's see if we have any logs that we can use. Also, we see here like starting the application, and we also see that we have some annotations or some logs from Hibernate. So here it's Hibernate version 6.1.7, and also it's using the dialect, PostgreSQL dialect, and the JTA platform implementation, which is the no JTA platform, and so on and so forth. So here the application is up and running. And if I go to my database and I try to refresh this one and check the public schema, also if I refreshed again, I don't see anything. Spring and JPA and the Hibernate implementation of JPA, they provide a tool and configuration to auto create and to auto generate the tables within the database. So in the next part, let's go ahead and see how we can tell Spring and tell Spring Data JPA to be specific to generate or to auto-generate our database. So now to define the extra properties, first I will stop the application and then I will go back to our application.yaml. Let me make it full screen. And then we need to provide few properties. So here within the properties, we see here that we have spring.dataSource. Now at the same level of data source, it will be Spring and then JPA. And then we can specify some information. So here within JPA, we have Hibernate. And then within Hibernate, we have this information or this property, which is called DDL Auto. So this DDL Auto, or like this mode, it stands like DDL stands for data definition language, and this is the behavior or like what we want exactly Hibernate to do when we start the application. So here we have 5 options. First we have create. This means that it will create the schema and destroy previous data. So you need to be careful when choosing this option. This means that every time you start the application, Hibernate will create a new schema and destroy the previous data. So it's okay on the development phase, or like on the early phases of your application development. Since you don't have the schema fully implemented, you can keep it as create. Otherwise, I would say you keep it to validate or to update. So the next option is create drop. So create a drop, it will create the schema, and then at the end of the session, it will destroy the schema. So it will remove the whole database. So it's like you don't have any database at all. So we have also none. So this means that we want to disable this DDL Auto, and this is valid, for example, in production mode, if we want to use a database migration tool like Flyway or Liquibase to manage our database. We have update, so it will update the schema if necessary. So if we don't have a schema, it will create it, and every time we make changes, it will try to update the schema if there is changes. And the final one is validate. So it will validate the schema and it will make no changes to the database. So assuming that we are managing our database using a database migration tool like Flyway, for example, and this option validate, it will try to compare the existing database to the representation or to the Java representation in our code, and it will validate this one. So here, let's go ahead and choose create since we're still in development mode. Also, we have other properties under JPA. So for example, we can also show the SQL queries. So here, when I choose JPA.showSQL query, show SQL, here we see that by default it's false, and then we can change it to true. So this means when we run the application and we try to execute any query or any method that will interact with the database, we will see the query displayed in the console. Then under JPA, we have also properties, and within these properties, we have Hibernate and Format SQL. So if we have an SQL query, if we don't add this format option, it will be displayed as a full line. Otherwise, we can format this SQL query and it will be nicely displayed. So the property for this one is Spring JPA properties and then Hibernate, and then we have Format SQL. So this Format SQL, all we need to do is to set it to true. Also, we have another property which is available again under JPA. So it's spring.jpa, and here we have database. So it's the second option. So here, this is the target database to operate on. So it's auto-detected by default if you want to. So Hibernate will try, or JPA will try to auto-detect what is the database that we are using, and also we can see it here in the logs. So as mentioned here before, so here as we can see, using the dialect, Hibernate dialect, and then Postgres SQL dialect. So I will also copy this one, and then we can even provide it manually, so we can tell JPA that we are using this database to be more specific and more precise. Also, we have another option which is called database platform. So the database platform, it's also, so this property specifies the Hibernate dialect for the target database. So the dialect defines the specific SQL syntax and features supported by the database. In this case, we will use this one, just the one I just copied from the console, and to set it to indicate that the Postgres SQL dialect should be used. So now we have everything and all the properties that we need for JPA. Now let's go back again and restart our application and see what will happen. So just click on start again and let's check what will happen within our table. So first of all, if we check the log right here, so we see that since we used this show SQL true, we see that we have the SQL query right here. So this is the SQL query for creating the student table. Also, we have this format SQL true, so we have a formatted query. All right. So now if I go back and check my database in here, so select public or the schema or even the database right here and click on refresh. And here, if we expand, we see that we have one table right here. So we have a table student. And the table student contains all the information or all the properties that we provided: ID, first name, last name, email, and age. So the age is of type integer, same for the ID. And we have email, first name, last name of type varchar, which is the SQL representation for the string type. So now let's move on and see how we can again play more and more with the Hibernate or the annotations for our entity. What if we want to change the table name? So by default, this entity annotation, it will use the class name as a table name. But what if we want to have a different one? So let's say, for example, I want to call my table students, not just student. So in this case, we can use the table annotation, and it always comes from the Jakarta.persistence package. And here we can specify the property equals name. And let's have a look on this annotation. So here it says that specifies the primary table of annotated entity. So we need to have the entity annotation. So additional tables may be specified using secondary table and so on and so forth. So here, if no table annotation is specified for an entity class, the default value applies. So here, for example, we have entity and we have the name cast, for example, for customer, and the schema, we can also specify the schema. So by default, if we don't add this table annotation, it will take, or the entity annotation will use the entity name or the class name as a table name. So here, let's say, for example, t_student, just to say table student. And if I rerun the application, we will see that the database will change and the table will be again changed. So here we see that create table, even in this SQL query, create table t_student. So here, if I refresh my tables, we see that we have a table now, it's named tstudent, and also we have the same columns, ID, age, email, and so on and so forth. So this is the use case of this table annotation. We also can have extra control on the different fields. So for example, if I want to change a column name, there is an annotation called column, and this column annotation has a bunch of properties. So we have name, and here the name of the column. So default is the property of the field name. We have unique, nullable, insertable, updatable, column definition, table length, and so on and so forth. So here we can specify many properties for the specified column. So for example, let's start by changing the name. So for example, for this first name, I wanted to have c_fname, just c to say colon, and then fname. Again, like we can use the same annotation for the other fields, but let's just try on only one. So here, if I restart my application and check again the database, here even in the SQL query, we see that we have again cfname. So if I refresh my table right here, we see that we have the first name is now called c_fname, as we mentioned in here. So now we have our first name named to c_fname. Also, we have other properties that we can specify. So in case, for example, I want to have extra, or like I want to have some precision or size, so I can also use the length. So as you can see here by default, so let me make it full screen. And as you can see, the length of a string by default is 225. So Hibernate will detect that automatically, but I can specify, for example, the length of my first name should be exactly 20 characters. And if I restart my application, just to recreate everything from scratch, we see that here the CF name or the colon first name, it's a type varchar, and now the length is 20 instead of 225. You can increase it or you can even decrease it to have, for example, if you have some specific cases where you need for some specific field or column to have a specific length. So you can use this property length to specify or to provide more precision to that. So here, if I refresh my table, and in the columns, and again, if I go to CName, we see that the CF name is of type varchar, and the length of this varchar is 20 characters. So now, let's see if we want to have a unique entry for specific column. So for example, for this email, we know that emails should be unique per user or per student or per person. So again, I can use the colon annotation in here at this level. And here there is a property called unique, and the unique is by default equals false. This means that we can have duplications for this specific column. But if we change it to unique true, and if I restart the application, and let's first check the logs, we see that we have here the email is of type varchar 225, and after that we see that we have alter table if exists, tstudent, and add constraint. This is the constraint name, it's UK, and this is a generated value, and we have this unique constraint for the colon email. And again, if I refresh my table right here, let's see what are the changes that we have. So we see that we have an email right here, and then we have the keys. So first we have the T student P key. P means primary and key, it's for key. And then we have the unique constraint applied on the email column right here. So this is what we exactly the result of this SQL query. We can also add some extra properties and constraints. Let's say, for example, I have right here a private string, let's say just some colon, just like that. And now I will use the colon annotation, and I can specify if this some colon is insertable or updatable. Let's say, for example, let's make it updatable true. So by default, any colon is updatable true by default, and then I can make it updatable false. And we have a specific, or we might have a specific use case for a field that should not be updatable, which is, for example, the creation date. So we can have a creation date for any field or for our entry in the database, and we don't want this creation date field to be updatable every time. So we can just make it updatable to false. And also we have another property which is insertable, and by default it's true. We can make this insertable false. So this means that we cannot create or we cannot insert a value for this specific field. So now let's stick with this updatable, and here let's again restart the application, and we will see that we might have another constraint. So here, if I refresh my table, and for the tstudent, we see that we have some colon, which is a varchar, and then we don't have any keys, but Hibernate will manage this automatically, and it will make this field called some colon not updatable. In this part, we will see how we can play a bit more with the IDs. So when it comes to the identifiers of tables, and especially when we use the type or the digits type, which is integer, float, double, also long, and so on and so forth, we can tell Spring and Hibernate to automatically generate the ID for us. And to do that, we can use an annotation called generated value. And this generated value, again, it's from Jakarta.persistence API. And let's have a look on this annotation. So if I go to the definition of this generated value and have a look on the documentation for it, so it says provides for the specification of generation strategies for the values of primary keys. So the condition here, it works only with primary keys. So the generated value annotation may be applied to a primary key property or field of an entity of mapped superclass in conjunction with the ID annotation. So we need to have the generated value always within the ID annotation. So the use of the generated value annotation is only required to be supported for the simple primary keys. Use of the generated value annotation is not supported for derived primary keys. So we cannot use the generated value annotation on derived primary keys, for example, like strings or composed keys. So here also there is an important property, which is the generation type. So the generation type, as you can see, it's optional and it has a default value, which is auto. And then the primary key generation strategy that the persistence provider must use to generate the annotated entity primary key. And then let's have a look on the different types of the generation type. So here, if we go to the enum generation type, we see that first we have table. So the table indicates that the persistence provider must assign primary keys for the entity using an underlying database table to ensure uniqueness. So this means that Hibernate will create a table within our schema, and it will use that table to store the IDs of the entities that we want to use. Again, we have another property, which is sequence. So this indicates that the persistence provider must assign primary keys for the entity using database sequence. So database sequence, it's something related to a database, and it's somehow like a table where we have a sequence of values. Then we have the identity. So this means that and indicates that the persistence provider must assign primary keys for an entity using database identity colon. So the database, or like the provider, will use a database identity colon to auto-generate the IDs. Also, we have another property which is called UUID, and the UUID is for universal unique identifier, and this indicates that the persistent provider must assign primary keys for the entity by generating an RFC of type 4122, which is a universal unique identifier. And finally, we have this auto, which is always recommended. And this indicates that the persistence provider should pick an appropriate strategy for the particular database. So this means that when we set it to auto, which is the default one, Hibernate will check within the database provider or the persistence provider. And in our case, for example, it's Postgres SQL, and it will choose the appropriate and the best generation strategy for our database. And here there is something which is really important. So the auto generation strategy may expect a database resource to exist, or it may attempt to create one. So it will attempt to create the resource. For example, let's say it uses a sequence. So the auto strategy will try or will attempt to create this resource if possible. If not, it will raise an exception telling that it's not able to create this one. And for example, I can give you an example from my previous experience. So Oracle databases, they work with sequences, and you need to manually create the sequence in order to use it as a generation type. So now let's go back to our code and let's restart the application and see if we have any changes. So first, let's check the logs. And as you can see, first we have this Hibernate query that was executed, which is create sequence T student sequence. Starts with 1 and increment by 50. So here, Hibernate created a sequence, called it T underscore student underscore sequence, or seq, and it starts from 1 and the incrementation is done by 50. And then we have the table and we have the unique constraints that we added. So now if I refresh again my tables, we see that we have the student, and now we have one sequence package or a folder that was created. If I expand it, we see that we have a T student sequence, which is of type big int, and this is just a sequence as you can see in the icon right here. So now that's it with this, with the annotations that we can use within our entities. Now let's move on and see how we can persist data into the database and how we can perform queries like inserting, reading, updating, deleting, and so on and so forth. So when it comes to data persistence and to persist data in a database, Spring provides us with a list of interfaces that we can use to simplify the life of developers. So Spring provides an interface called repository, and this interface is extended by multiple other interfaces. And we have here, for example, we have this repository, and we have the CRUD repository and list CRUD repository. And also on the left hand side, we have the paging and sorting repository and list paging and sorting repository. And all of them, like the basic one, or like the first one, is JPA repository, which extends all these interfaces. So if you extend or if you use the JPA interface or the JPA repository interface, you have access to all these interfaces right here. And all we need to do in order to access or to have a data access layer in our application is to create an interface and extend one of these 5 interfaces that we see right here, which is whether JPA repository, list CRUD, list paging and sorting, CRUD repository, or paging and sorting repository. So each one of them comes with a list of methods, predefined methods that we can use to operate or to execute some SQL queries. So the JPA repository is designed to simplify the development of access layer code by abstracting away the common data persistent operations. So it provides methods such as save, find one, find all, delete, and more, allowing you to interact with the underlying database without writing explicit SQL queries. So this is the important thing and the important part of using JPA repositories or using the repositories from the Spring Data JPA. And the JPA repository interface comes with some features. First, we have the CRUD operations. CRUD stands for create, read, update, and delete, which inherits from the basic CRUD operations from these interfaces we see right here, enabling you to perform standard database operations like saving entities, retrieving entities by ID, deleting, and finding all entities, and so on and so forth. Also, we have query methods. So JPA repository supports the creation of query methods based on method names. By following naming convention, you can define method signature that automatically generate the appropriate SQL queries. For example, if we want to have a method find by first name, and we provide the string first name as a parameter, or find all by age greater than int age, and so on and so forth. So this can be implemented without writing explicit queries, and we will see later on by example how we can implement this. Also, we have the derived query methods. So along with query method based on method names, JPA repository supports the creation of more complex queries using derived query methods. So this method derive the query based on the structure of the method signature and the names of the parameters. So this allows you to define queries with conditions and join multiple entities together. We can also have a custom query definition. So in addition to the query method, the JPA repository allows you to define custom queries using the @query annotation or the query annotation, and you can write JPQL, which is the Java Persistence Query Language, or native SQL queries, and map the query result to the entity or a custom DTO that you want to return. So by utilizing the features provided by the JPA repository, you can significantly reduce the amount of boilerplate code required for data access operations and leverage the power of query derivation and handle pagination and sorting with ease in your Spring Data JPA based application. So now let's move on and see in action how we can create repositories, and how we can generate methods, and how we can even persist data. To create a repository, all we need to do is to create a new interface. So select new and then Java class and select interface right here. And let's call our interface student repository. So in this way, we are creating a new interface, and to transform this student repository interface to a JPA repository, all we need to do is to extend the JPA repository. And the JPA repository is a generic interface. And let's see here, click always on download source to see everything and all the source code. And here we see that we have a T and ID. So the T represents the entity and the ID represents the identifier of our entity. So let's go back here and provide these types. So here, this is a JPA repository for our student entity. Okay, so this is like from the name, but here, like, our goal is to create a repository for our student object. So select the student here and then comma and the type of the ID. So in our case, the type of our unique ID of this student table is integer, as you can see here. So we have integer ID annotated with the ID annotation. So this is how you can identify or you can check the ID. And that's it. That's pretty much it. And here, even you don't need to add any repository or any component annotation, because Spring Data JPA will automatically understand that this is a repository, and it will transform this this interface to a managed bean or to a component or to a repository. All these names are valid for the JPA repository. So now let's move on and use this JPA repository and try to persist some data. Now, in order to use this student repository, all we need to do is to inject it somewhere in some class or in another Spring Bean, and let's inject it in this first controller. So I will make it full screen. And here I can also even clean up this one. And here I will create a private final student repository, and let's call it repository or even student repository. And then we need to generate, of course, a constructor parameter. And here we see that we will use the constructor injection. So as I mentioned before, we no longer need to use the auto-wired annotation. So here we have our repository available, and now we can just use it. So here in this post method, so let's say /students, and like to follow the namings. So now we have our first controller, and I want to use the post for the post mapping /student. And here as a request body, let's change this one to type student. Okay, so here we have the student, and I will just rename this one to student. So then it will not return a string, but I wanted to return the student object instead. So here it will return the student. So we will go back to this later on. And here all we need to do after receiving the student object, all we need to do is to call the repository instance that we created, and then we have a method called save. So the save, it takes an S of type entity. So here if I pass student, so this means that the student will be persisted. And as you can see, this method, it takes the entity as parameter, and it will return the same entity or the saved one. So all I need to do is to just return repository.save. And now let's start the application and go to Postman and start this and test this method. So this is our Postman interface again. Let's change the URL to students. And then we have a body. And for the body, it will be exactly the same way as the student object right here. So we need the first name, last name, email, and age. So first name, last name, email, and age. And I will copy these ones, and then I will just create an object of type student. So let me remove this, and then adding the colons everywhere. So here, and also for the age, and here for the first name, let's say Ali, and for the last name, let's say Bu Ali, and for the email, so this is my email if you want to get in touch with me. So it's contact@alibucoding.com, and the age, let's say I'm 34 years old. I'm getting old, but it's totally fine. So here we have our JSON representation for the student object. Now, if I click on send, let's see what will happen. So first we see that we have this 200 OK, and we persisted our object, and now we have the ID equals 1. So if I go back to my database, click on here, let's refresh the tables. And if I open this student, we see that we have an object that got persisted in the database. So here we still have this some colon that we added, but we can ignore it for the moment. And here we see that we have the object or the user or the student that we just inserted. So let's go ahead and insert another one and see the changes. So here, let's say John Doe. And here, for example, let's say John at alibocoding.com, and let's leave the age as it was and hit enter. So here we see that we have a different ID and we return the saved object. So if I go back to my database and refresh, so here you have the icon to refresh or to reload the page, and now we see that we have this user again inserted. So here let's just check again our entity, and we see that the email is unique. Okay, so now if I go back to Postman and try to insert the same object, click on send, and we see that we have a 500 internal server error. So if I go back to IntelliJ and inspect this one, let's see the type of the exception. So here we see that we have an error, duplicate key value violates unique constraint for this constraint that we created before. So just to remind you, this is the constraint that we created for the unicity of the email. So it's this one. And now we see the exception that we have a violation. And even we have more details. It says that the key email, like the field called email, and the value john at alibocoding.com already exists. So Hibernate is performing all the checks and checking that the email should be unique within our database. So this is how we can persist an entity. Now let's see how we can update an entity and how we can delete, fetch all, and the operations that we can use. Now let's implement another method that will return a student by its ID. So here we have student, and then I will pass as a path variable, and let's say student dash ID, and here it will return just a single student. So let's change the type, and here find student by ID. So this will be the method name, and of course we need our path variable, and here let's call it student dash ID, and then integer ID. So here we have our method ready, and now all we need to do is to use the method find by ID. And here this find by ID, it will return an optional of type student. So here let's pass first the ID, and then let's say or else, for example, null. Okay, so if we don't find the student with the specified ID, it will return a null object, or let's say even some new student. Okay, like an empty student object. So let's restart the application and let's go to our Postman and try to test this endpoint. So first let's insert an object, or like a few elements. So this one and this one, and we have 3 elements. So here if I test again the slash student, we see that we are returning 3 elements with the specified objects and values that we provided. And now if I say slash students slash 1, so it should return this first object. And if I click on send, so we see that we have only one object, and here before it was a list. So just to make sure, and as you guys can see, it's a list in here, and it's a list of objects. So now slash students slash 1, and if I try to find an object that does not exist, so for example a student with the ID number 10, which we don't have in the database, we see that we have an empty object with null values, and this because when we retrieved the student, we say or else new student, or we can just say or else null, or whatever you want. So this is how we can retrieve, and this is the method find by ID, that you can use to retrieve an object by its ID. So now in the next part, let's see how we can create a custom query and, for example, find a student by the first name. Now let's see how we can retrieve the list of students that are persisted in the database. So I will duplicate first of all this method, and instead of post I will just use get. So here it will be get mapping, and I will use the same URL students, and here like I will say find all students, and here instead of returning a single student I need to return a list of students. So here I will use list as a return type, and then I will just give it the type student. So here list of students, and here we don't have any request body since it's a get, and we don't have any parameters. And now instead of saving, we have a method called find all. So this find all method will return all the students that we have in the database. So let's restart the application and go to our Postman and test this one. So opening Postman, first I need to persist few data. So this is the first one, second one, and let's say this is the third one. And again, I will duplicate this tab, and here I will change this one to a get, and I don't have a body. And all I need to do is to click on send. So here we see that we have this 200 OK. And we see that we are fetching and displaying all the students or all the objects that we have persisted in the database. So it's Ali Bu Ali, and we see that the email is changing, and this is contact 1 and contact 31, the one that we just inserted. So this is how we can retrieve data from the database. And as you can see here, I did not create any SQL query for that, but all these methods, they come from the Spring Data JPA or from the JPA repository that we extended right here. So if I open this one, we see that we have a bunch of method right here, and even this find all, it comes from other interfaces. So here we have the save all, we have this find all method that we just used. So click on download source, and this is all the methods that are available. So let's see more and more methods and try to perform the CRUD operation. So here we have the create, and you have the read here. So let's check the delete operation and the update operation. So again, let's duplicate this method right here, and here it will be /student/search, for example, and then let's say student name. Okay, so here it will return also a list of students. So I'll just copy this one and replace it in here. So here we will say find students by first name or by name. It's also okay. And here we need student name instead of student ID, and the type should be of type string. But here, as we can see, we don't have any method that will return a student by name or by first name. So what we need to do, we need to go to our student repository right here, and let me show you how we can create a method that can filter, or behind that Hibernate will generate the query for us. So what we want to do is searching for the list of students. So first we need to provide the type, which is list, and the object, which is our entity or a DTO or any other object that Hibernate can be able to map it. So we have list of student, and then our method should start find all by, and find all because we want to have a list. If, for example, we want to return only a single student, we can use find by instead. Okay, but in this case we want to use find all by, and then after the find all by, all I need to do is to specify the colon name, like the Java colon name, like from the class, that I want to use it as a filter. So for example, here I want to use first name, so you don't use the C_F name, but you use the Java field of the Java class. Okay, so I want to use the first name as my filter. So all you need to do is to use a capital letter for the first for the field name. So as you can see here already, IntelliJ, so this is part of the ultimate version, this auto completion. And as you can see, IntelliJ is already suggesting first name as a filter. Okay, so now I say first name, and also I can add like. Okay, so this means that the first name contains this value, or I can say containing. So containing, this means any string I pass, it should be part of the first name. So for example, if I have a first name Ali, if I pass just L, it should return and filter all the students containing this L letter. So here, all I need to do is to pass my string P. So here P means parameter. So on purpose I mentioned P because you don't need to specify first name, for example. So because the type what really matters. So the type of the first name here should match the type of the parameter that you are passing right here. Okay, so now we have our method. Let's go back to our controller and call this method to return the list of students. So here we have find all by, and here we have first name containing. And then when we start the application and when we execute the query, we will see what is the output of this query. So here, instead of this string ID, let me just change it to name, and here pass name as a parameter. Now, if I restart the application and let's go back to Postman. So here I can clean the console so we can see the query that will get executed. I will go back to Postman. First, I need to insert some data. So this is the first one, and let's call the second one John. And let's call Cole, for example. And now let's go back in here. And now instead of passing this this ID, I can pass, for example, /Ali. Okay, and if I click on send, we see that first we have a bad request. Let's check why we have that. So we have a bad request because in IntelliJ here, when we created this method, we added /search, and within the Ali and the object or the value Ali, so Spring is trying to map the Ali to an integer. And as we can see here, let's check the exception, and it will say that it was not able to map or to convert the value Ali to an integer ID. So now let's go back to our IntelliJ, and also I need to insert some other data. And here let's click on send, and then also John, for example, and let's change this and click on send again because I guess it was not inserted before. So now if I go back to /students/search, and now if I pass Ali as a parameter and click on send, so we see that we have a list containing this object, which is Ali, Bo Ali, and so on and so forth. Now let's go back to the console and see the query that was generated. So here we have select, and we have the fields from student, where the CF name, so Hibernate was automatically capable of transforming this first name to use the colon called C_F name. And here we have like, and then so this is the value because it's an interrogation mark, and then escape the backslashes. So this, for example, in case we pass a backslash as a value. So this is the query that was generated behind, and all this came from just this method that we created right here. So we just told Spring Data JPA to search the list of students by first name containing. So any first name, or like the first name contains a portion of the string that we pass right here. All right, so now you understand how we can create queries. Now let's move on and see how we can delete objects, for example. Now let's create another method to delete a student. So here I will use a delete mapping, and then for the delete mapping, it will be /students/ and then I will need the student ID. So it will be student-id, and then I will have a public void, and then I will call it delete. So here, of course, we need our path variable, and then let's call it student ID as we mentioned before, and then I will need the integer ID, And all we need to do is to call our repository dot delete, and then we have a method to delete whether to pass the whole student entity or just delete by ID. So the delete by ID, we can just pass the ID. And here we can also use, as explained before, the response status annotation. And here, for example, let's say accepted or just okay. So for example, let's say HTTP status. And of course, we need to import the HTTP status. So now let's restart the application and let's go ahead and try deleting student by the ID. So now the application is up and running again. So let's go back to Postman. And of course, I need to insert some students, and I will insert another one. So here we have 2 students. Also, let's check in the database. So let's open the student table, and we see here that we have 2 students created. And now if I try to delete the second one, or the student with the ID number 2, let's see what will happen. So now let's duplicate this tab. So duplicate tab, and then instead of post, I want to send a delete, and then /student/2. And all I need is to do is to click send, and we see that we have 200 OK. And also let's go back and check in the database. So if I refresh, we see that the student with the ID number 2 was successfully deleted. Alright, so we performed all the CRUD operations. We saw how to filter, we saw how to create a custom method using the JPA repository. And now let's see how we can perform and add relationships to our entity. So here we have our student entity, and let's try to create other entities which will have some relation and mapping between them. So in order to create mappings and relationships with different entities, first we need to create the entities that we want to create the mapping for. So here, let's assume that a student is part of a school or studies in a school, and a student has a profile. So first, let's start with creating the entity school. So I will create an entity called school, and then of course we need the entity annotation. So we don't need the table because we can leave it just to school. And then we need the ID. So this will be the identifier, and then generated value, and let's say private integer ID. So this will be the ID of the school, and simply let's say this school has a string school name or just a name. Okay, so this is our school entity. And of course, we need to generate getters and setters. So let's select both of them and generate getters and setters for the ID and the name. And also let's generate a constructor. And this constructor, we can say a constructor using just the name, and another empty constructor, because if you remember, we need that. So here we have our school entity ready. Now let's move on and create the profile entity, and then we will start implementing relationships. Now let's create the other entity, which will be the student profile. So the student profile, again, we need the entity annotation, and we need also the ID. So this will be the identifier, and it will be a generated value managed by Hibernate. And then we will need a private integer ID. And then let's say the student has a private string bio. So this will be like just a bio or description for the student. We can also add many other fields for the profile, but for now, let's just keep it simple, and let's generate now getters and setters. So let's select both of them, and then again, let's generate a constructor. Let's generate an empty one, and let's also generate a constructor using the bio. So we can just create or instantiate a user student profile just using the bio. So now we have our student profile and school ready to use. Let's move on and understand the class diagram that we need to implement and the relationships between these 3 entities. This is how our class diagram looks like. So as mentioned before, we have one student, and a student has a student profile. So the student has only one profile. So that's why we see a one-to-one relationship between the student and the student profile. And then a student studies in one school. So here that's why we have a relation from the student to the school, which is mapped with the one right here. And then the school has many students. So one school has 0 or many students. So this means that we can have a school but without any students yet. But what if we have a student? The student should be assigned to one school. So this is how our class diagram looks like. Now let's start implementing the relationship between these three entities. And we will start with student and student profile, which will be a one-to-one relationship. Now let's create the first mapping one-to-one between the student and the student profile. So I will move this to the right. So I'm going to split it and move it to the right to have both classes open at the same time. So first what we need to do, so let me first remove this column because we don't need it anymore. And first thing we need to do is to create an object or a field of type student profile inside the student class. So let's go ahead, private student profile, and let's call it student profile. Okay, now from the other side, we need also to create an object or a field of type student in the student profile, but we will come back to this just in a few moments. So now to declare and to tell Hibernate that this is a one-to-one relationship between the student and the student profile, all we need to do is to add the one-to-one annotation. And this one-to-one annotation comes with some properties. First, we need the property mapped by, and this mapped by should reference to the field of type student in the student profile. So let's say here student, and then I will explain later on. And that's it. So here we have one-to-one, and also we can add the cascade type, a cascade type .all. So this means this cascading type, this means if I perform or if I delete a student, this means automatically I will remove the student profile at the same time without even performing a delete operation on the student profile itself. Now, from the other hand, on the student profile, I need to create a field of type student. So here, let's call it student. And here, be careful. This student should be exactly the same as the object mapped by, because the mapped by will look for an object of type student called student. So for example, just an example, if I say st and I start the application, so the application will fail because here in the student profile, we don't have any attribute or a field called student. So you need to be careful about this one. And then we need to add a one-to-one annotation also from this side. And now let's define where to add the join colon. So this means, because in class diagrams, when we have a relationship, we need to have a foreign key in one of the tables. So here, our primary entity is student, and then we have the student profile. So we can create a student, but we can skip and update the student profile later on. So this means that the student is the primary entity and the student profile is the secondary one. So in this case, we need to add the join colon annotation. So here we have a join colon. So this means that we want to declare a join colon. Let's give it a name, for example, student_ID. So this means that when we start the application, we will have an extra field in the student profile class or table having the name student_ID. So let's start the application and check that. All right, so the application is up and running. Let's check the logs first of all. So here we have, first we are creating the table school. So this, we will come back to this one later on. And then we have a student profile. And after that, we have the table called tstudent. So here for the student, we have the primary key, which is the ID. And in here, we have the student profile. And the student profile, we see that Hibernate created a new field called student ID, and it chose an integer as the type. So the integer, it chose it from the ID or the ID type of our student class. So now let's go back. Let's go ahead and check the tables right here. So if I refresh, we see that we have 3 tables. So here, if I open the student profile, we see that we have one foreign key, And if I expand this one, we see that we have this foreign key with this constraint. So FK for foreign key, and this is the key or the ID for this foreign key. And this one, it's the field student underscore ID, which is the field that we defined already. And it refers the table called T underscore student with the ID or the field or the primary key called ID. So in this way, we performed or we created our first relationship one-to-one between student and student profile. So now let's go ahead and create the mapping between the student and the school. Alright, now let's move on and create the relationship between the school and the student. So we said that the relationship between the school and the student is one-to-many. This means that the school has many students and a student can study in one school. So let's start from the school side. Here we need to create, first of all, a list of students. So because here we have one school can figure out many times in multiple students. So this means like the school has multiple students. So I will create a list of students. Let's call it students. And then we need to add the annotation one-to-many. So this means one school can figure out or can be or can exist in many students lines or many students row in the students table. That's how we can determine what is the type or which annotation to use. So then within the one-to-many, we need the attribute mapped by, and the mapped by should be exactly the same like the one-to-one. Should be, for example, in this case, school, and the school should be an attribute of type school in the student.java class or the student entity. So the first thing is to create a list of students when we have a one-to-many. So here from the school side, just as I mentioned before, we have a list of students, and then this list of students. So anytime or every time you have a list here, just go ahead and don't think twice and use the one-to-many annotation, and also use the mapped by attribute to map this list of students to the school from the other side. And of course, let's not forget to generate getters and setters. So let's generate getters and setters for the students. Let's click OK, and now we have students, getters, and setters. So let me just move them to the bottom, and now we have our student list. So this is how we can create a one-to-many mapping. So now let's move on and create the many-to-one mapping from the other side. So now let's perform the link and the mapping from the student side. So here, let's create a private school field. Let's call it school as exactly the name right here. So then semicolon, and here, so this means that we have many students to one school. So many students can study in one school. And every time you have the many to one annotation, always think about adding the join colon. So here, let's give it a name. So here, let's say school ID, school underscore ID. So now if I restart the application, we will see all the changes that we will have within our database. And of course, let's not forget generating getters and setters. So I will generate the getters and setter, and also the student profile, which I guess we forgot the last time. So let's click OK. And also let me move them to the bottom. And now let's restart our application and see the changes. So here, first, we can also check the logs. So here we have alter table student profile if not exist, and then we have alter table t student, and we are adding all the references and the links and the relationships. So here, let's open this again and let's refresh the tables. So we see that we still have 3 tables, but let's check now the the student table. We see that we have 2 foreign keys. So here we have the 2 keys for it, and then we have 1 foreign key, which is this one, which is called school ID, and it's referencing the school and the ID from the school entity. And here from the school, we have again the ID and the name, and we don't have any other foreign keys because the foreign key belongs to the student table, and the same here for the student profile. We have again our student ID, which is reference the T student ID. So like this, we are able, and this is how we can perform and create mappings between the different entities using annotations from the JPA and Hibernate and using Spring Data JPA. Now, let's move on and see how we can insert data. Before we move on to implement the controllers, let me first show you a way how you can check that you implemented correctly the mappings between the different entities. So here, open the database and let me make it a bit full screen. And then on the schema that you have or the database that you created, right click, and then you have this diagram menu, and then you can click on show diagram. So here it will show maybe two options, maybe not for you, but click on database schema if it shows the diagram type. So then let me close this one. We see here that we have the three tables that we already created. We have the student, we have the school, and we have the student profile. So let me just organize a little bit. And here, let's move this one. And then also you have this this link right here. And then when you make, for example, like when you move entities and so on and so forth, and to organize these lines right here, all you need to do is to click on apply current layout, and it will adjust itself in a smooth way. So here we have our student table, which also named T_student. And also if you highlight it, you will see also the script or the SQL script for it. And then we have here the student profile, and you see that we have the student ID as a foreign key. So the primary key will be with this golden key, and the foreign key it will be with blue one, and the same here for the student. And we see also that we have the school. So now let's move on and start creating the controllers for the school, and let's implement few methods to insert some school and then insert students and assign them to a school and see how we can do that. Now let's create our school controller. So right click and then a new Java class, and let's call it school controller. And then of course we need our REST controller annotation. And now let's create our first post mapping, and then it will be /schools, and then we have a public school, and it will be create or save, for example. And here we have our request body, and then we need the school object. So request body, it will be object of type school, and then let's name it school. So after that, we need, of course, to inject our repository. So it will be private final school repository, which we don't have for the moment, but we will create it in just a few seconds. And let's call it school repository. And now, even if you don't have it, so here just highlight it and use the auto completion, and it will suggest to you to create a class school repository or an interface or enum and so on and so forth. So in our case, we want to create an interface school repository, and we want to create it in the same package. So let's just hit enter. And here we just made a typo, so let's rename this one. So let's call it school repository. And then of course we need to extend the JPA repository, and we need to pass the school as an object and integer for the ID. Then let's go back to our controller, and here we need, of course, to add a constructor. So let me make this one full screen, and now we have our school repository, and now we can use it. So here in this method, all we need to do is just return school repository dot save school, not save all, just save, and then the school that we get as a parameter. So then I will just duplicate this one, and instead of a post mapping, I will create a get mapping. So now you are familiar how we create controllers, how we return objects, and so on and so forth. So we don't have any body, and we need to return a list of schools. So here we have a list, and then let's import this list, and then let's say find all. And here, instead of save, let's say find all. All right. Now let's start the application and insert some schools. And since we also have our student controller, which is already named first controller, so let's go ahead and just rename it and call it student controller to be consistent. So now let's start the application and go to Postman and start our new API and see how we can insert schools and assign students to schools. So our application is up and running. Now let's move to Postman and test the school controller and try to insert some schools. And then let's go and insert also some students. Now let's duplicate this tab. And then instead of students, it will be schools. And in the body, we will need only one attribute, which is the name. So let's just change this one and let's call it Alibu School. And here all I need to do is to click on send. And here we see that we have a 200 OK. So this means that the school was inserted, and we see that we have the ID and the student. For now, it's null because we don't have any students assigned to this school yet. Also, let's go to the database and check that. So here, if I refresh my database and open the school table, we see that we have the school that we just inserted called Alibu School. Now, if I want to insert a student, so let's see the structure we have right here. We have the first name, last name, email, and age. And also we have an object called school. So let's go to Postman and structure and create an object of type student to insert the student and assign it to the school that we just created. So here, let's go back to the first tab where we have the students to insert. And here, all I need to do is to add another attribute of type school. And this one is an object. So here, and all I need to provide is the ID, because Spring Data JPA uses the ID to insert an object. As you can see, the school that we inserted has the ID equals 1. So this is all we need to provide. So here we have the school and the ID. You can also provide the name and so on and so forth, but it will not affect anything because Hibernate and Spring Data JPA only needs the ID. So now let's click on send. And we see now this is the result. So first we have a 200 OK, and here we have the ID with the first name, last name, and the student profile. For now it's null. And we see that we have the school, which is ID equals 1, name, student, and the name and the student is null. So this is also not a problem. Now if I go back and duplicate the school request and change it to a get, and of course for the body we don't have anything, and I click on send. And here we see that we don't have a response yet. And this is because here we have, let's understand the structure. Let's go back to the code and let me open the student and the school. So here we have the school object, and the school object, it has a list of students. Okay. And then it will try to get the school and the students list. And then from the student, it will try also to load the school information, and then it will go back to the school and it will try to load the list of students, and so on and so forth. So we have here an infinite loop, and this is because Hibernate will try to load all the information all together. So let me show you how we can fix that. Before fixing the problem, let's have a look on the exception. So here I will use this soft wrap just to have everything wrapped. And here we see that we have this main exception and failure trying to resolve exception from this Spring framework, and call send error after this response. And this means that we encountered an infinite recursion with the JSON mapping. So here when Jackson tries to map the object, so when it tries to map or to transform or to create a JSON response for the school, it has a list of student, and then as I explained before, it will go to the student, and then the student has also an object of type school, so it will try also to serialize the school and back again. So we have an infinite recursion loop, or an infinite loop, and let me show you how we can fix that using the Jackson annotations. So for this one, we will be using two annotations, one on the parent level and the second one on the child level. So the parent level is where we have the list. So the school is the parent of the students. I'm going to make this one full screen. And here on the list level, we need to use an annotation called JSON managed reference. And this JSON managed reference, so this tells Jackson that the parent is in charge of serializing the child, and it prevents the child from trying to serialize the parent. Now, so we need the JSON managed reference on the parent level, and then we need to go to the child level, which is the student right here, and we need to go to the field of type school, and here we need an annotation called JSON back reference. So this is the back reference, or this will tell that this entity, the student entity or the student object, doesn't need to serialize the parent, which is in our case the school. So now let's restart the application again, and let's go back to Postman and try to insert the data once again. So here the application is up and running. So also let me keep it like this. I will clean up the console. So here again we need to insert the school and insert the student and assign it to the school. And now if I try to fetch all schools and I click on send, we see that we have a response and we have the status 200 OK. And here we see that we have the ID and the school name, and then we have the list of the students. So for example, if I insert a new student, so here let's say contact 2, and within the same school ID, and here let's say Ali Bu Ali, and I will click on send. So the student is correctly inserted. And now if I fetch again the list of schools, we see that we have the school with the ID number 1, and we have the list of students. We have this ID 2, it's the student we just inserted, and we have the first one, which is John Bu Ali, and with this email address. So now we have our application functioning, but there is one thing which is a little bit not okay with all that, is because we are exposing almost everything, and even when we want to insert a student, we need to provide the full school object. And imagine that we have other relationships within the school, within the student, like for example the student profile, and imagine we have subjects and so on and so forth. So this will make our object or our student object more and more complex, and it will prevent us, and it will add more complexity when we want to save or to interact with the student entity. So this is introducing us to a really important topic we will see just in a few moments. So let's move on and explore the next topic of our course. DTO stands for Data Transfer Object, which is a pattern often used in software design. The main purpose of a DTO is to encapsulate and structure data that needs to be transferred between different parts of a system or different systems entirely. A DTO typically includes only simple data fields, or also called attributes, and lacks the behavior of the model or entity it represents. So here, if we take the example of our application, we have a student and we have a school. We have also a student profile, which will hold some sensitive information about the student, like the address, like phone number, date of birth, and so on and so forth. And mainly, we don't need to expose this information to the outside world. And also, even for example, if you want to retrieve the information of the school, we only need to expose the school information. And since these information are represented by entities and stored into a database system, which is a secured system, so we need to expose only what the user or the end user is expecting and no more extra information. So for example, as I mentioned, for the user, for the student, we don't need to expose sensitive information such as address, date of birth, phone number, even if the student has a password. So we don't need to expose that. So then what we need to do, we need to include a mechanism in the middle, in between the entity itself and the outside world. So we need to add a mapper, and this mapper is just a simple mechanism. You can use many implementation or many tools and libraries to map objects. And then if we use a mapper, we can have multiple representations for the same object. For example, for the student, we can have a representation 1 only to expose first name, last name, and we can have another representation to expose or to receive data from the outside world in order to create a new student. And for example, we need only first name, last name, and email, and so on and so forth. So this is one of the advantages, is we can have multiple representations for only one object or only one entity, and this also applicable for school, student, or the student profile in our case, and generally speaking it's applicable to any kind of entity. And the REST API should communicate with the client through these representations, and we can have one representation for the read and other representation for the write. For example, to create a student, we can have one representation which holds the information, or like the minimum required information to create a student, and for the read representation we can have a different one or a different object that will be responsible for exposing only the necessary and non-sensitive information to the outside world. So when building a RESTful API, DTOs play a crucial role, and now let's give you some reasons why they are important. First of all, we have data separation. So the data transfer object pattern helps to separate the internal domain model from what is exposed through the API. This way, you can change your internal model without affecting the external representation. It also helps in not exposing sensitive or unnecessary data to the API customers. Then abstraction. DTOs provide an abstraction layer. They give you a clear structure of what your API will provide to the client, abstracting the complexity of the domain model. Then performance improvements. Instead of sending entire entities over the network, you can instead send a DTOs which include only the necessary information. These can significantly improve the performance of your API, as you can control the size of your response payload. Then we have flexibility. Since DTOs are separate from your domain model, they allow you to tailor your API response to exactly what your client needs, even if that does not exactly match your domain model. And here we are talking about multiple representations for the same object. And finally, versioning. So DTOs make it easier to maintain different versions of your API. By using different sets of DTOs, you can support multiple versions of an API simultaneously. And then in the next part, we will see how we can use this DTO pattern in our application. Now let's go ahead and create a new object that will represent a student request, for example. So let's start with the student, and here we have in our student controller, we have the bunch of methods that we created to persist a student, to fetch a student, and so forth. Now let's see what are the changes that we need to apply after creating our student DTO object. So I will close everything, and here right click and then new and then Java class. And for this example and for the DTOs, we will be using records, as I explained before what is the difference between records and normal POJOs. So let's say student DTO, for example. And here for this student DTO, it will be a similar representation to the entity itself. So here, to create a student, we need the first name, we need the last name, and we need, let's say, just the email, and the age is not mandatory to create a new student. So I will copy these fields right here. I will copy them, and then let's paste them in the student DTO. So here I will just paste these fields, and I will add the comma. And now we have our record ready to use. So also, since we have a relationship within the school, so a student is linked to a school, all we need to do is to pass a school ID instead of the whole object. So let's imagine that the information we have within the school is address, location, and like a bunch of information about the school. But for Hibernate and for persisting the data, all we need to do is the ID of the entity. So here within the student DTO, after the email, I will add also an integer school ID. So I will create an object and then we call it school ID like this. So now we have our student record or student object ready to use. Now let's move on and create an object for school also, and let me show you how we can use these DTOs to persist data and to send back information. So now if I close all these classes right here, and if I go back to the student controller, let me make it full screen, and here in the post mapping, or when we want to create a student, so here we are requesting an object of type student, which is our entity. But let's change this, and instead of requesting the student entity, let's request a student DTO object. So now we are asking the REST client to send a student DTO, which is represented by the first name, last name, and then field called school ID, which represents the identifier of our school. So then we see that the repository.save is now not working because here it's expecting a type student and we are passing a student DTO. So here, as you can see in this error message, so inferred type S of type parameter S is not within its bound, so it should extend com.alibu.example.student. So we need to pass an object of type student. So now let's see how we can use this DTO to save an object. So as we explained before, here we need to transform this student DTO object to a student object. So here let me create a private student method, and let's call it toStudent. Okay, and this toStudent method will receive exactly this object. So let's call it DTO right here, just for clarity. And here what I will do, I will create a var student equals new student. So here I just have a new student, so I can use also this constructor that we created before, or we can use the getters and setters. So it's actually up to you to choose which way you want, but let's go ahead with setters and getters. So here let's say student.set first name, and then the first name is the one coming from the DTO.get or .first name, and then we have student.last name. So here it's a set instead of a get, and then we need the DTO.last name, and then we have student.set email, and then again from the DTO.get email. So here it's not a get, like within records we don't have gets, but we have methods representing like with the field name. So now we have all the three fields that we specified for this student DTO, first name, last name, email, and now we need to set an object of type school and link it to this student object. So here I will create a var school equals new school, and then for this school I can just use DTO and just set the ID. So here just school and then DTO. So here I need to set the ID, sorry. So it will be my DTO.school ID. So here I have, or I prepared my school object. Now I need to assign the school object to the student. So here I will say student.set school, and then the school object I just created right now. So now we have our toStudent method. So again, let's just return the student object. So here we have our toStudent method. So all I need to do here is just replacing this method call right here. So I will create a variable, and here I will just rename this one to DTO or student DTO. You can name it as you want. And here I will create a var student equals toStudent from my DTO. Okay. And like this, I will be able to persist the data. Okay. So let's go ahead and try this. So now the application is up and running. Also, I will just do a small change here in the application.yaml. Instead of using create drop, I will use just update. So because I don't want to lose the data each time I restart the application, and now I will just restart again. And let's go ahead to Postman and try to create a new student. So here in Postman, first we need to create a school. So let's just send this one. and we have the ID number 1. And here we have the method that will allow me to create a new student. Okay, so it's a post and then student. So here we said that we no longer need the age since it's just a requirement from us. And here, instead of passing the school object, all I need to do is to pass a school ID right here. And this school ID, I will give it the name 1. Value, not name. And then let's click on send and see what will happen. So here we have 200 OK. So this means that the student was persisted and it was linked to the school that we recently created. So let's go back to our database and check if we have everything persisted and working as before. So here, let's go to the database. Let's refresh. And then here we have our school. And if I open the student, we see that I have the student that I just created with the name Ali Bu Ali, and we have also the school ID equals 1. So like this, we saw that using the DTO, we are no longer requiring all the information or all the fields from the entity, but it's just a representation that suits our need. But we still have one small issue. We are returning again the student object. So we are returning or exposing the student entity. And here, as you can see in Postman and the response, we have the age, which we don't want to expose, and also have this object student profile, which is null, and so on and so forth. Also, we have the ID, and maybe we don't want to expose that. So now let's see which DTO we need to create in order to return a proper object and a proper response to the user. So now let's create another record, and with this one we will call it, so it's a record, and we will call it student response or student representation DTO. So let's say student response DTO, and exactly as we did right here. So we need the first name, last name, and email, for example. So these are the information that we want to expose to the end user or to our client, to our REST client. So let me stop the application. And here, all I need to do, I need to go back to my controller. And then instead of returning a student, I would return a student response DTO. Okay. But here again, we see that this repository.save is returning a student object, and I need to return another type. So again, we need another method right here. So we need a private student response DTO, and let's say to student response DTO. And this to student response DTO should receive a student object as a parameter. Okay. And then all I need to do is return new student response DTO, and then I need to pass all the information that I need. So it will be student.getFirstName, and then so let me inline this one. So it will be student.getFirstName, and then student.lastname, and finally student.getEmail. And like this, we have our student response DTO, and here semicolon. And now we have our representation ready. So here I will say just var saved student equals this one, or like the result of saving the student. And then all I need to do is to return to student response from the saved student. And like this, I have again a new object or a new representation of the response that I want to expose to the customer or to my REST client. So let's go ahead and start the application, and let's try this out. So now if I go back to Postman, and let me duplicate this tab, and let's use a get in here, and let's search student by its ID. So let's say, for example, student/1, or let's save another student again, and we will come back to that method later on. So here, for example, if I say Ali or like John Doe, and here let's say it's john.@alibucoding.com, and now if I click on send, we see that we have the response or a different response from our backend, and we do not expose extra information. So here the response is really encapsulated and an abstract response without any further information that we should not expose to the outside world. So here we are exposing only the necessary information. Even if you see, for example, that this email is a sensitive information. All you need to do is just remove it from the DTO and adjust the mapping. Now for our school object, let's create a DTO for that. So again, just new and then record, let's say school DTO. And here in this record, all we need to do is a string name. So, or string school name, you can name it as you want. So now we have our school DTO record or school DTO object, and we can use this one now in the school controller in order to save and expose information about our schools. So again, let's go ahead and implement that. Let's now introduce all the necessary changes to our school controller in order to receive a school DTO and expose also a school DTO. So here, let's check back again. Here, if I go back to Postman and let me start the application, I will explain to you what I mean. So now if I go back to Postman, and here, if this is the school, or like to retrieve the school with all the students, we see here that we have the information of the school and we have the list of the students. So now it's okay to have it like this, because in this case, and so far we have only 2 students assigned to this school. But imagine the case we have hundreds and even thousands of students assigned to the same school. When you request the information, or like you need just a light information about the school, we will be loading the school and all the students. And imagine also we have other relationships for the students, and like the response will be really heavy, and it will take time until it gets from the backend to the REST client. So what we need to do, again, we need to just use DTOs and expose only the information that we need. And I will then show you how we can expose or like fetch the students for a specific school. So now let's go back to our code and let's adjust our controller to only expose and receive only the necessary information for the school object. So here, for the post mapping or to create a school, first I need to return a school DTO. Again, I just want to remind you that the school DTO takes only as a parameter the school name. And then here we also need to get a school DTO as an input or as a request body. So here all I need to do is just to have var school. So here let's call this one DTO, and school equals to school, for example, because I need a method that should do or make or perform the mapping and the object transformation from school DTO to an object school. So here we don't have yet this method, so let's create a method school in school controller. So here it should return school, and that's it. So now all I need to do is just return a new school, and for this new school it will be DTO.name, since our school contains only one attribute, which is this one, and we don't really need to pass any students. Then we need to perform saving, or like we need to save the school, and all I need to do, so in this case I can whether return or like have, for example, saved school equals school.repository, and then I will do var, and then I need another method to transform this school DTO, this school object to a school DTO. But here, as you can see, it's just for this case, the school object is the same as for the input as the output. So all I can do is return DTO again. So this also valid, and this will allow me to have or to save some time on the execution level. So here we have our method right here. It's a post mapping, and we receive the school DTO, and then we save the school and return the object back. So let's go ahead, let's restart, and let's try out this. So if we go back to Postman, and here this is the tab for posting a school. So let's say Alibu School 2, and then if I click on save, so we see that the school was persisted, and here I have the response that I already get from my backend. Now if I go back and check the database, and here let's open our school table, we see that we have Alibu School and Alibu School 2, sorry, not 2, which was persisted into our table. Now for fetching the list of schools that we have in the database, we don't need to expose the school, but we need to return a school DTO object. So here I will just change this return type to school DTO, and then we need to perform also a mapping. So we need to do a transformation for each element of the list to a school DTO object. So here, let's create private and then school DTO, and let's call it to school DTO. And these two school DTO will receive a parameter of type school, and then all I need to do is to return a new school DTO, and then it will be school.getName. Now we have our method, and this method, it will transform, like it will take a school object as a parameter, and then it will return a school DTO out of it. So here, what we need to do, so first let's have a stream, and then let's perform a mapping. So then stream, so this will return a stream of schools, and then a map. So we can do this, and then we can use the method reference, and then we can call this method to school DTO, and then of course we need to collect and return a list. So here now we have a transformation. So after finding all the students, which will return a list of schools, then we open a stream, so this will transform our list to a stream of schools, and then we will do a mapping. So we'll do a transformation of object. So this means for each element of this list of schools or of this stream of schools, we will perform a transformation, and then we will call the to school DTO method, which will return later on a stream of school DTO object. And then we call a reduce method, which is collect, and then we want to collect all of this as list. So now let's go ahead and try this one and see the output. So let's open again Postman, and here we have the method, or like the request to call or to get the list of schools. If I click on it, we see that we have now an object name Alibu School and then name Alibu School 2. So we don't expose anymore the list of students or any extra objects or any extra information that we don't want to expose it to the outside world or to our REST customer. All right, so now we have everything we need. So let's move on and talk about a really interesting topic. So see you in the next lecture. As the application and the business requirement grows, we see that the code that we are producing in here, in this controller, student controller, and also in the school controller, has grown significantly. And for that, we need to introduce another layer in order to make our code more reusable, and we need to create a separation of concerns. So for that, we need to create another layer, which is called the service layer. So the service layer in REST API plays a crucial role in separating the concerns of handling business logic and application-specific operations from the presentation layer, which is the controller, and the data access layer, which is the repository. So it serves as an intermediary between the controller and the repository, encapsulating the business logic and providing a reusable, modular, and testable code base. And here are some key reasons why the service layer is important in REST APIs. First, we have business logic encapsulation. So the service layer is responsible for implementing the business logic and performing complex operations required by the API. It encapsulates the logic that goes beyond simple data retrieval or modification, such as validation, calculation, transformation, or coordination of multiple operations. So by centralizing the business logic in the service layer, you promote code reusability, maintainability, and readability. Also, the service layer provides a separation of concerns. So the service layer helps to maintain a clear separation of concerns within the API architecture. Controllers are responsible for handling incoming HTTP requests and providing appropriate responses, while repositories handle the data persistence and retrieval. The service layer sits in between, ensuring that the business logic and application-specific operations are decoupled from the other layers. So this separation improves code organization, makes the code easier to understand, and allows for independent changes and testing of each layer. And finally, testing and maintainability. So the service layer provides a boundary of unit testing, as you can test the business logic independently of the controllers and repositories. By mocking or stubbing the dependencies, you can focus solely on testing the logic within the service methods. So this makes it easier to write comprehensive and targeted tested, enhancing test coverage and ensuring the correctness of business logic. Additionally, the separation of concerns achieved by the service layer improves the maintainability of the code base, as changes to the business logic and can be isolated to the service layer without affecting the other layers. So in the next part, let's go ahead and create the service layers that we need for our application. So now let's start with refactoring the student controller and create and extract the code for each layer. So here, let's first start with these two methods. The method that can convert and map an object student DTO to an object student. And also we have another method which converts a student to a student response DTO. So for that, let's go ahead and create a new class and let's call it student mapper. So this class or this service is responsible for mapping or creating mapping for our students. So first, to make this class a service, all we need to do is to add the service annotation on this level right here. And then let's go back to our student controller and let's copy or let's cat these two methods right here. So I'm gonna use Command X to cat these two methods, and then we go back to the student mapper and then just paste the code right here. And don't forget to make these methods public. And again here, let's make the second method public. So now we have these two methods available in this student mapper service. So now in order to use the student mapper and the student controller, all we need to do is to inject our student mapper. So let's go ahead and do it. So here we have private final student mapper, and then let's call it student mapper. And here, of course, we need to include that or to add this to our constructor. So let's go ahead and do it. And now we have our student mapper injected. I'm going to make this one full screen. And now let's fix the test. So here, instead of calling directly the toStudent, we need to call student mapper dot toStudent. And here we see that the code still works and we don't have any compile issues. And the same here. So for the other method, to student response DTO. So here we started or we extracted our first service, and we have our student mapper service, which can handle the mapping and the object's transformation. So now let's move on and create another service for this student controller in order to make our code more and more reusable and make our code maintainable and encapsulated. So now we extracted the code and we made our code less complex on the student controller, but we still see that we have more logic which is happening around here. So here we have like mapping, saving, and then returning the mapped object. So the idea is always to make the student or the controller layer responsible only for receiving the requests and sending back the responses. And all the logic and all the business logic needs to go to a separate service. So for that, let's go ahead and create a new class, and let's call it student service. So here, student service class. And again, to make the student service a service, we need to give it the annotation service. So here we can use whether the annotation service or just a component. But since we decided that this is a service layer, so we can annotate it with the service annotation. So then we see here that we are using repository and mapper. So we need to move these two dependencies to the service layer. So I'm going to close this one, and then I will just cut this student these two dependencies, and I will paste them here. And again, Let me make it full screen. And now I need to create or to add a constructor with these two objects or two dependencies in order to inject them using constructor injection. And here, let's go back to this one. And now instead of injecting the repository and the mapper, all we need to do is to inject the service that we just created. And we will come back to this in a few seconds. So here we see that we have this post method. So first I'm gonna change this one and I make it save student. So I will just rename the method. And here in the student service, I need to create also a method that will perform these three operations. This means transforming a student DTO to a student, and then saving the student, and then finally mapping the student to a student response DTO. So I'm gonna cut this one, and here I will go back to my student service and I will create a public method. So I will call it, or like it should return a student response DTO. So let's call it also save student if you want to. And this save student needs to take as a parameter the same object that we have right here. So let's pass our student DTO as an input, and then let's open this and just paste the code that we copied from the controller. So now if I go back to my student controller, and then I will just remove this constructor, and again I will inject my private final student service, the one that we just created, and let's call it student service. And of course we need to create or inject it through the constructor. And here we have our student service. So here in this save student method, let's just do this dot student service dot save student, and then we pass the DTO as an object. So for this method, we see that we have only one line, and of course we need the return keyword. And here we have only one line, which is calling the student service in order to perform all the business logic that we need. So here, let's go ahead and also migrate and move all the logic for the other methods also to the student service. So now, before we move on, I want to give you a small exercise, and I'm pretty confident that you will handle it your own. So here I want you to migrate and to move all the logic in this controller to the student service. So this means you need to create a method find all student in the student service, and the same for find student by ID and find student by name, and the same for deleting a student. So go ahead and do it, and I will give you the solution just afterwards. That's good. So now let's correct this exercise. So first of all, let's create a method in our service and let's call it find all students. So we can just copy this one and then move it to the student service. So here I will have my method, so find all students. And now if I go back here, instead of repository, and I will call this the service. So here I have student service dot find all students. And now we migrated the find all students to the student service. So in case we need to perform any other operations on the find all students, we can just do it on the service layer, and we no longer need to update or to change anything on the controller layer. So again, let's migrate this one. And then of course I will give you another exercise just to transform or to return the student response DTO instead of the student for this controller. So let's go ahead and let's do this. So here we need the integer ID, and then all we need to do is just to return this one. So let's copy this code from here and then paste it here. And now instead of calling the repository, so it will be the student service dot find student by ID, and then we need to pass the ID as a parameter. So we migrated also the find student by ID, and now let's go ahead and migrate this method too. So let's copy it and then let's go to the service, and here we need the string name as a parameter, and then also we can just go back and copy this line of code and paste it in here. So again, let's go back to the controller, and here instead of returning the repository, so it will be student service dot find all by name, or find students by name. So here find students by name, and then we need the string name. So now also we migrated this method, and finally we need to migrate this delete method. So let's make it also a void. So let's go back to student controller, and let's paste this one, and we need our integer ID, and then we need just this line of code. So let's just copy it and then paste it in here. So then we go back to the student controller, and instead of calling the repository, let's just call student service and then just the method called delete. So now we migrated all the code to the service, and as you can see here in the controller methods, we see that we just making a call to the student service. So we have no logic in here. So that's good. Now we migrated everything, and the next step, let's see what we need to do again. Now I want to give you another exercise. So as I mentioned before, here we see, or we need to return always the DTO or the DTO representation, and we want to do the same for all the other methods. So here, instead of returning the student object, I want you to return the student response DTO object instead. So now I will leave it to you, and just go ahead, fix this and change the return type, and I will see you in the solution for this exercise. That's good. You made it this far, so now let's correct together this exercise. So here, instead of returning a student, we need to return a student response DTO. So let's first change the type of this list, and here in this find all method, let's start and open a stream, and then let's make a map, and then we need our mapper. So student mapper, and then we can make a method reference to student response DTO, and finally we need to collect our objects. So here we have collect and then collectors as list, and of course we see that we have still one related problem, which is the student controller or the return type of the student controller. So we need also to change that. So now we have our student response DTO for the find all student methods. So next, let's go ahead and also migrate and change the return type for the find student by ID. So let's go back to our student service, and here in the find student by ID, let's just paste this one. So we change the return type, and here this find by ID, as you can see, it returns an optional of student. So within the optional, we have also the map method. So we can also perform a transformation and return the transformed object. So for the transformation, we need also the student mapper, and then to student response DTO. Otherwise, here we need to return a new student, or we can just return null for the moment. And then I will show you in the future sections how to deal with this kind of objects in case we don't find any student with the specified ID. So now let's go back to the controller and also change the return type for this method. So here it should be student response DTO. And now let's move on and also change the return type for the find students by name. So again, let's go back to the service, and here instead of student, we need to return student response DTO. And here also we know that this find all by first name returns a list of student, so it will be exactly the same thing as in here. So we can just copy this code to make it faster and just paste it in here. So we have the find all and then stream, and then we perform the mapping, and then we collect the response. And of course, don't forget to change the return type in the controller. So here I will just use the content to paste. So here I want, or I need, my student response DTO, and we have the issue fixed once and for all. So now we have everything fixed in the student controller, and we migrated and moved all the business logic to the student service. So here, as you can see, if we need to perform any operation or to apply any business logic, we just do it on the student service. And also, for example, if we need anything or a new method on the for the mapping, or if we want to return another type or another representation of the student, all we need to do is to perform and do this transformation on the student mapper level. So now we have our student controller clean. Let's go ahead and also migrate the business logic for this school controller to a school service. That's good, you made it this far. Now I want to give you another exercise. So now let's move to the student controller, and I want you to extract all the logic that we have in here to separate services. So just to give you a hint, I want to remind you that we have mapping methods right here, and we have some logic in here, and also we have some logic in here. So just go ahead and do this and extract all this code to separate services. And I will see you in the solution for this exercise. Good, you made it this far, and I'm pretty sure that you correctly implemented the services and extracted the services for the school controller. So now let's fix that together. First, we need to create a new class. So let's call it school mapper. So this school mapper, of course, we need the service annotation to make it a service and to make it injectable. And first, let's move these two methods right here. So I'm just gonna cut them. So let me make it full screen, and then let's paste these two. So here also we need to make these two methods public in order to be able to use them from outside this class. And now also let's create another class, and let's call it school service. So here we have school service class, and again we need the required or the service annotation. And again, we need to create two methods since we have just two methods right here. So I'm gonna just copy this one, or I'm gonna copy the whole method, and I will paste it in here. So here we don't need this request body, and we can also make the code a bit cleaner, and I'm gonna make it full screen. And here, of course, we need to inject our mapper. So private final school mapper, and then let's call it school mapper. And of course we need our constructor for that. So add a constructor, and here instead of using to school, I'm going to use my school mapper dot to school, and the same in here. So here we need also the school repository. So let's go ahead and inject it. So we have private school repository, and let's call it school repository. And also let's make it final and inject it and add it as a parameter into our constructor. So here we extracted the create method. So let's go back to the controller, and instead of calling this, we need to return the call from the school service. So here I will just change this one to school service, and also I will rename this one to school service. So let me just remove the controller and inject it again. So here let's call it school service, and let's create a new controller with the school service. So here I will just remove everything, and instead of just returning the DTO, I will just return my school service dot create, and then I need to pass the DTO as a parameter. So now we just successfully migrated and extracted the code for the create. Let's do the same within the school or the find all method. So I will copy this one, or I can just copy everything, and here I will go to my school service, and I will paste this method right here. So here, instead of this for the mapping part, instead of this I need to call my school mapper and then the method to school DTO. And of course, let's not forget to change or make the changes in the school controller. So here let's call our school service dot find all method. So again, we also need to optimize the imports, and now we have our code migrated and extracted to separate services. So here we see that the code is more and more readable and maintainable. So if we need to, again, to perform any business logic, we only have one place to perform it, and we don't need to make everything in one place or in the controller. And this will make our life easier later on when we move to the unit tests part. You will see the impact and the advantages of extracting the code to service layers. As our application grows, we see that each time we need new classes, new interfaces, and new objects to create. And this is too much and makes our code really not easy to target. And for example, if you search a specific class or specific object to update or to perform any operation on it, it's really a bit hard to find it. And here it's just a simple example. Imagine if you are working on a bigger application, and let's say for example an e-commerce application within the same code base. So this makes our life a bit complicated to find and identify the correct class and the correct object to update. So for this, I want to introduce you to a topic which is the best way to organize your code within your application. And for this one, we have several approaches, and I will walk you through each one of them and explain how to organize the code using each of these approaches, and then we will choose together the best approach, or I will give you my recommendation for the best approach to organize the code, but you are always free to choose the best approach that suits you. So now let's first start explaining the approach. The first approach is called by feature. In this approach, the code is organized around the business capabilities of features of the applications. For instance, if you're developing an e-commerce application, you might have packages like product, order, customer, and payment. And each of these packages would then contain all classes related to that particular feature, such as controller, services, repositories, and models. So this organization style is beneficial for large teams and projects because it's easy to locate code related to specific feature. The second approach is the layer approach. So in this approach, the code is organized around its architectural layers. Common layers might include controllers, services, repositories, models, and utils, for example. So these styles is beneficial when the focus is more on technical roles classes rather than their business roles. So however, one downside is that change to a single feature could affect multiple packages. And the next approach is by domain. So in a domain-driven design, or also called DDD approach, the focus is on the business domain packages. So packages are formed around different bounded contexts of subdomains within the large domain. So for instance, in a healthcare system, for example, there might be packages like patient management, billing, scheduling, and medical records. And finally, the final approach is by component. So in a more modularized approach, you may have top-level packages for each high-level component or of your system. Within each of these packages, you can further organize code by feature layer. For example, if we have a user component, we can have sub packages like controllers, services, models, and so on and so forth. Same for the product component. We can have controllers, services, models, utils, and so forth. And personally, I prefer the layer approach. So here we can have packages for product, order, customer, and payment, and inside of each package we will have all the related classes to the product. So in our case, we will have a package for school, a package for student, another package for user profile, and so forth. And if we need a common package, like for example, let's say validators or exception handlings or like custom exceptions and so on and so forth, we can create a specific package for that. So now let's move on and organize our code together. So now, in order to move all these classes to the appropriate packages, there are several ways, and let me show you how you can use your IDE to do that. Here on the first line of each class, you will see a line called package, and it refers to the package that holds this class. So here, for example, if I want to move the school class to a package that I want to call school, all I need to do is to add .school, and then IntelliJ will say that we don't have a package for that. And if I open this small pop-up right here, we see that we have set package name to com.alibu.example, since IntelliJ is considering this as a typo, or it will propose also to move to package com.alibu.example.school. So let's go ahead and choose this option. And here if you uncheck this button right here, you see that inside this example package, it will ask to create a school package. So let's go ahead and click on OK and see that here we have this school package. Okay, but this will come with some related issues because we need to import now the appropriate classes. But first, let's move all the school related classes to the school package. So here we can just perform a drag and drop. So let's just drop this one here and ask IntelliJ to refactor. Same for school DTO, and then refactor, and also school mapper. So here, and finally we need the school repository and the school service. So it's easy to do it within the IDE. So here, let's check if we have another school object. So we don't. Here, if I go back to the school, I need again just to import the student, but let's do it for later. And then what I can do also, like a different way, I can just create a package like new and then package. And then let's say, for example, student. So here, this package will hold all the information about the student. And now I can select multiple classes. So student, student controller, student DTO, student repository, and then student response DTO and student service. And finally, student mapper. And then all I need to do is just to drag and drop them to the student package, and then click on refactor and let IntelliJ take care of the rest. And finally, we see that we have the student profile. So let's also create a new package for that. So let's call it student profile. And finally, we need to move the student profile to this student profile package. And then let's go back to here and let's check everything. So here we see that the school, we need just to import this one. And if you just type or open the auto code completion, it will propose that to import the school from this package. So just select this one, and now we have our school object ready to use. So then if I go to the school and also open, let's import our student object here. And now we have everything fixed. And if I go back to the school, we see that our application is compiling successfully. And also, to make sure that everything is compiling, just go to build and then build project. And let's see if our project is successfully built. So we still see that we have one issue is with the student mapper. So let's click on this one. And again, we need to import the school from here. So now let's check back again, and we see that we have in the school mapper, in the student mapper, sorry, not the school mapper, because we are using the school object in here. So we need to import it from the appropriate package since they are now in different packages. So again, let's check if our application is building, and then click build on and build project. So now the project is successfully built and everything looks a bit nicer and pretty much nicer, not just a bit. So here we have our code organized. If I need something school related, all I need to do is to go to the school package, and here we have all the classes related to the school, the same for the student. So now let's move on and check what comes next. Now, after all this refactoring and the code organization, let's go ahead and check if our application is still working. So let me close all this, and then let's start the application and go to Postman and make sure that the application is still working. So here we see that we have the application is up and running and everything is totally okay. So let's go to our Postman and make sure that everything is working fine. So here in Postman, so for example, if I go to schools and try to retrieve the list of schools, we see that we have the response and we have 200 okay. And now, for example, in case I want to insert a new student, let's say Alibu, and I will just provide the first name and the school ID, and let's click on send. We see that we have our student persisted and we receive a 200 okay. But here we see that we have the last name and the email are null. And also let's go check in the database and see the changes. So here I'm going to make this full screen, and now let's open the student class or the student table. We see here that this is the latest student that we inserted, and we inserted it with the first name Alibu, but we see that the email and the last name and even the age are null. So the age is 0 because it's of type int, so by default the int is 0. But we see also that we have the email and the last name, they are null. And this is not really appropriate when it comes to database, and for the data we want to persist. There we can accept null values for some fields, but for other fields we cannot accept null values. For example, when we talk about the email or the student, so the email can be also a unique identifier and an important and sensitive information for a student. So we need always to have the email and the last name for the student. So this also introduces us to the next section of this course. So let's go ahead and introduce that, and let me explain to you the issue and how we can fix that. Data validation is crucial in REST API for several reasons. First, data integrity. Data validation ensures that the data being received and processed by API meets certain rules and restrictions. This helps maintain the consistency and reliability of your data. For instance, validating an email address format ensures that you won't have invalid email addresses in your database. Preventing attacks. Invalidated data can expose your API to security vulnerabilities. Malicious users can send harmful input to your API in an attempt to perform SQL injection, cross-site scripting, also known as XSS, and other types of attacks. Proper data validation can significantly reduce these risks. Error preventing. By validating data before it's processed, you can prevent errors that might occur during processing. If you receive a number where you expect a string, it can cause errors in your code. Data validation helps detect these issues early. User experience. Validating input on the server side and providing clear error message can greatly improve user experience. It lets users know what they did wrong and how to correct it, rather than leaving them guessing. Performance. Receiving large amount of incorrect or poorly formatted data can affect your API performance. Validation can serve as a first line of defense against unnecessary processing such data. And finally, business logic compliance. Often, business rules determine the acceptable values or formats for certain data fields. Validation ensures that the data your API receives and processes complies with these business rules. Now, let's see in action how we can implement this in a Spring Boot application. The first thing that we need to do is to add the required and the needed dependency for validation. And Spring Boot provides already a starter for validating objects. So let's go to our pom.xml file, and here after Spring Data JPA, for example, I'm gonna make this one full screen. Let's add a new dependency. So here we need the dependency called Spring Boot Starter Validation, and it comes from the same group ID, which is org.springframework.boot. And then all you need to do is to click on this button to load the Maven project or the Maven changes, or right click and then reload project. And like this, Maven will download this new dependency, and now we are ready and able to use this dependency within our project. So the next step, let me show you how we can validate objects just using some annotations, and use the power of Spring Boot starters to delegate almost everything. Now, the question that you need to ask is where to add the validation. So we mentioned before that validation within Spring Boot starter validation, it's just a bunch of annotations that we need to add to some fields, and then Spring will do the rest for us. Of course, it will not do it by itself, but we need to tell Spring that we want to validate this object that contains the validation annotations. So the answer is we need to add the validation on the first entry point object that we use to interact with our REST API. So now I guess you get what I mean, and this is on the DTO level. So for example, here if we go to our student controller and go to the post mapping, the method that helps us to create or to save a new student, we request a student DTO object. So the validation needs to be done on this level. All right. So let me show you how we can validate this object. So first, as I mentioned, we need to add some annotations telling Spring Boot Starter validation what are the validations or what are the controls that we want to add on each field of our object. And these annotations are valid whether you work with records or if you work with only simple classes or simple POJOs. Let's first start by validating, for example, our first name, and let's say that we want to make sure that the first name should not be empty. Okay, so here we have an annotation called not empty, and here to make sure that this is the right and the correct annotation, it comes from jakarta.validation.constraints, or if you are using Spring 2.7 point something or like a prior version before the Spring 3, it will be javax.validation.constraints. So now let's use this not empty annotation on the first name. So I'm gonna make this one full screen. So this not empty annotation, let's go and check the documentation and the code of this annotation. Always don't forget to download the source code so you have everything clear and complete. So here it says that the annotated element must not be null or empty. Okay, so if we add the not empty annotation to a field of type string, or here we can see the lists or the supported types for this annotation. So here the supported types are, so here we have char sequence. So this means the length of character sequence is evaluated, or a collection. So the collection size is evaluated. A map, the map size is evaluated, or an array. This means that the array length is evaluated. So here it will make sure, so this annotation will make sure and ensure that the first name is not null and is not empty. This means that the length should be greater than 0. So also I will add this not empty annotation to the last name just to make sure that the first name and the last name are not empty when we try to create a new student. So now let's move on and let me show you how we can make or how we can tell Spring to validate the student DTO when we receive a request body from the user or from the REST client sending us an object and we want to transform it to student DTO. So let's see how we can validate that. So this student DTO is used to interact with the student controller. So as we can see here, we have in the post mapping for the method save student, we have a request body of type student DTO. So we need to tell Spring that this object should be validated. So now how to do that? All we need to do is to add an annotation called valid. And this annotation valid comes from jakarta.validation. So it's the same package as the not empty. So here this one's jakarta.validation.constraints. So these are the constraints that we can use. And here is the valid comes from the jakarta.validation package. So you need to be careful about that, because if you import the wrong annotation, the application might not work. So now let's start our application and test these changes. So let's start the application and then let's go to Postman and send a student DTO object, but with the first name and the last name with null values. So here, this is our post request. And here we see that we have only first name and the school ID. So here we don't have the last name. So I'm expecting to have an exception or an error or validation error raised by Spring if we don't pass the last name. So let's go ahead and click on it. So here, let's say Catherine as a student name, and let's click on send. So here we see that we have a bad request. So our backend raised automatically a bad request response. So let's go and check what we have as exceptions or what we have as logs. So now let's check this. And here we see that we have nothing, but we see just one warning. So here we have a warn and we have a default exception handler resolver, and it says here resolved an exception of type method argument not valid exception, and here validation failed for argument 0 in public, student response DTO, and so on and so forth. So save student controller, and here we say that field last name rejected value null. Alright, so here we have an exception raised and REST client received a 400 response. 400 means bad request, as we can see right here. So it's a bad request, but with no further information about what happened exactly. And here we are missing something important that we explained before, which is the user experience. So the user doesn't know what happened or what he missed exactly. So he needs to, in this case, he needs to recheck everything and then try to send a new request. So let's see how we can catch this type of exception and how we can handle and return a proper response to the end user. As we can see here in the logs, Spring validation threw an exception of type method argument not valid exception. So I'm going to copy this one, and now what we need to do is to handle this exception inside this student controller. So what I will be implementing right now, I will explain it in details, really in deep details, just in the next lecture. So now I just want to show you how we can handle an exception inside the controller, and then we raise a proper and a clear message for our end user. So now I will just scroll down, and here I will create a public method. So a public and then response entity, and then this response entity will be of any type. And then so here I will say handle, and then the method argument not valid exception. And here as a parameter, I'm expecting an exception of type method argument not valid exception. So we need to import this one. So let's import it, and then let's write the logic for this one. And of course, to make this method a handler method or an exception handler method, we need to add an annotation called exception handler. And this exception handler takes a list of classes or a single class as value. So here we want, within this method, we want to handle the exception of type method argument not valid exception. So each time we receive, or this controller, the student controller, throws an exception of type method argument not valid exception, this exception will be handled inside this method. So as I mentioned, don't worry about that. I will explain all this in details in the next lecture. So for now, let me create a map. Let's call it errors equals new hash map. And this hash map will be of type string and string. So the first string will hold the field name, and the second one will hold the message name. Okay. And then what I need to do, I need to get the exception or the validation exception from this method argument not valid exception, and then transform them and send back a map of key value, and the key is the field name and the value is the message that was raised by the validation. So here all I need to do is exp or my exception, and then the dot get binding result, and then we have a method called get all errors, and as you can see it will return a list of object error. So let's do that, and then I will do for each. So for each element or for each error which is returned by the get all errors here, so these errors that we have are coming from the annotations that we used in here. So for example, if we use multiple annotations even on the same level name here, so we will get all the errors then. So now what I need to do is I need my object, which is, let's call it error, and then I will use the lambda expression. And for each element, what I will be doing is I want to extract the field name and the error message. So I will have here a var field name equals, and then I need my error, and then I need to get the field, but I need to cast this error object to another type. So it should be casted to a type field error. So then it will be field error, and then I have a method called get field. So this will return the field name, and then I need another variable which is the error message. So I will call it error message equals, again we need to go to error dot get default message. So this will return the default error message that will be thrown by the exception, and also we get this error message from this annotation right here. So now once we get the field name and the error message, all I need to do is to store this in the errors map and then put, and the key is the field name and the value is the error message. And like this, we gathered, or like we captured all the error messages, and we formed a proper object that we can expose to our customer. And now, of course, we need to return a new response entity. And then for this response entity, we will pass the errors object and then a bad request. So it will be HTTP status dot bad request. So now every time a method argument not valid exception will be raised inside the student controller, this method will intercept this exception and try to extract and transform the error messages that are coming from the validation process and transform them to a proper response that we can send to the user. So now let's restart the application and see what happens. All right, our application is up and running. Let's go back to Postman and let's just click on send. So here we see that we have a proper response. So here we see that last name must not be empty. And even if I remove, for example, the first name, we will see that we have two error messages because for now we have two annotations. One is on the first name level and the last one is on the last name level. So now let's move on and explore more annotations and how we can validate and give proper validation and proper control on the fields that we have for each object. All right, before we move on and explore more annotations, first let's see something or a property which is really important. And let's see here we have first name and then we have a message must not be empty. So this message is the default message coming from the Spring Boot starter validator. And then what we need to do, or what we can do, we can customize this message. So instead of having first name must not be empty, we can set our proper or our custom error message. So let me show you how we can do that. So here on the student DTO level, where we have the not empty annotation, here we have a property called message. And as you can see here, by default, it's jakarta.validation.constraints.empty.message. But we can provide our own proper message. And here, for example, let's say first name should not be empty. And this should not be empty. And this message will be returned to the user. Also, I can copy that and add this message to the last name, and here I will say instead of first name I will just say last name. So now let's restart the application and see the impact or how this is gonna be displayed on our Postman. Now all I need to do is to click on send again, and here we see we have first name should not be empty and last name should not be empty. And in this case we can even enhance a little bit the code that we created, so we no longer need to expose the field name that we have in our backend. All right, so let's go ahead maybe and do this, or we can just for now leave it as it is because I will show you a better way how to validate objects. So now we can move on and explore the rest of the annotations that we can use to validate the different type of objects and its different boundaries. So in the project, if you go to external libraries and then scroll down, it's almost in the middle, and you will see a dependency called jakarta.validation. So this is the dependency that we added already in the pom.xml file. And then if you expand this one, you will see a package called jakarta.validation, and then you have a subpackage called constraints. And here we see the list of all the annotations that we can use to validate fields in a class. And now let's walk through these annotations and see what are the use cases for each one. So for example, here we have the first one, assert false, and from the documentation the annotated element must be false, and the same for assert true. This means that the annotated element must be true. For example, if you have a Boolean field and you want to add the validation that this Boolean field should be true or false, you can use the annotation assert true or assert false. Now let's move on to the decimal max, and this one, this annotated element must be a number whose value must be lower or equal to the specified maximum. So if you want, for example, that a field or a value should not pass the value equals 100, for example, you can use the decimal max and give it the value 100, and then the validation will take care of the rest and make sure that the value we receive should not go beyond 100. And the same for the decimal min. So this will check and validate if this decimal or if the value should not be under that value we specified. And here also you need to check the supported types. So here we have, so for the decimal max and decimal mins, so we have, it applies to big decimal, big integers, charged sequence, byte, short, int, long, and their respective wrappers. So wrappers means the integer class, and the long with an uppercase or a capital L, and so on and so forth. The next one, we have digits. So this annotation, the annotated element must be a number within accepted range. So here we have a message group, and we have fraction, and we have a list of properties that we can specify when we use this annotation. And the next one is email. So as the name mentioned, so this one, it will make sure that an email address or a string email address should be well formed. And here we have by default, or we have a default regex for the email. So this is the one provided already by the Jakarta validation. But if you want to provide your own email formatting regex, just use the property called regexp, and you will be able to format or to give the regex for your email. Then we have the future annotation. So this annotation is applicable to all the date types, as you can see here. So here, this annotated element must be an instant, date, or time in the future. So when, for example, when you have a field date, let's say, for example, event or event date or something like that, and we want to make sure that this event date should be in the future, we can annotate this field with the future annotation, and then of course the Spring Boot starter validator will take care of the rest. So also, if we want the date to be future or present, we can use this future or present annotation to validate that. Then we have the max and min. So the max and min, so this annotated element must be a number whose value must be lower or equal to the specified maximum. And the same for the minimum. And here we see also the list of the supported types. Then if we want a value to be negative, all we need to do is to annotate the field with the negative annotation. So the annotated element must be a strictly negative number. For example, 0 is considered as an invalid value. So it should be, or the value should be lower than or strictly lower than 0. And then we have, if we want to accept 0 values, for example, we have the annotation negative or 0, and it will do the same except that this annotation accepts the 0 value. Then we have the not blank annotation. So this annotated element must be not null and must contain at least one non-white space character. So this is important. So for example, if I pass a white space and I use the not blank annotation to validate the field, so this will throw a validation exception as we saw before. So here we have the not empty, and the not empty we already used and we saw in action. So this would just ensure that the element must not be null or empty, but it accepts white spaces. And then we have the not null. So for the not null, it just checks that if the value or if the element must not be null. And then we also, of course, have the null. So since we have the not null, we have also the null. So this checks or specify that the annotated element must be a null value. And here it says accepts any type. So we can use this null or not null on any type. So then we go back again to the date annotations. So here it's exactly the same as future and future or present. We have also past or present. So for example, past we can apply it to date of births, to a date that we want it to be in the past. Also, we have the past or present, where we can use this annotation to make sure that the date should be in the past, or we also accept a present date. So present date means today's date. Then we have the pattern annotation. So this pattern annotation is applicable on annotated or a field of type char sequence must be a match for the specified regular expression. So here we have like 100% freedom to specify the regular expression that we want to use it to validate this field. And then we have positive. So this ensures that the annotated element must be a strictly positive number. So 0 is also considered as an invalid value. So here you need to know exactly the difference between, for example, positive and positive or 0. So positive or 0, just the difference that it accepts 0. And finally, we have the size annotation. So the annotated element size must be between the specified boundaries. And for example, here, if I have a string and I want the size or the length of that string to be between a minimum and a maximum value, all I need to do is to use the size and then specify the min and the max values. So these are all the annotations or all the validation annotations that we can use. Also, we can create custom annotations, but this we might cover in a future lesson. For now, let's move on and let me show you how to validate, or how it's a proper way to validate objects. All right, so now we implemented, or we are almost done with the implementation of our REST API. We also organized the code, we added the validation, we added the mapping, our code is well organized, and each part and each domain is in its own package, and everything is all right. Also, we tested the application, and the application is working fine. But the question is, are we done with this implementation? So let me give you the answer. So the answer is no, because we are missing really a crucial part and a critical part of the application, which is testing. Yep, exact. It's all about testing. Because why we need test? Because, for example, if I do a small change in one of the domains that we have, what are my guarantees to say that this change won't impact anything else? So software testing is a crucial process in the realm of software development, designed to identify and rectify defects, errors, and inconsistencies with a software application. It serves as a quality assurance mechanism, ensuring that the software performs as intended and meets the requirements and expectations of both developers and end users. Through a systematic and a structured approach, software testing evaluates various aspects of programs' functionality, usability, security, and performance. So then in the next part, first we will see what is the importance and how Spring is going to help us for testing. And after that, we will try and we will do testing, and we will see software testing in action. So we will implement the 3 parts of testing. So unit testing, integration testing, and end-to-end testing. So stick with me, and I'm really happy you reached this part, and let's go ahead. Implementing tests for a Spring Boot application is important for several reasons. First, we talk about quality assurance. So tests help ensure that your application functions as expected. They identify bugs, error, and expected behavior early in the development process, allowing you to fix issues before they reach production. And then regression testing. As you make changes or add new features to your application, tests act as a safety net to catch regressions. They ensure that existing functionality continues to work as intended even after code changes. Also, test serves as documentation for your code base. They provide examples of how your code should be used and demonstrate its expected behavior. This is especially helpful for other developers who may join the project later on. Also, a well-written tests encourage good coding practices and modular design. They often lead to the more modular, loosely coupled code that is easier to maintain and refactor. When you want to refactor or optimize your code, tests provide a safety net. They allow you to make changes with the confidence that you'll immediately know if something breaks. Also, the tests facilitate collaboration among developers. When multiple team members are working on the same code base, tests ensure that changes made by one developer don't negatively impact the work of others. Also, in a CI/CD pipeline or like continuous integration, continuous deployment pipeline, tests are run automatically whenever new code is pushed. This helps catch issues early in the development process and prevents faulty code from reaching production. Also, written tests can take more time upfront, but it can significantly reduce the time spent on debugging later in the development process. It's much easier to identify the root cause of a failure when you have a well-defined tests. As your application grows, the complexity also increases. Tests provide a safety net that allows you to confidently make changes and add features without introducing unexpected issues. And finally, of course, certain types of tests like security and vulnerability tests help identify potential security weaknesses in your application. This is crucial for protecting sensitive data and ensuring the overall security of your application. So generally speaking, in a Spring Boot application, you can implement various types of tests, including unit tests, integration tests, and even end-to-end tests. So each type of test focuses on a specific aspect of your application's functionality and provides a comprehensive safety net to ensure its reliability and correctness. Now, let's see how Spring can help us in implementing the tests and what Spring provides exactly. So first, Spring provides utilities and annotations for testing applications. So the test support is provided by two modules. The Spring Boot test contains core items, and the Spring Boot test auto-configure supports auto-configuration for testing. And then we have also the Spring Boot starter tests, which imports the following modules. First of all, we have the Spring Boot test module. We have also JUnit, AssertJ, Hamcrest, and number of other useful libraries. So a Spring Boot application is a Spring application context, and this I will explain it more in details when we go to the practice part. So the Spring Boot provides a Spring Boot test annotation when you need Spring Boot features during tests. So for example, if you want to load the application context in your tests, all you need to do is to annotate your class with the Spring Boot test annotation. And then in case you are using JUnit 4, you need to add the annotation run with Spring Runner.class to your test, otherwise the annotation will be ignored. Other than that, if you are using JUnit 5, there is no need to add the equivalent extend with Spring extension, as the Spring Boot test annotation and the other annotations will be already annotated within the @Spring Boot test. So now we mentioned that Spring comes with a Spring test auto configuration module. So the Spring Boot's auto configuration system works well for applications, but can sometimes be a little too much for tests. So it often helps to load only the parts of the configuration that are required to test a slice of your application. So the Spring Boot test auto configure module includes a number of annotations that can be used to automatically configure such slices. And finally, each slice restricts component scan to appropriate component and loads a very restricted set of auto configuration classes. Now we are done with the theoretic part. This might be a little bit too much or like too much talking. Now we will move to the practice part, and you will be able to understand and start implementing tests your own. So let's move on and let's go ahead and do it. All right, now let's dive into the implementation of tests for our different classes. So here, this is the diagram or the composition or the class diagram of our small application, and I'm focusing only on the student domain. So here we see from the bottom to the top, we have the student composed of the student service. This means that the student controller uses the student service, and the student service use both of student repository and student mapper, and the student mapper will use both object student and student response DTO. So now I want to tell you and explain to you what you need to implement test for. So what do you need to test, which classes and which objects you need to implement tests for. So here we see that the student response DTO and the student object, they are just classes. So there is no logic inside it. So it's just a class holding some information about the student, and this class or this record is only holding some information about the student response DTO. Now, if we go a level down, we see that we have the student mapper, and then we have the student repository. So the student repository, we can also implement tests for that, but it doesn't make sense, or it's not really required to implement tests for repository. So we will skip this one. Now let's start with the student mapper. So the student mapper right here. So if we go to the navigation, or if we navigate to the student mapper right here to this class, we see that we have two methods. All right. So now I want you to change a little bit your mindset, and suppose that you don't know the code before. So you just have a mission, or you're asked just to implement tests for these classes. So here we have two methods, toStudent and toStudent response DTO. So the first one will return a student object, and the second one will return a student response DTO. So normally from the name of the method, we can understand what is its functionality. Otherwise, we can go ahead and read the code. So we don't need that because we already implemented this our own. And now what we need to do is to create a test class for this student mapper. So to create a student mapper test class, let's start with the recommendation. So here we see that we have the Java, and this is the base package that we have, which is com.alibu.example. And then we have school and student profile, and so on and so forth. Here, if we check the test, we have also Java, and then com.alibu.example. And here we have also example application test, which is the same, or like the same loader class, or the class that will load the application context for our test. So for now, we will just ignore this one, and I will explain it in the coming sections. All right, now the first recommendation is when you create a test class for one of the services or the classes that you want to test, be sure and make sure that you keep the same package naming. So you need to keep the same hierarchy of packages and folders, just to make it easy to find. So you can just create it anywhere, or like even without creating packages, but the recommendation to make your test classes clean and clear and easy to understand and easy to point, you just need to keep the same hierarchy, or like the same package hierarchy. And we are lucky because our IDE, whether you are using IntelliJ, Eclipse, NetBeans, and so on and so forth, you always have some shortcuts, and you have the instruction and menu to generate test classes for the class that you want to test. So here, if I open back my test student, or like my student mapper class, and I want to generate a test class for it. So if I do like right click, and then let's click on generate right here. So here we see that we have many options, and among these options we have test. So if I click on test, you will see that it will be generating a student mapper, and then it will have, or it will give it a suffix called test. All right. And here you see the destination package. It will be com.alibu.example.student. You can select a different one, or you can change the name, and so on and so forth. But as I mentioned before, I recommend you keep the same hierarchy. And then you also can generate methods for setup, teardown, or also showing the inherited methods. And even you can generate two methods, or like two test methods for the toStudent and toStudent response DTO. But for now, we won't do that. We will do it one by one and step by step. So I will cancel. then we have a different option. So here, just focus on this area. You will have this green pop-up to show you which command or which shortcut or keyboard shortcut that I will be using in order to navigate to the test. So here, if you do Command Shift T or Control plus Shift plus T if you are using Windows or Mac, IntelliJ will try automatically to navigate you to the test class of this student mapper. All right, but if it can't find any test class, it will suggest you to create a new one. So it will also open and display the same window that we used before or that we saw together before. And here for the testing library, since we are using Java, like recent version of Java and also like a recent version of Spring Boot, so we can keep or we can use the JUnit 5. Also, if you have another project using JUnit 4, for example, I already explained that before, that you need to add few annotations or like one annotation in order to make it work. So now all we need to do is to click on OK button, and here you see that automatically a new package was created and it contains a new student mapper class test. All right, so now we have everything ready. Let's go ahead and start implementing, or let's start writing the first test method that we have for our student mapper class. All right, so first of all, let's generate a first test method. To create a test method, all you need to do is to create a public void. So this is the signature, and it should be always public void, and then the method name. So let's call it test method 1. So this will be the first test method, and the test method is a method without any parameters. So here, to make this test method as a test method, so all we need to do is to add the annotation test. So the test, it comes from org.gunit.jupyter.api. So here, once we add this test, you see automatically that now we have this button to run this single method, or you have this button right here to run all the test methods inside this class. So let's first of all just add a system.out.println, and here my first test method. And now let's run this test class using this play button to run only this method, since we have only one, or if we want, we can run the whole test. So let's run student mapper test class, and then you will see that it will open the test view, and here we have the system.out.println, the message that we printed, my first test method, and the test was green since we have nothing to assert yet. We will come to this in few moments. But before that, we need to understand what are the properties and what are the things that we can do within a test class. So the first thing that we need to know is that we have a setup method, or we can create a setup method. So if you click on generate, here you will see that you have a setup method. You can generate it automatically, or you can even write it your own. So let's generate it and see what is this method. So it's just a void called setup, and it contains an annotation called before each. So this means that this before each method, or this setup method, will be executed before each test that we have. And we mainly use this setup in order to initialize few things or few parameters or anything that we want to initialize before running any test method that we have. So I will just copy this message right here, and here I will just write inside before each method. And now if I run again my class, let's see what will be the output. So here we have, if I click in here, we have inside the before each method and then my first test class. So now I will just duplicate this method right here, and I will call it my test method 2. And here I will say my second test method. All right, so I will rerun again the class. And here we see that this one we have inside the before each method, my first test, and here we have also inside the before each method and then my second test. So as I mentioned, this before each will be executed before each test class. So in case, as I mentioned before, in case we want to initialize anything before running the test method. All right, so also as before each, we have other methods, and let's go ahead and explore them one by one in order to understand the structure of a test class and what are the usages and the benefits of using these methods. Alright, also if we want to execute any script, for example to reset the values of variables or classes or services or whatever, we also have a method, we call it teardown. So the teardown is after each execution of test method. So here, let's use the generate again, and here we see that we have the teardown method. So let's generate it, and here you see after each. So let's copy the same message, and here inside the after each method. When we run the test class, we will see inside before each method, and then my first test method, and finally inside the after each method. So let's go ahead and execute it and see the output of this execution. So now I'm going to select the first method, and as I mentioned, we see inside before each, my first test, and then inside after each. So as I mentioned before, in case you want to reinitialize, or for example to change the value of a specific attribute, or for example if you are running your tests against database, so you can just initialize and insert some data in the before each, and after each you can delete them or re-update the data in order to be able to use them in the next method. Alright, so now let's move on and let's see what are the other methods other than the before each and the after each. Alright, now the question is, what if I want to execute a setup or to initialize a few attributes and variables only before the execution of the whole class? So I don't want to run this method before each method, but I just want it to be executed only once. So in this case, we have also another method. So let's click on generate, and here we see we have a before class. So when I use a before class, so it's called a before all. Again, I will copy this message, and here I will say inside the before all method. So now when I run my test, so you can whether run it from here or again click on this play button or just run one of the tests. So let's go ahead and run and rerun the whole class and see what we have. So for example, let's select this one. So here we have first, when we select the method, we see only these three output messages, which is the before each, the method, and then the after all. But when I select the class, we see that we are inside the before all methods, and then inside the before each method and the after each method, and we have it again for the second method. So now just I want to make this output clear, so I will be running only one method, so like that you will see it in a better way. So now we see that we are inside the before all method, and then inside the before each, my first method, and then inside the after all method. So this is the case if I want to initialize something, a service for example, or to create a new instance of an instance or an array list or something like that, but I want to do it only one time. I don't want to do it each time. So in this case we use the before all method. So now in the same way we have another method called after all. So let's go ahead and try this one, and then let's move to the real implementation of the real test cases of our student mapper class. Alright, in the same way, let's generate an after class or an after all method, and again I will just copy paste and here inside the after all method. So if I run one of the test classes or the test methods that we have, and here let's go ahead and check the output. So here we have inside the before all, and then inside the after all, and in between we have the before each, the test method, and the after each. So the use case of the after all and the before all is, for example, I want to initialize or insert some data into my database, in case we are using, for example, an in-memory database. So I want to insert some data, and then once I'm done, I want to remove them, for example, or even if I'm working against my dev environment database or something like that. So in this way, we can initialize data, work with them, and once we are done, we can remove all the data that we already inserted. So in this way, we are safe from polluting and inserting wrong data into our database. Alright, so now you know the structure of a test class. What are the methods that we can use within a test class? So now let's go ahead and start implementing few test cases for our student mapper class. Alright, now let's start implementing our tests. First of all, let's start by cleaning up all this code. So let's remove it, and also let's re-optimize the imports. And now let's implement the first method. So here, just to remind you, we have our student mapper class that performs a mapping. So it transforms a student DTO to a student object, and then we have to student response, and it transforms a student to a student response DTO. So now coming back to our student mapper test. So here the first thing that you need to do is to declare the service that you want to test. So here we want to test our student mapper. So let's create an object of type student mapper, and then let's call it mapper, for example. And then the first method, or like the first use case or the test case that we want to implement, is that we want to make sure that these two student mapper performs a correct mapping from student DTO to the student object. So here let's create our first method, public void, and let's call it should map student DTO to student class. Alright, so this is our first method, and to make it a test method, we need to add always the test annotation. So then you see that this student mapper right here is not yet instantiated. So we don't have an instance or an object of type student mapper. So here it's just the variable or the field. So now we have two options, whether to initialize it in here so we can do new student mapper, or we can use one of the test of the setup methods. So here we can add a before each, and then we can move this part right here to this setup method. So we can make it this way or the other way round. So let's go ahead with the before each. So now we have our mapper object initialized, and now let's start creating and implementing our first test method. So here, the first thing that we need to do, we need to create an object of type student DTO, since this is the input of our toStudent method. So now let's go ahead and do it. So here we have an object of type student DTO. Let's call it DTO equals new student DTO. And for this, let's call it John. And then for the last name, let's call it Doe. And we have an email. So john@mail.com, for example. And then we have an int the school ID. So in this way, so I'm gonna just inline this one. So in this way, we have our student object. So after that, all we need to do is to call this toStudent method. So here, let's create an object of type student, and let's call it student equals our mapper dot toStudent, and then we pass the student DTO. And then we will start asserting that the output of this mapping method is what we expect. So here, let's go back to this toStudent method, and we know that when we call this student method, we just set these fields, and then we have an object of type school. So again, we can test. So what we want to focus on is that we have also a mapping for this school object, and that we have all the fields not changed. So now let's first start by asserting, and in order to assert, so here we have assert equals, and this assert equals, so it comes from assertions. So the assertions is from the package org.gunit.jupyter.api.assert equals. And here for the assert equals, we have multiple implementations. So we can assert equals shorts, bytes, strings, integers, and so forth. So here, let's do assert equals. And then what we want to test, we want to make sure that our DTO.getFirstName to be equals our student object.getFirstName. So here we want to make sure that this first name is the same for the class student. All right. So now also we can import statically this assert equals, and we can do that by add static import for JUnit Jupyter API assertions.assert equals. So when we do that, And when we go up, so you will see right here that we have a static import for that method. So the next time you see assert equals or any static usage of a method, so you know that it's statically imported in here. All right, so now let's continue the assertion. And here we have the first name. Let's also test the last name, and here get last name. And after that, we have the email, and also here get email. And finally, we want to make sure that the school is not null. So here, for example, we have the assert not null. So as you can see here, so I want to assert not null that my student dot get school is not null. All right. So then we can also make sure that the school ID was correctly set. So what I can do, we can assert equals. So our DTO dot school ID is the same as student dot get school dot get ID. So at this level, we are safe because we have an assertion that the school is not null. But if we change the order, we might encounter a null pointer exception in case the school is not correctly mapped. So now let's just go ahead and run this test method, and let me show you what is the impact and the execution of this method. So here we see that the method was green, but now you might ask the question, I'm just making sure that this object that I created manually is the same as I called this method. So now let's go to our student, and for example, let's say that I forgot to set the school to the student object. And now if I go back and rerun again the test, let's see what will happen. So here we have a test failed. So here we see that expected not null, but the object was null at this point. So here you see that assert not null of the school. So this means that the school was null, and I'm expecting the school to be not null. So now step by step, you see the importance of having unit tests within our application. So let's go back to the mapper and let's bring this back. And then, for example, let's say when I transform the first name or the last name, I just do to uppercase. All right, so I transform the first name to an uppercase. If I rerun the test again, you will see that the test will fail. And here we see this message. So here we have assertion failed error, and the expected was John, which is the object right here that we initialized with our DTO, and the output was John with an uppercase. So this is also another or a different assertion level or an assertion test that we make sure that the input should be exactly the same as the expected output. All right, so now let's go back to our mapper and let's just remove this one. And in case, for example, you have changed the implementation of this toStudent method, you need also to update the test. Okay, so in this case, you make sure that everything works fine. So let's run the test one more time and make sure that everything works fine. So our test is green. Now we can move on and implement other tests. All right, so now since you know and you understood how to implement tests, so I want to give you a small exercise. I want you to implement the test method for testing these toStudent response DTO, and it should take a student object and then return a student response DTO. So you can also inspire and follow the same example we did right here. I want you to create another method and you call it should map student to student response DTO. So I will let you do it and I will provide you the correction in the next lecture. That's good. I was sure that you will implement it correctly. So let's do it together. All right, so first of all, we need to create a public void method, and then let's call it should map a student or student to student response DTO. All right, and then parentheses, and then the brackets, and don't forget the test annotation. All right, so the first thing, as we did before, we need to create an object of type student. All right, so here go student equals new student, and then let's initialize our student object. So here let's say Jane as a first name, and then Smith as a last name, and then let's provide an email, so jane@mail.com, and then we need an age, let's say for example it's 20. And let me inline this. All right, so now we have our student. Then all we need to do is to create an object of student response DTO, and let's call it response equals our mapper, and then to student response DTO, and we need to pass our student. All right, now comes the assertion part. So the first thing we need to do is to assert first name, last name, and email, and make sure that the result is the same, since within our student response DTO we only have 3 attributes. All right, so now let's say assert equals, and then I want my response dot first name to be the same as my student dot get first name. The same for last name, so here last name, and then get last name. The same for the age. I want the age to be the same as the student dot get age. Sorry, we don't have an age for the response DTO, but it's email, and here it should be the same as get email. All right, so now let me add a few comments. So here, how we can read the test. So here we have given a student object, and then when we map the student to a student response DTO, then I want or I expect this result. So now let's go ahead and run the test and make sure that everything works fine and we did not forget anything. So the test is green. Also, let's go ahead and run the whole class. And here we have all the tests are green and passing. Okay, so that's it. Let's move on and let me talk to you about something really important when you implement an application, and mainly you can detect that with the tests. All right, now let me talk to you about something else. So here I will just start by creating a new test method. And after this method, I will just create a method called public void. And then this is also a different way of writing the method name. So we can write it in this way: should map student DTO to student object. All right, but this new method, I want to add if, or let's make it when student DTO is null. So this means I want the mapping to be or to perform correctly or in an expected way, even if the student DTO that I'm passing right here is null. So what I will be doing, I will just copy this part right here and then paste it in this method. And instead of passing the DTO, I will pass a null object. So here, what I will be doing, let's say for example, so we will change this later on, but let's start expecting this. So here, let's say an empty string, and here an empty string. All right, now if I run this test method, let's make it a test. And if I run this test method, let's see what will happen. So here we have a null pointer exception, cannot invoke the student DTO.first name because DTO is null. All right, and the exception happened inside the mapper itself. So if I click here, we see that the problem is exactly in here because we are trying to get the first name from a null object. And here we mainly talk about code coverage. So we need to cover all the use cases that our method and our service class and our class, generally speaking, should handle. So here you see and you noticed that we did not handle the case when we pass a null DTO object. So in this case, what we need to do, we need to go back to our student mapper, and then we need to add a test or a check or do whatever, just to make sure that when we receive a null object, we want to do something, whether raise an exception or just printing a message, or even, for example, initializing an empty student object with, for example, let's say empty values. So the implementation always depends on the requirements of your story or of the application that you are implementing. So now let's go ahead and start doing this. So in this case, or in this use case, we will see many things. So the first thing, let's go back to toStudent. And here I want to do if my DTO is null. For example, I want to throw a null pointer exception. All right, so here we need the new keyword, so a new null pointer exception, and here the student, for example, as a message. the student DTO is null. All right, so now we added a coverage to our method. So now let's go back to the test and make sure to readjust the test right here in order to make sure that this student method should throw a null pointer exception when we get a null DTO student. So we don't need this one since we don't have any assertions. And now let's just rename this method to make it more relevant. And here instead of should map, so let's say should throw and then a null pointer exception when student DTO is null. So now we have this mapper.toStudent and then we are assigning it to a student. So we can also remove this assignment since we know that it will throw an exception and it will return nothing. So now how can I expect or make sure that this toStudent is going to throw a null pointer exception? So in order to do that, all I need to do, I need to assert that this method is going to throw a null pointer exception. So I'm just going to remove it. And now I'm going to use assert throws. So here, this throws method, first of all, it gets the expected type. So in our case, it's a null pointer exception dot class, and then it's a lambda expression. So here, when we call the mapper.toStudent, I'm expecting to have a null pointer exception dot class thrown. So let's run this method and make sure that it passes green right now. So now this method is throwing this exception. So now what if I want to check the message that the message should be the student DTO is null or should not be null? So here, let's just rename it should not be null. And I'm gonna copy this message. And now I will go back here. So in order to do that, all I need to do, let's create a var message equals this. So as you can see, this assert throws, it will return the exception itself. All right, so now if I do msg dot, and here I have access to the method get message from the null pointer exception or from the exception, generally speaking. So now I want to do assert equals. I want this error message to be equal to my message or exception dot get message. So let's just rename this one to exp to say it's an exception. So exp for exception. And now if I run again, we need to be sure that the method threw this exactly the correct error message. So here, for example, if I add a dot and run again, the method should fail. And as you can see, now the method failed. And the assertion failure is we are expecting this, but we got this one. So in this case, we gained two things. The first one is that we add a coverage to our toStudent method, and then we also covered this within the test. So for example, in case I want to change from null pointer exception to a different exception, it will be automatically detected by this test method. Again, if I change, for example, the exception message, it will be also automatically detected. So now let me run it again and make it green. And now we added a new coverage to our method. So this is how you can test exceptions, and this is how you can catch exceptions and make sure, or you can do whatever you want. Even if you work with custom exceptions that you create your own, you can also capture that and do whatever you need to assert everything is as expected. All right, so now let's move on to the next part. All right, so we finished the implementation of the student mapper, and we saw how we can create a test class, how we can create test methods. Also, we saw how we can, or how much we need to cover our code, like we need to cover all the use cases. Now, let's move and start testing or writing tests for our student service. So we know that this student service is a Spring component, and it has a strong dependency with student mapper and the student repository. And especially when we talk about student repository, we talk about communicating with a database. So when it comes to testing, how can we test and how can we tell Spring or this student service that we have a student repository and this one needs to communicate with a database? And what happens in case we don't have a real database for testing? Because testing, it does not necessarily need to have a database for testing. So that's why we will talk about test isolation. So test isolation means that we want to run and to write tests for this student service in isolation of its dependencies. In a different way, I want to execute and write tests for this student service, but I don't necessarily need to have the real instance and the real object of my student repository. The same for my student mapper. So what do I need to do? I need to mock these two objects. So to do that, there is a framework called Mockito. So Mockito is a popular Java testing framework that helps you create mock objects and stub behaviors when writing unit tests. So it's especially useful when you want to isolate a specific component of your code and test it in isolation from its dependencies. So now we know what we need to do. We need to isolate and we need to mock. So you need to remember this term. We need to mock our objects. We need to mock the student repository and the student mapper to be able to run the student service test in an isolated way. So let's go ahead and let me show you how we can isolate and how we can mock the objects and the methods for each service that we have right here. So now, as always, the next step is we need to go and create a test class for our student service. So all I need to do, navigate here and then Command-Shift-T and create a new test. So here we don't need any of this. We just maybe need or use the setup method. So I will just check it out and then click on OK. So here we have our before each and we have our student service test class. So as we did for the student mapper, what we need to do here, first of all, which service that we want to test. So in this case, we want to test our student service. So I will create an object of student service and I will call it student service. And then when it comes to objects that have dependencies, let's check in here. So we see that our student service has two dependencies that we need to inject. All right. So our constructor is a constructor with parameter and it requires an object of type repository and an object of type student mapper. So let's just go ahead and do that. I'm just gonna copy this one and in here declare the dependencies. All right, I'm gonna paste this and then I will just fix the code. All right, so now I have my service and I have the dependencies. So what I need to do, so we said that in order to run this student service in an isolated way, what we need to do, we need to mock this student repository and the student mapper. So what we need to do, there is an annotation called mock. So this mock annotation comes from org.mockito. It's not the one coming from the org.spring framework. We want to use the mock from org.mockito. So let's select it one, and the same we need to add it to our student mapper. So in this way, we are telling our test class and the Mockito framework that we want to create mock for this repository and a mock for this student mapper. All right, now how can we tell this mocking framework that we want to inject these two properties and these two dependencies into this service right here? So the answer is kind of straightforward because I just mentioned injecting. So we have an annotation called inject mocks. So inject mocks always is coming from the org.mockito package. And like this, our mocking framework will try to find any dependencies annotated with the mock annotation that is compatible with the dependencies that are required from our student service. So this means when we try to create an instance or to initialize this student service, the mocking framework will look for two objects annotated with the mock annotation and that are of type. One of them is of type repository and the second one is of type student mapper. All right, so now we prepared everything. We still need to do one more step. So then what we need to do, we need to tell the Mockito framework that we want to open the mocks, or like we want to start the mocks for this current class. So this means that in the before each, here what we need to do, we need to use the Mockito annotations class dot open mocks. And this open mocks takes an object which is the test class, as you can see right here. So let's give it this because we want to open the mocks for the current class. Alright, so you might see this warning right here. This is because the open mock methods return an auto-closable. So, and this, the IntelliJ or your IDE will recommend to you that you might want to use a try with resource, but we can ignore that for the moment. It's not something really important or really gonna break our test. All right, so now we set up our test class. Now let's move on and implement the first test method that will allow us to save a student. So the first one, it will be this save student. That's good. Now let's analyze our save student. So we have here, first of all, we are doing a mapping and then saving the repository. And then again, we are doing a second mapping. So this is what we need to test in our test method. So let's go back to our student service test. And here I will create a public void and then should successfully save a student. All right, so this is our test method. Let's not forget the test annotation. And now here, let's remember the given, when, and then. So here, given what? So here in our save method, we have a student DTO. So let's first of all create a student DTO object. So let's go back here. And here I have, first of all, my student DTO object. Also, this class, it is going to need an object of type student, which is this one. So let's also go ahead and prepare our student. So it will be almost the same. So just copy the signature right here. And here I will create an object of type student. Let's call it student equals and then new student. All right, here, let's remove this one. All right, here we have also our student object and our student DTO. So what we want to do, or like how this is gonna work, this means is when we call our student service.saveStudent, we are expecting an object of type student response DTO. All right, so here I will create an object of type student response DTO. I will call it response DTO equals our student service dot save student, and then we have a DTO. So this is the DTO that we will pass as a parameter. And then what we need to do is to start asserting. So let's say assert equals, and then we have our DTO object dot get first name should be equal our response DTO dot get first name. All right, let's do the same also for the last name and also the email. So we can stick just to these few fields. We don't need to test everything. So this is what we want to test. So now if I run the test, what should happen? So let's go ahead and check together. So I will run this test method and let's see what will be the output. Here we see that we have a null pointer exception saying that we cannot invoke student response DTO dot get first name because the response DTO is null, and this is happening in here. So this means what? I'm gonna just add a breakpoint right here and I will run again this test in debug mode. So here, let's see our student service. So we have an object since it's already mocked. The same for our repository. So as you can see, we have a Mockito interceptor and so forth. So now if I evaluate this expression and then evaluate expression and then evaluate, we see that the result is null. Okay, so let me explain to you why we have this null result. So this null result is because the student service is trying to call the student mapper, and then we have the student repository is also going to call the save method. But remember, here we have a mock. So we don't have the real instance or the real service running for our test because we decided to run our student service in isolation mode. So to do that, what we need to do here, we need to mock the calls. So which calls that we need to mock? We need to mock every call that uses another service or another dependency in our student service. And in this case, we have the student mapper and we have the repository.save. So let me show you now how we can mock these calls. So the first thing that we need to mock is as you can see here, the first thing that we do is the mapping. So let's mock the mapping. All right, so now in order to mock the calls, so the first thing that we need to mock is our toStudent. So student mapper.toStudent method. So this comes from Mockito. We have a static method called when. So this means when we call a method, so we have as a parameter the method to call. So here we have student mapper dot to student. So when we call this to student with our DTO object, so make sure that the mock will work only if we pass this object right here. So then what we want to do, then we have so many options. So we can return whether a student, we can also a student and a list of other students, we can return an answer, or we can even throw an exception. So in our case, we want to return an object, which is our student right here. So let's return the student. And now we are done with the first mock of our student mapper.toStudent method. So here when we say when, we are mocking a method, all right? So this, when we call the student mapper.toStudentDTO, then we need to return the student object. So this means that our student service will run in isolation mode, and it does not 100% depend on the real implementation, or not the real implementation, but the real instance of the student mapper. So also let's import this in statically. So when student mapper, then return. All right, so let's do the same for our repository. So when our repository dot save and then student, then return our student itself. All right, because we know that when we save a student, we return another student. Or if you want to be more consistent, or if you want to have like more details, you can even create another student object. You can call it like saved student and set the ID and set everything, and also you can return that one. So let's just do it. It's totally fine. So I will call it saved student, and then I will just do saved student dot set ID, and let's give it the ID number 1. And in here, I will return our saved student. All right, so now we have 3 objects. So first we have the DTO, and then the student that will come from the mapping. And now this is the student that should be saved in the database. So now again, we mocked the second call, which is our repository. So if we go back in here, we still need to return another call. So here we need to mock also the student mapper dot to student response DTO. So in order to do that, just in the same way, so here we have when we call our student mapper dot to response DTO of our student object. Which one? Which is the saved student. All right. So here we have then return. Let's now just return a new student response DTO, and all we need to do is to pass the first name, last name, and email. So this is the first name, last name, and email. So let's just copy them from here. So we have our John Doe. I'm also going to inline this so you can see the full code. And the email is just john@email.com. All right. So now we have our test set and ready. So let's go ahead and run the test right now and see the output. So I'm just going to click and run this one, and let's see what will happen. So now our test is green. So we have all the expectations and everything was running in a successful way, because we have here, we mocked everything. And in case, for example, I just change anything, or you forget to mock a step, your test will fail. That's good. Now we created our first test method, and we saw how we can mock objects and also do some assertions. So this is the classic assertions. But now what if we ask the question, how can I check that my application is performing well? So here, for example, in this save student, I want to make sure that I only save one time the student into the database. This means, for example, I don't want to have some error or like someone typing 2 or 3 times this repository.save, because this will save the student many times, and in case, for example, you have a unique constraint, it might throw an exception and this will break the application. So let me show you how we can prevent this from happening. So if I go back to my student service right here, we can do this in the same place since we have our code already set up. All right, so here we are mocking. And now what I want to do, I want to make sure that this student mapper.toStudent was called only one time, same for the repository and the same for this one. All right, so to do that, Mockito also provides us with a method called verify, as you can see here. So we want to verify, and then we need to type the mock object. So our mock object is the class or the instance itself, and then we can pass a parameter. So it's a verification mode. So here we have a Mockito.times. Also we have timeout. We have so many other options. I can, for example, check that a method call should take only, just as an example, should take only 2 seconds maximum to be executed. If it goes beyond 2 seconds, the test will fail. And like that, I can also make sure that I have performance issues with my application. All right, so now let's continue with these times. So I want to be sure that this student mapper dot to student, and then the object student DTO, or the DTO object that we created, it has been called only one time. All right, so let's do the same for repository, and then times 1, and then the save method when we pass the student object. Again, I will duplicate this one, and here's student mapper, and then to response DTO, or to student response DTO, and here just to make sure that we passed the saved student as an object. All right, so here we need to say saved student. All right, I'm just going to align these methods right here just so you can see everything. So here verify that this method, or these 3 methods of the different services, were called only one time. So let's go ahead and run the method again. So run this, and then the test passed. So now let's suppose, for example, that one of the developers, or me, for example, as a developer of this application, I accidentally forgot to remove this extra line. All right, so now if I rerun the test again, let's see what will happen. So the test will fail, and we will see here that wanted one time. So this means that we wanted to have our call only one time, but it was called 2 times. And here, so as you can see here, you have student service.save student that was called 2 times. All right, and it was pointing to here and then to here. So here we see that even the test will point us directly where the issue has happened. All right, so that's good. Now let's move on, and let me give you a small exercise, and I'm pretty sure that you will be implementing it really easy without any issues. Now let me give you an exercise. I want you to implement the test for these find all students. So it needs to cover and to make sure that when you make a call to this repository.findAll, it should return the exact same list that you already expect. And in the next lecture, I will show you how to fix this one. All right, that's good. I'm sure that you correctly implemented the test for this find all student, but also let's go ahead and do it together. So I will create, as usual, a public void, and then I will call it should return all students. And then we have the given. So for the given, the first thing that we need to do is to create a list. So let's create a list of students. So this is the object that will be returned. So let's call it students equals new array list. And then let's add one student. So student.add, and we can even copy the student from the previous method right here. So I'm just gonna copy this one and I will insert this student here. Alright, so now we have one element in our student list, and then we need to mock the calls. So the first call that we need to mock is when we call our student repository or the repository object dot find all. Then I need to return the students list that we created. All right. And then what we need to do, we need to mock the call for the mapping. All right. So here we have when mapper or student mapper dot to student response DTO. And here, since we might add or pass any student, so we can use the power of Mockito. And here we have argument matchers dot any. And here, when we say any, we can also specify the class. So when we receive any class of type student.class, then I want to return, for example, a new object of type response, student response DTO, something like that. So I'm just gonna inline this. So when we call the student mapper dot to student response DTO passing any object of type student, we want to return this object. We can also make it more dynamic, but for the sake of a simple test case, it's also easy and it's also okay to make it like this. And here we just forgot the test annotation, so we need to add it. And now all we need to do is to have a list of type student response DTO, and then let's call it response DTOs equals our student service dot find all. All right, and here, so this is given, and now it's when we call this one, so then, so here we do assert equals that our students list dot size to be equal to our students DTOs dot size or response DTOs dot size. All right, so this is the implementation. Let's go ahead and run this method and make sure that everything is fine. All right, also should return all students is green. We can also add an extra test and make sure that, for example, this repository.findAll was called only once. So let's go ahead and test it just to make sure always that we have our application performing really well. So here we have our repository and then times 1 and then dot find all to be called only one time. Let's rerun again. All right, so the test is still green. So now let's move on and let me tell you what we will be doing next. All right, now I want to give you another exercise and I want you to implement the test for this find student by ID. I'm pretty sure you're gonna do it in a correct way and I will see you in the correction. All right, so as usual, let's go back to our student service test.java class. And the first thing that we need to do is adding this test annotation and then creating a public void. And let's call the method should find student by ID or should return student by ID. All right, so here always the given. And here we have an int student ID or an integer. Let's make it an integer. Student ID equals 1. And then let's create a student object. We can also take it from here. So let's call it student. So here we have student equals new student. And then we have when. So here we need to mock. So here we have when we call our repository.find by ID. And then we pass our student ID. And then I want to return an optional dot of my student. All right, and you might ask the question why I used optional, because this find by ID is going to return an optional. The second mock that we need to do, we need to mock the to student response DTO from the student mapper class and to return that one. So from that we can just copy this one. And then let's paste it in here. So here we have when we make a call to our student mapper, we are going to map this one. And again, we can just go up and copy these assertions. So here I will create an object of type student response DTO. I will call it DTO equals my student service dot find by ID. And then I will pass the student ID that I created. And now we have the then. So here we start the assertions. So here we have the DTO.firstName should be exactly the same one as the student.getFirstName. So here I will just copy the student from here and I will just replace it in here. So now we can select all, and here we have get, and then let's make this one uppercase, and now that's it. Also, we can add another check. We want to verify that our repository has been called one time for the method find by ID. So passing also the student ID as an object, as a parameter. And now let's go ahead and run this new test method. All right, so we might miss something. Okay, so here expected john@example.com, but the actual was john.mail.com. So maybe let's fix it. So here we have mail. Let's change this one also to mail, and let's rerun again, and the test is green and fine. All right, so that was it for this method. Let's move on and implement the next one. That's good. You really made a really good progress, and I'm really proud of you. So the next method that we need to implement the test for is find student by name. And just I want to give you a quick hint. You can inspire from the previously implemented methods in order to implement it in a correct way. So take your time, and I will see you in the next lecture to provide you the solution for this exercise. All right, you did a good job. Now let's correct this exercise together, and you might learn something new. So as always, we need to add the test annotation, and then we have a public void, and let's call the method should find student by name. All right, so then what we need to do, the first thing, we can also copy things from what we have before. So I'm gonna explain it one by one. So we can copy this part right here. We can also copy this one right here. So here we copied, so also let's copy it with the given. So here the initialization of the students list, and then we have the mock for the find all. This one we will change later on, and also we need to copy the mapping. So let's go back here, and now, so when we call the find student by first name containing, and here I just need also to declare a string student name. Let's call it John. All right, so here containing student name, then return the students list. And then when we call the student mapper.toStudent response DTO of any student object, I want also to return this mapped object or the student response DTO. Now, when I call, so here let's use var just to make it shorter. I will call it response DTO equals our service dot find all by name. And here I need to pass the student name. So then I need to do some assertions. So I want to do assert equals that the students dot size is equals to our response DTO dot size. So this is what we need to do, or what we need to check. Also, we can add a verify that our repository has been called one time for the method find all by first name containing our student name. So I'm gonna break the line for this one, and now let's run the test and check the result. All right, so the test is green and our method is correctly implemented. All right, that's good. So now we still have only one method in our student service. So let's go ahead and create an exercise for that. and also we will see the solution together. Congratulations on mastering the intricate dance of the Spring framework. You've built a solid foundation, but guess what? There's a whole universe waiting to be explored, the enigmatic realm of Spring Data JPA. Ever wondered how the pros handle data persistence in style? We're about to reveal the secrets that will transform you from a Spring enthusiast to a data wizard. Buckle up for a thrilling ride through repositories, relationships, and the art of querying with finesse. You've tasted the sweetness of Spring Boot success. Now let's add the spice of Spring Data JPA to your coding journey. Get ready to play with embedded entities, master the nuance of ID generation, and harness the power of named queries and specifications. Before we dive into the nitty-gritty, don't forget to subscribe to my YouTube channel and join our vibrant community. Elevate your coding skills with fresh weekly content delivered straight to your virtual doorstep. All the links are conveniently waiting for you in the video description. Don't miss out the coding adventure. Your seat is already reserved. Now that you're logged, loaded, and subscribed, let's get back to business. Spring Boot was just the beginning. Spring Data JPA is the next frontier. Ready to unravel the mysteries? Grab your coding gear, hit play, and let's embark on the epic coding journey together. Let's get started. First of all, we will start by setting up our database management system. And for the purpose of this course, I will be using Docker. And I will show you how you can install PostgreSQL or MySQL database. So you have multiple choice. Also, if you have them already installed on your machine, you can skip this part. So this part is only about installing and setting up the database management system on your machine. So first of all, make sure that you have Docker desktop running, installed and running. And here, like when you open the Docker dashboard, you will see this green part like here, or this green icon. So this means that the engine is running. So if it's an orange color, means that the engine is whether it's starting or it's not started. So you need to make sure that this is green. And this is all you need to do. Okay, now let's move and install the Docker image for PostgreSQL. The command that we need to run is the following. So here we need to use the command docker run, and then -d to say we want it to be running in detached mode, so we don't want to wait for it. And now we want our Docker image to be persistent, or to have a persistent volume within our system, because as you know, every time you start a Docker image, it will start like from scratch, and it will consider that nothing is persistent. So if we want to have a persistent Docker volume, you need to add this option -v. It's for volume. And now for the volume, first of all, you need to specify the path where you want to store the data of PostgreSQL. And for example, in my case, so it will be in here. So I just called it this way. It's my personal project data/pg for Postgre and data for data. And then just colon here and /var. So here we are trying to map the volume from our local machine to the volume that PostgreSQL will be using. Okay, so it will be /var /lib /PostgreSQL /data. So this is the path that PostgreSQL uses to store the data. Okay, so now we mapped already the volume. Now we can also pass some environment variable. And these environment variables, we need them for the username and the password. Okay, so to pass an environment variable, it's like following. It's -e, and then we have Postgre _ username These are predefined environment variable that PostgreSQL will look for. And here I will call it just Postgres or postdegree. And then minus E, I want to pass a second environment variable. And this one, it will be a postdegree password. Okay, it's a postdegree underscore password. And here I will call it Alibu coding for the password. Okay, and now we need to map the port. So this means on which port we want to run our application. So let's keep it the default one, which is 5432 colon 5432. Okay, so we will be using, or we will be connecting to our PostgreSQL on the port 5432. Okay, so now all we need to do now is to precise or to specify the image name, which is in our case, like we said, we want to use Postgres, so it's gonna be Postgres. Now let's hit the enter button and see how it will do. So here it says that unable to find the image Postgres latest locally, so it will be pulling it from library / PostgreSQL, so means it will download the image. And now we see that we have this status downloaded image or new image from Postgre latest, and here we have the hash of the image. Also, you can go to Docker dashboard, and you will see here that we have this image, and if you go to containers, you will see the container which is running. Okay, so and here you can see that we have this container which is up and running. Okay, so to install MySQL using Docker, we will follow the same steps. So it will be docker run minus d as d for detached. And now we want our database, or we want our image to be persistent or to have a persistent volume. So we can also precise the minus v, which stands for volume. And I want my volume, or my persistent volume, to be in this path. So it's up to you to choose where you want to have your persistent volumes. And then colon /var /lib /mysql /data. So this is what MySQL uses for data. And now we need also to precise some environment variables. And in this case, or for MySQL, if we do not precise, for example, the username, it will take the root as default username. So I will keep it just root. So I will only precise MySQL or this environment variable, which is the root password. Okay, so it's MySQL underscore root underscore password equals, and I will keep it empty, or you can leave it empty. So I want to have an empty password for MySQL. Next, we need to precise the port. So it will be 3306 mapped also to 3306. Okay, and then of course the image, it's MySQL or MySQL. Okay, now let's hit the enter button, and it will download or pull the image. So now it's extracting, and in just a few seconds it will be done, and we will be able to see the hash. So this is the digest or the SHA of the pulled image, and this is the ID of the image. And also to make sure that everything was fine and okay, you can go to image, refresh in here, and you can see what we have, the MySQL running, and it's already in use. So if you click on this one, you will see it here that it's up and running. Okay, to create a new Spring Boot project, the recommended way, and also the way that I really recommend, is to go to the Spring Initializer website, which is at this address, start.spring.io. And here you have a graphic user interface or a website that you can use to create a Spring Boot project. Okay, so let's go ahead step by step and create our Spring Boot project. So first of all, you can choose which project First of all, you can use which dependency manager you want to use. So if you want Maven or Gradle project, or here you have also the option for Gradle Kotlin for people that want to use Kotlin instead of Java. And here you can also specify the language, Java, Kotlin, or Groovy. So for us, we will go for the standards, which is Maven and Java. For this tutorial or for this course, because Spring 3 is already out, so we will be, from now on, we will be using the Spring 3 version. Okay, now let's specify or precise the project metadata. So here the group ID, it will be, let's call it com.alibu.coding. And the artifact, let's call it, because this is a Spring Data JPA course, I will call it just JPA. So this is Spring, and the description, you can leave it or you can put whatever you want. So let's just leave it, and this will be our base package or the package name. So we want a jar packaging, and of course we will use the Java 17 for our project. Okay. Now let's add some dependencies that we will need within our project. So first of all, we need Spring Data JPA. And for the people that would be using PostgreSQL, just choose PostgreSQL driver. For the people that they want to use the MySQL, just go ahead with the MySQL driver. Okay. Next, we need Lombok. So Lombok, it's, as you know, it's an annotation which helps us to reduce the boilerplate code. And I will be explaining all the annotations that we will use within our project. And also I will add Spring Web, just in case we need, for example, if you want to need to expose some controllers or something like that, you can use the Spring Web. Okay, so now once everything is set up, you have all the dependencies, you have all the metadata, and you configured everything. So we can first go and explore the project before downloading it. And as you can see here, we have all the information. So if the parent is a Spring Boot starter parent with the version 3. And here we have the group ID and the artifact that we precised. By default, the version is 001 snapshot. And the name is JPA. Okay. Also, we have the properties, Java 17, and so on and so forth. And here we have all the dependencies that we want to use. And in the end, we have this build plugin, which is the default one from the Spring Boot framework. And yeah. Okay, so now let's just go ahead and click on download and open our project using IntelliJ or your preferred IDE. To connect to our database, there are so many ways to do it. My preferred way, I want to have everything in one place, so I always go with the database option within IntelliJ. So by the way, this is the new interface, so you can download the latest version and enable the beta UI, and you will have the same view as me. Okay, so let's go back to our database. So in order to connect, you have this menu right here which called database, but if you don't see it, you can go to view, and then you have tool window, and then you can see here database. So if you click on database, it will open up this window right here. All right, so now let's create or connect to our data source. Let's start with PostgreSQL. So just click on this plus icon. Let me make it a bit bigger like that. So when you click on data source, you have here a list of databases or databases management system. So here, for example, you can also filter. Type Postgre to filter for PostgreSQL, and then click on it. Okay, so this window will show, and here we will have a default name which is Postgres localhost, and here you can add some comments. You can also see the connection type, which is default, and the driver, which is PostgreSQL driver. So this is not the driver that we included to our pom.xml, but it's the driver needed by IntelliJ or the the database view system that you want to use to be able to connect to the database. So here you have PostgreSQL, but for the first time it might require you to download the driver. So just go ahead and click on download the driver. It will be in the bottom here next to test connection. And now let's go and configure our database. So as you remember from the previous part, when we set up our PostgreSQL, we chose the default port, which is 5432, and then we chose username and password. So for the username, we said it's Postgre, and for the password, we chose Alibu coding as a password. Okay, now just go and click on test connection once you provide all the correct information. So if you used a different port in here, just precise it. Same for the local host and so on and so forth. So when you click on test connection, so you need to expect this succeeded, otherwise you have something wrong, whether the password or something like that. So let's do apply, okay, and let's check what we have in here. So here we see that we have our PostgreSQL, and here you have one of three schemas or one of three databases. So these also are my old databases or the one that I'm using for other projects. So now the first thing, let's go ahead and create our database. Okay, so right click and then new, and then you choose database to create the new schema. Let's call it data JPA. Okay, data underscore JPA, because this is the purpose of this course. Now just click OK. It's updating or creating the database, and then all you need to do, click on this 0 of 3 icon, and then just select the public. So you will have the public schema by default. Okay, and then in the future, or when we create a new table, it will appear under this public right here. Okay, so now we have our PostgreSQL set up and running within our application. So let's move to the next. For the students or for the users that prefer using MySQL instead of PostgreSQL, so in the same way, you have this icon right here that represents the database. When you click on it, it will open a window like that. But if you can see it, just go to View menu and then Tool Windows, and then you will see Database. Just click on it and you will have this view available for you. All right, now let's click on this plus icon to add a new data source. And here, like I have it already in the recent used, but also you can filter by typing MySQL and it will pop up. Okay, so then you need to precise the same information that you gave when creating the Docker image. So the local host or the host, it's always localhost. And the port, if you followed my exact same configuration, it should be also 3306. And for the user, it's root, and the password within the precise. So just go ahead and click on test connection. Okay, so when you just provide the username and password, if you have a username and password, but if you didn't provide a password, so just leave it empty. And when you click, you will see this succeeded, means that you are able to connect to your database. Also, one hint, be careful and make sure that you have your container running. So otherwise you will not be able to connect to the database. Okay, so I will click on OK. And now we see that we have our local host for MySQL. Let's configure our project to be able to connect to our database. And we will start with connecting to PostgreSQL. But this is important because it's the same configuration and only few changes would be different from MySQL or PostgreSQL. So the first thing, just go to resources in here, and here we have our application properties files. So I prefer using YAML representation. So it's the same thing. The only or the main difference is just the way we write the properties. So I will use YAML representation. If you want to use properties, it's also okay. So just go ahead, first of all, rename the application properties to application.yaml. Okay. Next, now we will start providing information or providing properties to our application or to Spring container to be able to connect to the database. So first of all, the first property will be Spring dot data source, and then we need to provide the URL. Okay, so to be able to connect to a database, we need to provide few information, because we have the Spring Data JPA starter within our dependencies. So we need to provide the minimum required of information. Okay, so for that case, we need the URL. I will just come back to it later. We need username. So in our no, not Hikari, just username. So for our case, for PostgreSQL, we say that it's Postgres, and for the password, why this Hikari? And for the password, we said we want to use Alibu coding as password, and then we need to provide also the driver class name. And the driver class name, you see here that we have already three suggestions. So the first one, or the first one is for MySQL or MySQL. The second one is for PostgreSQL, because IntelliJ is smart enough to detect that we have these dependencies in our pom.xml, so it will suggest it. Okay, so now what we need to do, the first one, we want to configure it for PostgreSQL, so just choose the second option or the first, I don't know the order that it will pop up for you. And yeah, that's it. Now let's add some other configuration. Okay, here I will add JPA, and here I want to tell or to give some extra properties to Spring configuration or to the Spring Data JPA on how to connect or how to manage or how to work with my database. Okay, and the first property is part of Hibernate, and it's called DDL Auto. This means what do we want to do when the application starts. Okay, so we have many options. The first one is create drop. This means that we'll create and destroy the schema at the end of the execution or the lifecycle of our application. So when the application starts, we will create the schema and the tables, and when we stop the application, we will drop or we will remove everything. So be careful when choosing this one. The second option is create. So when the application starts, it will destroy all the previous data and recreate the schema from scratch. So this is also, you need to be careful about it. We have also the none options, mean that we want to disable the DDL handling. That this means that we don't want to do anything when the application starts. Last but not least, the update option means that we want to update the schema if necessary. So this means what? This means that Hibernate will compare the Java representation or the entities. It will compare them to the table or the database schema that we have, and it will try to make it even. But here you need to put in mind something which is really important. The update option, it will not remove attributes. So for example, if you have an entity and you create and you want to remove an attribute and replace it, or like create other ones, it will create the new attributes, but it will not remove the existing ones. Okay, so also you need to know that, and you need to be careful about this. The last option is validate. This means, what means validate? This, it will not do any changes, but it will just validate the schema comparing to the Java representation or the entity representation. So we have, for example, user entity and we have a user table. So the validate, it will check if we have the same table name, same attributes, same attribute names, same types, and so on and so forth. So it will just validate that what we have as code is the same as what we have within our database. So for our configuration, let's say create drop, because this is a learning course, so we don't need to persist data forever. So create drop should be fine for us. So let's go with create drop. And now we can also precise the database. This will help Spring, or will help also Hibernate, to know which database we are dealing with. So it will just enforce the way that we will update and manage our database. Okay, so here we have also the option show SQL. Let's set it to true because we want to see SQL queries. Okay, so now this is the main configuration, or this is the configuration that we need to do. Now we will need to go back to this URL, and the difference between, for example, configuring MySQL and configuring PostgreSQL is just providing the URL, the correct driver class name, and here this option right here, you can also change it to say it's MySQL. Okay, so now going back to this URL, so it's JDBC, it's always like that, jdbc.postgresql :// and then you need to provide the local host, or well, whether it can be local host if it's locally, or it can be an IP address, or it can be a URL, and so on and so forth. So now we need to provide the port, which is 5432, and then the database name. As a reminder, the database name we created here, we called it data_JPA. So here let's just provide it. So now our application will be able to connect to this one. So how to test it? What we can do, we can just go ahead and start the application and see if we are able to connect to the database. Now I will enable annotation processing because we have Lombok within our application. And as you can see here, so the application already started in 2.9 seconds and without any issues. So everything is up, and because we don't have any tables, so we don't have any further information. But if something is wrong, we would see that we have exceptions in here, and I will just show it to you. So for example, if I provide the wrong port name, number, sorry, not name. So if we provide the wrong port number and we try to connect to the database, we will see that we have a connection issue, and it will say that unable to connect to this localhost 5431. So connection refused, and so on and so forth. So this just to ensure you that when you have the correct configuration, you will have no issues when connecting or when starting the application. Okay, so now our application is ready to use. Let's move on. We will add now the properties to connect to MySQL database. And to do that, I highly recommend that if you skipped the first part to connect or to configure PostgreSQL, I would really recommend that you go back, because we explained all these parts. So it's really, really important that you go back and check that. Now I would show you how to configure or how to connect to MySQL. The first thing, let's go ahead and duplicate this application.yaml. Just copy and paste, just Command C, Command V. Also, just as a reminder, every time I use a shortcut, you can see the green pop-up down here. So yeah, you can always follow what I'm doing. So now I will just say MySQL, or just the new file, I will call it application-MySQL. So this, we can use it as a profile, as a Spring profile. and I will show you how you can run the application, whether for MySQL or MySQL or PostgreSQL. So how you can configure IntelliJ to run with a specific profile. We will see it just in the end of this video. Okay, just go ahead and click OK, and let's start do the changes that we need. Okay, let's put this in full screen, or even I guess it's also like that is readable. So the first thing we need to, of course, change the username and password. So for MySQL, it's root, and we will see if it works or not. Let's go ahead and change the driver. And now we want to use the MySQL driver. Okay. And for the database, we want also to use MySQL or MySQL. Now we need to change, or we need to update this URL and connect to the database. So the good thing is within MySQL, you can ask him to create the database automatically if it doesn't exist, or if the database does not exist. So MySQL will create it. So MySQL will create it automatically for you. The URL is here. Instead of let's remove it. Let's write it from scratch. So it's JDBC, and here MySQL, and then ://. Now we need to provide the URL of the database. So it's localhost :3306. This is the port that we want to use. And then we want to use also the same database, or the same database name here. So just for to be convenient, so I will call it also Data JPA. Okay. And also you remember that we did not create manually the database, because as I mentioned, MySQL has the option, or has the capability, to automatically create a database if not exists. So to do so, just add interrogation mark and add this parameter, which called create database if not exists, equals true. And that's it. So like that, it automatically MySQL will try to create, or will create, a database called Data JPA if not exists. Okay. Now to run the application using this configuration, first, before clicking on this play button right here to run the application, just click on JPA application, and you will see edit configurations here. And here you see that we have active profiles. So Spring, now if I precise it as MySQL, Spring, what will do when starting the application, he will try to find an application properties file, or properties file having the suffix MySQL as precised in the configuration in here. Okay. So here we said that the active profile we want it to be MySQL. By the way, we can provide many active profiles. As you can see here, it's profiles, not profiles. So we can provide many, but in our case, we want to connect to application-mysql.yaml file. So Spring will automatically try to scan and read this file if it exists. Okay. I will click the run. And let's see if the application is going to start correctly or not. Yes. All right. So we see here something that I didn't know. So here we see that loading class, this one, but it's deprecated, and the new driver is the one that we saw in the options. Okay. So we will just update it later on. Now I want to go and check the schema. Let's refresh this one. And here we see that we have now 5 schemas, and we see our database Data JPA. So we don't have nothing yet, but this one, once we create the tables and the entities, we will have all the tables in here. So let's do the final update, and let's replace this with a new driver using this package, and that's it. For this course, we will implement the following database class diagram. So this database class diagram is about e-learning platform and what it's about exactly. So it talks about how we can, for example, if you go to Alibu Coding and check the courses that I have there, so what you see, this is what we have behind the scenes. So we have courses, sections, lectures, and for each lecture we have a resource, and the course has an author, and so on and so forth. So this is what we will see. But first, let me explain to you in depth this class diagram. So we have a course. So for example, this one that you are following right now, which is mastering Spring Data JPA step by step. So we have a course, and this course has an author, okay? But a course can be done by many authors, right? And the same author can create many courses. So for example, I can create so many courses, and one course can be created within a collaboration of multiple or many authors, okay? So that's why here we have this many-to-many relationship. But here, create an author, having an author within our database doesn't mean that this author should already have a course within the database. But if we have a course, we should have at least one author assigned to that, because when we want to create a course, we need to assign it to at least one author, okay? So that's why you see you see this symbol right here, and you see this one right here, means that the author is optional to have courses, but a course is mandatory to be assigned or to be done or to be created by an author. Then you know that a course has one or many sections, okay? So here, when we create a course, we need to create at least one section, but we can have multiple sections for one course. And here, just put few attributes, just simple ones, like title, description, name, and order for the section, and so on and so forth. Okay, so as I mentioned, a course has one or many sections, but one section, if we take one section, it belongs to one course, and within the course we can have many sections that belong to that course, okay? All right, next one, when we talk about sections, we have many lectures, okay? We have so many, one or many lectures. And one lecture, if we take one lecture, it belongs to one section. So this means that we cannot have one lecture that belongs or can figure out in different sections, okay? So if we take the section A that has lecture 1 and lecture 2, so this lecture 1, it belongs only to this section A. We cannot find it as part of section C or section D, for example, okay? Now, after that, a lecture has a type or has a resource, okay? So a lecture has one resource, and this resource belongs only to this one lecture. So that's why here we have this one-to-one relationship between the lecture and the resource. And for the resource, we have, of course, the ID, name, size, and URL. And the resource can be of different types. So I just created a simple types here, for example, video, file, or text. So this represents a resource, okay? So here what we have inheritance between this resource class or resource table and this video, file, and text objects, okay? So for the video, we have the length, for example, how many minutes this video. For the file, we have the type, for example, whether if it's PDF, MP3, and so on and so forth. And we have for the text, we have the content, and all of them, all these three types or three types of resources, they are already a resource and they can be assigned to a lecture. Okay, so this is our class diagram, and this is what we will implement during this course. So we will go through all this one by one, and each time or every time we need to explain something, we will go ahead and create and see how we do that. And also we will see how to create advanced search queries, how to work with transactions, and so on and so forth. So you already saw the plan of the course, and this is what we will be implementing. Before we go further, let's first understand and explain the difference between Hibernate and Spring Data JPA. So first, Spring Data JPA is just an abstraction layer on top of JPA to reduce the amount of boilerplate code required to implement data access objects, or what we call DAO or DAO. But JPA, what is JPA? JPA is just a specification that facilitates object relation mapping to manage relational data in Java applications. This means what? We can consider JPA as a Java interface where we have, or where we define the methods that we want them to be implemented by any class that wants to use or implement this interface. And why is that? Because we have so many implementations, like for example, we have Hibernate, we have Eclipse Link, we have iBatis, and so on and so forth, that all of them, they should implement the JPA specification. And the reason behind that is we want to make coders or developers' life much easier. So for example, if you want to move from Hibernate to Eclipse Link, all you need to do is to do a minimum configuration or minimal changes, like changing the dependency or maybe some basic configurations. But for example, if you have a save method, it's exact the same method for Hibernate and Eclipse Link, for example. This is what JPA exactly. As I mentioned, JPA is just the specification. Okay, now if we go to the Hibernate level, so Hibernate is a JPA implementation, and also Hibernate generates SQL query and executes using JDBC. So Hibernate is the ORM, the object relational mapping, that will use JDBC to handle all the database side, means like saving, reading, deleting, and so on and so forth. Okay, so this is the main difference between Hibernate and Spring Data JPA. So let me also re-explain this part. So instead of doing all the implementation and defining the session management, and so the transaction management also, and so on and so forth, that Hibernate provides, so Spring Data JPA will do all this job for us, because as you know, when using the Spring Data JPA starter, it will auto configure almost everything for us. So yeah, this is the power of the Spring Data JPA. Let's see first how we can transform a table or a database table to a Java class and to be able to manipulate it within our application. So let me explain this diagram right here. So we have this author.java that we will take as a first example, and we want to persist this object into our database, and we want it to be stored directly into the author table. Okay, so we have our author.java that contains a set of attributes, ID, first name, last name, email, and age. And then what we will see next is which annotations that we need to use in order to make Spring Data JPA understand that this is a table or this is an entity and needs to be persisted, and so forth. Okay, so let's go to our IntelliJ. Now let's create within our base package com.alibucoding.jpa. Let's create a new class, or let's create a new class, a Java class in here. But if you want, for example, if you don't have the right package ready to use, just when you want to create the class, you can precise the package name. For example, if you want to call them models, or if you want to call them entity or entities, it's up to you. So you just give them the package name. For example, let's say models in here, and then you can precise the class name. So for us, we want to create the author Java class, and we want it to be within the models package. So when you hit enter, so this is what we see in here, and we have author created under the package models. Okay, so now, as we mentioned before, let's just create our attributes. So here, just a reminder, we want to create ID of type integer, first name, last name, and email of type string, and we have an age of type int. Here I have a private integer ID, and I have a string first name, and I have also a last name, private string email, and finally I have a private int age. So this is my Java class. Now what we need to do, or like normally or usually what needs to be done when you create a Java class, or when you create, especially when we talk about entities and so on and so forth. So always think about generating getters and setters. So make all the fields private and generate getters and setters. So to do so, there is a shortcut in here, like as you can see, like you can generate it using this shortcut. And here we have getter and setter. Here you can select all the fields that you want to generate getters and setters for, and then just click OK, and you will see that we have all these methods ready to use. But if you remember, I will just roll back this. So if you remember, we already added Lombok to our project, or to our pom.xml. So let's use Lombok for that. Okay, so the Lombok annotations, we have many annotations, many useful annotations. We have the getter annotation, and as you can see, it's always from the package Lombok. So this will generate getters for this class, and also we want setters. So this will generate, this annotation will help us generate setters or setter methods for all the attributes in this class. If you want also, for example, a no args constructor, means a constructor with no parameters, you have the no args constructor annotation. Also, if you need all args constructor, you can also add it using this annotation, also all args constructor. But we have another annotation, it's called data, always from Lombok. And if we go and read the documentation, always try to download sources to be more readable for you and to get all the information that you need. So here, this data annotation, it generates getters for all fields useful to string method, hash code and equals implementation, and so on and so forth. So this data annotation, it's the equivalent to getter, setter, required args constructor, to string and equals and hash code annotation. So always, to reduce the amount of boilerplate code, we can remove this and we can remove this too. So we can just work with two annotations, data and no args constructor, and also if you need other annotations, it's also easy to use. So we have now our class or our Java object ready to use. Let's move on and try to make this an entity or to make it a table. Now let's try to answer one question. Is having a Java class containing all the attributes that we need for our table, is it enough to tell Spring that this is an entity? So Spring or Spring Data JPA, how he will know that this is an entity and needs to be managed? So the answer, first of all, this is not enough. Having just a Java class is not enough. And we need to tell Spring that this is an entity. So we need to provide some annotations or some information in order for Spring to be able to scan and pick up this object. So I already told you the answer. So we need to give an annotation, and this annotation is entity. Okay? So this entity, just let me show it to you first. So now we are using Spring Boot 3.0, and as you know, one of the breaking changes, or like the biggest changes, is using Jakarta EE9. And when we use Jakarta EE, so the package is no longer javax.persistence. So all the javax, not all of them 100%, but all the javax packages that belongs to the Jakarta EE, now they have been renamed to Jakarta. Okay, and from now on we need to use Jakarta.persistence for all these annotations. Okay, all right. So here using this annotation, and when we run the application, automatically Hibernate, Spring, and Spring Data JPA, like all of them are working together, so they will be able to pick and tell this is an entity, so we need to use it. Okay, and I want to show you also the documentation, and it says that this specifies that the class is an entity. So it specifies that the class that has this annotation is an entity. Okay, and also this is so important, this annotation is applied to the entity class. So here it's a type level or type target. So like this, we covered this part, this entity part, and we have here the same package as we already saw together. So now Spring will be able to know or to recognize this author.java class as an entity. Let's move on and see what we need to provide as minimum information in order to have this entity created in our database. After annotating this Java class, this author Java class with the entity, so this means that Spring Data JPA will recognize this class as an entity, and it will create the table, for example, based on the configuration we specified in the DTL Auto when we first configured the application. So it will automatically create this table. Otherwise, it will consider it as a table. All right. But here we see that we still have an issue. Even by having this entity annotation, we still see that we have some error right here. And let's go ahead and check it together. So here it says that the persistent entity author, so we see that now our class is a persistent entity, should have a primary key. So you may ask the question, I already have a key field right here. But yes, this is a key for us. We are a human being, and we understand and we can read that this field is ID, and even our intention is to have it as an ID for our entity. But Spring Data JPA doesn't understand this. Spring Data JPA is just a program. It's just 0 and 1 is a binary, so it understands only annotations. Okay, so to make this field an ID or any other field an ID, we need to add an annotation, and this annotation is as the name says, so it's the annotation ID. And here, while we are using the Spring 3.0, always make sure that you are using the annotation from the correct package. Okay, so the package is always jakarta.persistence. All right, I will insert this one, and we see that the error now is gone. But first, let me explain to you what is this ID. So in Spring Data JPA, the ID annotation is used to mark a field as the primary key of an entity. It is used to specify the identifier property of an entity, which is used to uniquely identify an instance of the entity in the database. Okay, so when the entity is persisted to the database, the value of this field will be used as a primary key of the corresponding database table. So this means the value of this integer ID is unique within our table, and also it might be unique within our database, depends on the generation type or the strategy that we will use to generate this ID. All right, so here I want also to answer one small question you might ask. So why we are using integer here instead of int? Okay, so the answer is as follow. So the int value by default is 0, but the integer value by default is null. And this is super important because Spring Data JPA, and when we talk mainly here about Hibernate, because we are using the Hibernate implementation. So Hibernate, each time when we try to save or to persist a new row or new line into our table, Hibernate will check the value of this ID or the field annotated with the ID. If the value is null, Hibernate will understand that we want to create or to persist a new element into the database. Otherwise, if the value is different from null or is not null, he will try to fetch the element within the table that has this value. Okay, so if we use the int, if we use the primitive type, so the default value will be 0, so Hibernate will try to find an element or a row with the value 0, and it will never find it. Okay, so that's why it's always recommended to use wrappers over primitive types. Okay, so I hope this is clear. If you have any questions, just go ahead, reach out to me. Otherwise, let's move on. We already explained that this ID is the unique identifier of our table. And we mentioned that we want to use, or we need to use, the wrapper classes or the classes like objects in here, because the integer is the wrapper class of the primitive type int. Because when Hibernate sees that this ID has a null value, it will automatically generate a new ID and insert a new line into our table. But how Hibernate will generate this ID? So here we talk about generation types or generated values for our IDs. And here let's explain, or let's see which annotation or which mechanism can help us generate this ID. Alright, so the answer is easy, and here we have an annotation called generated value, and just a reminder, always from jakarta.persistence. And once we mention, or once we annotate a field with this generated value, here let's check the documentation, what is written in here. So it says that it provides for the specification of generation strategies of for the values of primary keys. So here this is a keyword, means that we work with primary keys. So this generated value works with primary keys. So the generated value annotation may be applied to a primary key property or field of an entity or mapped superclass in conjunction with the ID annotation. So this property or this annotation might work with primary key, property of a field, or an entity or mapped superclass. We will see all these terms together, and always in conjunction with the ID annotation. The use of the generated value annotation is only required to be supported for simple primary keys. So we cannot use this generated value with complex keys. Complex keys means we can have, for example, an ID composed of two fields. Let's say, for example, an integer and a date. So this we can create a composed key, and we will see that also somewhere like after in this course. Okay, so use of the generated value annotation is not supported for derived primary keys. Okay, so here we have this annotation generated value, and we know that it will generate an ID or auto-generate a value for us. Let's check what we have in here, or which properties we have within this annotation. So we have a strategy which is of generation type, and also we have a generator. So this strategy is the primary key, so it's optional, but it's the primary key generation strategy that the persistence provider must use to generate the annotated entity primary key. So here we can define, or we need to define which strategy we want to use. So the persistence provider, and the persistence provider here means the database provider or the database management system we are using, must use to generate the annotated entity primary key. So here we have a default value for this, and we will check what are the types we have right here. The second one, it's also optional. We don't need to specify this property, and this is the name of the primary key generator to use, and specifies the sequence generator or the table generator annotation. Defaults to the ID generator supplied by persistence provider. So here, based on the generation type that we want to use, we can also create our own generator. So this means what? Let's go ahead first and check these generation types. So for these generation types, we will go and understand them one by one. We have table, sequence, identity, and we have this UUI ID and this auto. Okay, all right, so we will understand this in a few seconds. And now I want to go back to this generated value annotation and talk about this generator. So we saw that within this generation type, we saw that we have one value called table and one value called sequence. So this sequence generator and table generator, they are responsible if we want to create manually our sequence generator or table generator. So we will understand that in the next lecture. So now let's understand the different types of these generation strategies. So as we mentioned, the default value of this generated value, the strategy, the default value of it is the auto, and we also have the sequence, table, and identity. So first, let's understand what this strategy equals auto means. So this means that Hibernate will try to connect to the database or to the persistence provider and try to determine which is the best strategy to use. So to understand this more in practice, so just a reminder, here we see that you have within this generated value annotation, we have the default strategy is auto. And now in order to understand that, all we need to do is to start our application. So by default, our application is connected to PostgreSQL, and we will see that within PostgreSQL, it will choose one strategy, but when we choose MySQL, or we start with the MySQL profile, it will choose a different one. Okay, so let's go ahead and start our application. So our application has started, and let's check the log first, and then we will check the database. So here it's just a normal log and a classic one, but we see here we have some hibernate logs. So now what we have create sequence, author sequence, start with 1, increment by 50. Okay, and then we create a table author with the following attributes: integer ID not null, and so on and so forth. And we have here, or we are defining here, a primary key ID. Okay, so this is good. Let me reduce this, and here within this data JPA or our database, let's refresh it. And here, if you see 0 of 3, you need to select the public schema. Okay, now let's open this one. Within the public, we see that we have one table, which is our author table right here, with the fields or the columns that we defined, which is ID, age, email, first name and last name. And also we see that we have one sequence, which is the author sequence. So by default, Hibernate determined that the best strategy to generate IDs for this database, for the PostgreSQL database, is using sequence. So it created a sequence and it named it author sequence by default. Like it takes the concatenation of the table name within a suffix underscore sequence, and then it will use this sequence to generate values. So if we have multiple tables or like more than one entity, the sequence name will be Hibernate sequence. Okay, but for now we have on one single table, so it will take the table name with this sequence suffix. All right, now let's restart our application, but using the MySQL profile, and let's see what will happen within this MySQL. Okay, so let's do it. And in order to profile, in order to define the different profile, so all we need to do here within IntelliJ, you see this little caret right here. Just click on it and then open Edit Configurations. Select your application right here. So you might have multiple ones, but select the one JPA application. It's our application name. And here specify the profile name. And the profile name, how you can find it, let me close this one first, and you open here and you see for here for our application, it's called application-mysql. so this MySQL is the profile name. So now let's go ahead, edit the configuration, and in the active profiles right here, I will just provide MySQL. So like that, when we start up the application, Spring will pick up this configuration file. So now the application is running, and we see that we have drop table if exist, drop table if exist. And here what do we have? Here we are creating first create table author with the attributes or the IDs that we precised. And we see here, instead of creating a sequence, we have create table author sequence. So it contains a next value attribute of type big int. Okay, so here MySQL and Hibernate determined that the best strategy for MySQL is using table, okay, using strategy table. And this might not be the best strategy, but maybe MySQL or any other database management system does not support one or another strategy. For example, MySQL does not support sequences, so it will fall back to the second option. Maybe I don't know the exact order, but I'm just trying to explain it like that. So it will fall to the next strategy, which is author, which is table strategy. Okay, so let's check our tables right now. Click here, refresh. And now we see that we have two tables. The one is our author with the 5 columns that we already precised, and the author sequence is only one column, which is the next value. So if I open this table, you see that for now it contains only one line and the value is 1. And if I insert any data, it will automatically increase it by 1 and use it for the next value. All right, so this is the auto strategy, and now let's move on and talk about the next one. So here we saw together how Hibernate is able to detect which strategy is the best for our persistence provider. Now let's talk a bit more in details about this sequence generation. Okay, so by default Hibernate will create a sequence if possible, of course, but let's assume that we are using PostgreSQL and the best strategy is sequence. So Hibernate will automatically create a sequence. But what if we don't have the right to create sequences? What if we have a database admin that creates everything for us? So we need to specify which sequence we have already, or like we need to point Hibernate to that sequence, and the name might be a different sequence, so we need to point Hibernate to that. So this is one use case. The second use case, I want to create my own the sequence, and I want also to auto generate or to auto configure manually the allocation size. So we saw in the previous lecture that Hibernate will use the value 50 as an incrementation or as a step value. So we want, for example, to be 1. All right, so let's see how we can do this. So now, in order to do that, first of all, we need to specify the strategy right here. And the strategy, if you hit Control space, we see the options that we have, and let's choose sequence. Okay, now I just want to remind you that within this generated value annotation we have the strategy and the generator, and the generator here, it's the name of the primary key generator. All right, so let's give it right here. I will just put it into new lines, and here I will precise the generator, and my generator is a string, like we need to give it a string name, and I will call it author generator or sequence, author sequence. Okay, I will call it author sequence or let's call it sequence to see the difference between the one we generated before or that was automatically generated. I'm talking about this one, so our name would be author sequence. All right, okay, so now we have author sequence, but when we start the application, Hibernate will not find this author sequence, so it will claim, or it will raise an exception telling that we don't find this exception. All right, so what we need to do is we need to create or to manually create this sequence. Okay, and to do that, it's really easy peasy. We have an annotation called sequence generator, and this annotation sequence generator, it takes a name as a parameter. So this is the name, and the name should be the same like as this one. All right, so I'm just gonna copy paste it to avoid typos, and let me align it. So after providing the name, we need also to specify the sequence name. The sequence name is the sequence that also we want to use as a name. All right, so sequence name, by default it's empty, but let's also use this author sequence as a name. Next, we talked about allocation size, means the step of increasing or incrementing this sequence, and it's called allocation size. And as you can see here, the default value of this one is 50, and this is what we saw before in the logs. This is where this allocation size or 50 is coming from. All right, so for us, we want an allocation size of 1. And now that's it. We have our sequence generator and we have our generated value for this ID. Let's go ahead, start the application and see what will happen. So here we see that we have this log right here, create sequence, author sequence. So now it's called author sequence, start with 1, increment by 1. So it starts from the position number 1 and it's incremented by 1, and this start by 1, so it's from the initial value. So you can also change it if you want to start your sequence from specific value. All right, Next, we are creating the table, and now let's go and check the database and make sure that we have everything in order. So I will just refresh this one, and we see that we have our table, and now our sequence is called author sequence. So in case you want to create a specific sequence or a specific sequence for each entity, this is the way how to do it. All right, so now this is how sequences works, and then you don't need to do anything. Hibernate will automatically use this author sequence to generate the ID. All right, so that's it. If you have any questions, just reach out to me on contact@alibocoding.com, or all my contacts on social media. Otherwise, let's move on. Now, what if we want to choose a different strategy of generation? What if we want to use table instead of sequence, and we want to create our table generator instead of sequence generator? So let me show you how to do that. First of all, I will just comment out this sequence generator. I will leave it here in the code so you can use it. Then we need to change this generation type from sequence to table. And I will call or rename this generation or generator, instead of author sequence, I will call it author ID generator. Okay, so ID gen, I will call it like that. Okay, now instead of using this sequence generator, we have a similar annotation, which is table generator. Okay, this table generator, it takes a name as parameter. So the name, I don't need to mention it again, but it should be the same name as in here. After precising the name, I want to precise also the table, right? So the table right here, let's call it ID generator, for example. All right, next we need to precise the primary column name, comma here pk column name, and this is gonna hold the column name of our primary key. Let's call it ID name, for example, just to make it easy for you. I will call it ID name, and the value column name is the value for this column. So I will call it ID value, just to be consistent with that and make it easy for you. And of course, we can define the allocation size. As you can see here, it's always default 50, and I want to make it 1. All right, so I will keep the same profile, the PostgreSQL profile, so we can see the difference, or we can see what will happen when I restart the application. So I'm gonna stop it right now and restart it. So here, let's first check what we have as information. So we have here create table author. So this is our main table. And then we are creating a table called ID generator, and the ID name is type of varchar 255, and the ID value, and so on and so forth. So here what we are doing, insert into ID generator, and we are inserting the first value, which is the author, and the value is 0. All right, so let's check what we have in here. I'm gonna refresh this one. So here we no longer see this sequence generator right here. We no longer have the sequence, but instead we have this generator table, and this generator table, it contains only already one line, which is the author, which is our entity name, and the ID value is 0. So when we use this table generator, the one that we created manually, it will create one line for each entity, and it will initialize the ID value for it. So if we want to insert another entity, it will come here, query it by the name, and as you can see, the name is an ID, so it should be unique, and it will increment the value for that one. So this is how we can also use tables as generators. But here, before we finish this part, I want just to bring everything as it was before. So I will also comment this out just to leave it in the code. like that. And also I will change or just remove this. Okay, so I will just leave it as generation type auto, and like that I don't need to care about which strategy to use. All right, so that's it. If you have any questions, don't forget to reach out to me. Otherwise, let's go ahead and continue. In the background, I restarted the application, so we have the previous state. So now we have our table and we are using the sequence as a generator. So what I want to show you in this part is, as you can see here, we have this ID, age, email, first name, last name, and so on and so forth. But the question is, what if I want to have more control over these columns? Okay, so for example, this first name, I want to have a different name, and I want to have a different name for this last name. I want something which is different from the field that I have right here. So this is the first thing. The second, I want to have a unique, or I want to make sure that my email is unique. So this will prevent me from having duplications when we talk about email, because we know that an email is unique per user. All right, so to do so, we have an annotation that can help us reach this goal. So let me make this one full screen. And first of all, let's talk about this annotation. So the annotation is colon. And first, let's check what this colon is, what this annotation. So it specifies the mapped colon of a persistence property or field. If no colon, this is so important, if no colon annotation is specified, the value or the default value apply. So default value means what? Means the default values of this annotation, of this colon annotation. And let's quickly check the attributes that we have right here. So as you can see, all of them are optional here. So the first one, we have this name. So this is the name of the column. Otherwise, it will take the property or the field name. So if we don't precise anything in here, so the default name will be first name. And here, as you can see, that when you write it in camel case, it will be transformed automatically into snake case. All right. Now let's go back to this colon annotation. We have a unique attribute. So this specifies whether the colon is unique or not. Also, if it's nullable, if we accept null values, by default it's true. But if we accept null values or not, and here we have this insertable property. So this means what? This means that if we accept that we can insert new value for this column. You may ask the question why I should prevent inserting. And the answer is, when we talk about, for example, dates, and we have an update date or the last modified date of this column. So here we don't want it to be insertable, but we want it to be only updatable. Okay, so here we have insertable true, updatable true, and the same for this updatable property. So for creation date, or like the date of creation of a new line, or when we insert a new row into a table, we want to track the creation date. So the creation date should be only insertable, and we need to insert it only when we create a new line. But when we update the same line, we don't want to update it. So this field should not be updatable. Okay. And here we have a table, we have length, and also length, for example, for strings, we can specify, or we can say, for example, that a username or a login name or a pseudonym should be only maximum, or have the length of 8 characters maximum. Okay. And when it comes also to numeric numbers or decimals, we can talk also about precisions and scale. So okay, now we talked enough. Let's go and see this in action. All right, so for the first name, I want to have my name, or the name of this field, to be like that. For example, F name. All right, and why we have, or why we need to change this. So like For projects from scratch, it's okay because we will define everything. But imagine you want to work on a project where the database already exists. And for example, let's take the financial domain, and the database already exists, but believe me, you don't want to know how they call the fields or the columns. So it's totally different because they are using really technical names, financial technical names. So we want to have a more understandable for our Java application. We need to have a more understandable names. So we need to stick to the same names to the database, but we want to have our own. All right. So when we manipulate objects within our Java project, we want to use first name instead of this F name, or it can be F1234. So we don't want to name our field F1234. We want to name it first name, and then we can reference it, or we can give it a name that will be used within our database. Okay. So this is the first one. Now I will move on to this email. So for the email, for example, it's okay, it's fine for me to keep the name as it is, but for this email, I want, for example, I want it to be unique. So as you can see, and also as I showed you before, this unique attribute has a default value false. So by default, the field or the column is not unique, but let's make it unique. So when we use this property, this means that the email will become unique. So we cannot insert a duplicate values for this email. All right. Also, I can make it non-nullable, because also nullable by default is false, but I want to specify or like make the user pass a value for this email. So the email I don't want to see any emails into my database with null values. Okay. Also, if you want to, I know this is not okay, but let's go back and do it. In here, I was going to talk about the length. If I want to have a specific length, so the default is 255, and let's say, for example, I want to have 35 as max length for this first name. So this is the property to use. All right. So here, if we talk, for example, as we mentioned before, I will create a local date time field right here, created at. So this is the creation date, and I will give it also the colon annotation. All right. And for this colon annotation, I want this to be not updatable. All right. So as you can see, it's by default true, but I don't want this field or this column to be updated. So I want it only to be insertable. So I don't need to specify the insertable because by default it's true. But I don't want this one to be updatable, and this one cannot be null. All right. So this also nullable false. Now I will create another column, and I will call it last updated at, or last updated, or last modified. Let's call it like that. So for this last modified, I will also use the colon annotation. And within this colon annotation, I want this one not to be insertable. So I don't want to insert this last modified when I first create a new line, or when I first insert a new line, I want this last modified to be null. So because if I insert it, it might be confusing, because for example, I want to query all the data where all the data that were not modified. Okay, so I don't want to insert it. All right. I want it also to be updatable, and it will be nullable. So I just keep the default value because nullable is by default true. So using this colon annotation, we can have more control over our columns within our entity and on the database level. So we can precise the name, we can precise the length, we can also check the unicity and the nullability of our field. Also, we can decide if it's updatable or not, and if it's insertable or not. So this annotation gives us more and more control over our columns. Okay, so I'm gonna restart the application and let's see the impact of these annotations right here. So let's see what was the impact of this. So here it's just updating the constraint. So here we see that first of all we are adding a new constraint to our email with this unique. So now it's unique, and here, for example, for the age, it's an integer, not null. And we have this created at, it's not null. The email is also the same, and we see that the first name is now called fname and is no longer called first name. All right, so we see also that the last modified is a timestamp, but we don't have any control over it, like a not null and so forth. Same for the last name, and here we are defining the primary key as our ID colon. Let's see the changes directly visually. I will refresh this, and now we have our 7 columns. So we see here that we have this ID, the age, created at, email, and we see this small circle right here. So this means that these objects are not null, or they should not be null. Okay, also we see that we have 2 keys. So we have the author primary key, and we have a second one which is referencing the email, because we don't want this email to be null and we want it to be unique. So here you see this UK is unique, stands for unique key. PK stands for primary key. All right, so I hope this was clear for you. Otherwise, drop me a message and let's move on. Now let's take the following example. What if we want our table to be named author underscore TBL as a table name in the database, and we have our Java class called author? So in this case, how we can map, or how we can tell this entity or the Java class, or we mainly talking about Spring Data JPA and Hibernate, how we can tell Hibernate to name this entity and give it the name author underscore TBL in the database. So the answer is in here. We see this annotation. The table annotation is the one that can help us do this. So let's see the power of this annotation. So let's go back to the code right here, and now I will use this table annotation right here. So first of all, let's check what are the properties of this annotation. So first of all, it says that it specifies the primary table of for the annotated entity. Additional tables may be specified using secondary table and secondary tables. So here, if no table annotation is specified for an entity class, so the default values apply. So if we don't use this annotation, we will apply this default value. So the name will be empty, catalog, and so on and so forth. So let's now discover quickly these fields or these properties. So name, this is the name of the table. So we already have the answer how we can change or how we can give a specific table name. Here we can also specify a catalog, and the same for the schema. So for example, if my table is located in a different schema, so I can provide it in here. So I can give this information. So for example, if I have a schema 1, schema 2, and schema 3 within the same database, so I can specify, or I can precise which schema for each entity or each table. Also, if I have unique constraints like the one we did before, we want for example our email to be unique, we want to add new indexes and so on and so forth, so we can add a list or a table of unique constraints. Okay, the same for indexes. All right, let's go back here. So for our case, we only want, or we only need to give a name to our table, because we have only one schema. So if you have a different one, you can give also the schema name. So here I will call it author TBL, And I will restart the application and let's see the changes. So click on restart right here. And let's check again what we have. So we have this sequence, this author TBL underscore sequence, and we have our table now is called author TBL. Okay, so just for record, databases are not case sensitive, just in case you don't know this information. So that's why we see here that the table is written is lowercase, and here it's already in uppercase. So we see now that the table or the table name has changed, and now it's called author TBL. All right, so yeah, that's it. I will just clean up the code, comment out this annotation, and I will leave the rest for you. So thank you so much. Drop me a message if you have any questions. Otherwise, let's move on. So far, we learned how to manipulate data tables, how to create entities, which are the annotations that we need to use, which properties of these annotations we can use. Like, for example, when we talk about generated values, and the strategies, how they work, how we can also customize them and create our own and private sequence and table generator, and so on and so forth. But now we didn't reach yet the point where we need to discuss or where we need to manipulate and interact directly with the database. Interact means, for example, CRUD operations like read, create, read, update, and delete. And this we will see right here. For example, we have, as always, our author table in the database. So this author table has its own representation in our Java code as an author.java, and we need to persist this object to this database. So the link between the author and the database right here, because the a table already belongs to a database. But when we talk about Java programs, and also when we talk about Spring Boot framework, we talk about entities. All right. So what we need to do in order to better interact with this database. So here comes the power of Spring Data JPA. So Spring Data JPA made it so easy for us because he proposed something really, really nice, which is a repository. And the repository is an abstraction to reduce the amount of boilerplate code needed to implement the DAO layer, or the data access object, to interact with the data stores. Okay, so let's go a bit deeper within this definition. So in Spring Data JPA, a repository is a Java interface that is used to abstract the data access layer from the business logic. It is used to perform CRUD operations. CRUD, just a reminder, stands for create, read, update, and delete, as well as other common database operations such as pagination and sorting. Repositories are typically defined as interfaces and that extend one of the Spring Data JPA repository interfaces, such as JPA repositories, CRUD repository, paging and sorting repository. So these are the three main repositories or JPA repositories that we can extend, like we create an interface and extend this interface to have our own repository. Okay, so because these interfaces provide a number of predefined methods that can be used to perform common database operations such as saving, deleting entities, finding entities by their primary keys, finding entities based on various criteria. And this is what we will see in details later on. Okay, but first, let's understand and see this hierarchy of repositories. So far, we learned how to create a Java class out of a database table, and this Java class is the representation of the table in our database. Now we have another question, is what can we do, or how can we do when it comes to database manipulation and interacting with the database? Means if I want to persist a new object into, or a new row into this author table, so how can I do this? So the answer is using JPA repositories, right? So, but first let's understand and give a quick definition of this repository. So a repository is an abstraction to reduce the amount of boilerplate code needed to implement the DAO layer or the data access object to interact with the data stores. Indeed, in Spring Data JPA, a repository is a Java interface that is used to abstract the data access layer from the business logic. It is used to perform CRUD operations such as create, read, update, and delete. So this is what CRUD stands for. And then as well as other common database operations such as paging and sorting. So repositories are typically defined as interfaces that extend one of the Spring Data JPA repository interfaces, such as CRUD repository, paging and sorting repository, or JPA repository. So this has been a bit changed since Spring 3.0, and I will show you the difference right now. So these interfaces provide a number of predefined methods that can be used to perform common database operations, such as saving and deleting entities, finding entities by their primary keys, finding entities based on various criteria, and so forth. And we will see in deep how we can create data or can create queries using the Spring Data JPA repositories. So, but first, let's understand or see the hierarchy of the Spring Data JPA repositories. So as we can see here, that's why I told you before that it was slightly changed about when we talk about paging and sorting repositories, because now the new architecture looks like that. So we start, as we mentioned, by creating an interface. So for our example, we want to create an author repository, and then we need to extend one of these 5 repositories that we see right here. All right. But let's start and see the inheritance from the lower level, from the lowest level to the from the highest level to the lowest one. Actually, it's the other way around. So we first can start by extending JPA repository right here, and this JPA interface repository, it also extends 2 other interfaces at the same time. So it extends the list paging and sorting repository and list CRUD repository. So this list CRUD and list paging, so both of them, they contain methods. Like this is where comes the difference, because there have been a small refactoring in these interfaces. So now we have all the methods that returns list. They are within this list paging and sorting repository. So this in order also to reduce more the boilerplate code, because for example, if I want only to perform CRUD operations with I don't need list, so I can only extend this CRUD repository. Same for paging and sorting. But if I want everything, all I need to do is extending this JPA repository. So let's continue. So here we see, or we said that the JPA repository extends at the same time list CRUD repository and list paging and sorting repository. And the list CRUD repository already extends CRUD repository, and this CRUD repository also extends the basic interface which called repository. The same way when we take the left hand side part, so when we talk about JPA extending list paging and sorting repository, this interface itself, it also extends the paging and sorting repository. So now let's go ahead and see the code, or the not the implementation, but the interface which was created by Spring Data JPA. So go back to your IntelliJ, hit Command-Shift-O or Control-Shift+N for Windows and Linux users, and just type JPA repository, and you will see that we can open the Java class or the repository if you already downloaded the code. and we can open it, and it's the one Spring Data JPA, the version 3.0.0. So if you are using a previous version of Spring Boot, this might be slightly different, okay? But our course is fully focusing on Spring 3.0 because we want to see the new changes and we want to use also the most recent versions. All right, let's go back in here. So we see that we have here our JPA repository interface, which is extending at the same time list CRUD repository and list paging and sorting repository. So this query by example executor, so this is something else we will see later on. So that's why I didn't mention it in the diagram. So let's go back and focus on this. So here we have this list CRUD repository. If we open it, we see that this list CRUD repository is already extending the CRUD repository, and list CRUD repository contains all the listing methods. So save all, find all by ID. And then when we open this CRUD repository, we see that it also extends the repository interface, and this CRUD repository contains these methods like the CRUD method save all, find by ID, and so forth. All right. And the same way, if we want to go to list paging and sorting, so here we have this find all within this list paging and sorting repository. The same when we go to the paging and sorting repository interface, we see that we have this find all, and so forth. And this one, like we see when we talk, because when we talk about paging and sorting, we mainly talk about lists. So we have here the first parameter for the find all is a sort, and the second one it's a pageable, and the pageable also contains the sorting. So we can, if we want to use this one, so it already covers this. All right, but make sure that the return type of this one is iterable and this one is page. So this is just to mention. And as we said, both of them, they extend the repository interface. All right, so if you have any questions, don't hesitate to drop me a message. Otherwise, let's move on and continue. First of all, we will create a repository for this author model or this author entity. But first of all, don't panic if you see that I removed the code. And don't worry, you will not be losing the code because here it's just a cleanup, and you can find all the code when you go to Git right here and then you click on the logs. You will see that after each chapter, I will commit or have a full commit right here. So if you double click on this author, you will see all you need. So here you have the entity, you have all the annotations, the strategies, and so forth. So you will see all the changes that we will do in each chapter. So don't panic, don't worry about that. So it's just for me to have a clean code for each step. All right, so now in order to create a repository, it's so easy. So here I will create a new package, or I can create a class and a package at the same time. So here, create a package, call it repositories, and then dot, and the class name or the repository name. And don't forget to select interface, because we mentioned that a repository is an interface that extends another interface, one of the JPA repository interfaces. So let's call it author repository. Hit enter. So here we see that we have a public interface author repository, and in order to transform or to tell Spring that this is a JPA repository, we need to extend one of the repositories, okay, the repository interfaces. So for our case, we will extend the JPA repository. So because within JPA repository, we have all the methods. And as we saw before, this JPA repository, it's a generic interface that takes two types. The first one is T, which is the class or the table. And the second one is the ID. And this is the unique ID or the type of our ID within our entity. All right, so if here it's integer, so we will pass integer. If you use string, long, big decimal, and so on and so forth, just pass that type. All right, so let's finish this one. So it's a repository or JPA repository of our object author. So this will help Spring Data JPA to determine and correctly write the correct queries, okay? And of course, we want our ID, which is of type integer. Okay, so like this, we have our first repository. Now let's go ahead and play a little bit with this repository and create or insert some data and see how we can use this repository. Now, in order to test this repository right here, we need to create a service and then create a controller, expose the endpoint, and use Postman or like use Swagger UI to test this repository or test these methods and so on and so forth. So the process might be a bit long, but let me show you a better way how to do it. Okay, so we will use a command line runner. And the command line runner is a bean or is a method that will be executed at the application startup. Okay, so when we first start the application, we will run this method, and within this method we can inject any bean which is available within our application context. All right, so to do so, let me close all this. Go to the JPA application or your main application file, the one where you have the Spring Boot application, because this is the startup class, and then just create a bean. All right, so add the bean annotation, and here a public beans should always be public, don't forget that, and the type is command line runner. All right, so this interface right here, command line runner, give it a name, command line runner, and within this command line runner method or bean, you can pass any type you want right here. Okay, so it's like that, and now I want to inject my author repository right here. Okay, so I will create an object of type author repository. I will call it repository as a simple name. So like this, automatically this bean or this author repository will be injected. Okay. So now to implement this, let's use a Lambda expression. So let's say return args or something like that, and then arrow function, and that's it. And inside this method, we can implement or we can do whatever we want within this repository. Okay, so let's go back, check quickly our author method. So here we have the data, no args constructor, entity, and so on and so forth. I will just add two annotations. The first one is all args constructor, to have a constructor with all the arguments. And the other one is the builder annotation. So the builder annotation, it's for the design pattern builder, which help us create and building objects. So I will show it to you right away. So now to use this builder annotation or this builder design pattern, I will create a var, call it author. So you can use var because we are using Java 19. So equals author dot builder dot build. So you see, because we have this author, because we have this builder annotation, now we can use this build or builder method. So you see already in the icon right here, this is the Lombok icon, and yeah, so and then I will just type build. All right, so this builder help us, like we can use the field names as methods. So first name, email, and so on and so forth to create or to instantiate an object. All right, so let's have first name. I will call it Alibu. Last name also Alibu. Let me make this one full screen. Age, okay, I'm gonna give you my age. I'm getting a bit old. Okay, so email. Here you can find my email if you want to contact me. So it's contact@alibucoding.com. And that's it. So these are the information that we need to create an author object. Now let's use our repository dot save. Right, so within the repository, let's go ahead and have a quick look on the methods that we have right here. So we have save, count, delete, equals, delete all by ID. So all these methods, they come from all the interfaces that we saw together. So like we have a pre-built methods that we can use without any need to create methods our own, like, or to type or create queries manually. So we can use Spring Data JPA or the repositories to create a bunch of methods or many methods that can make our life so easy. So for now, I want just to test the save method. So I want to save this author object. Okay. So at the application startup, when I run the application, this bean will get executed and it will insert a data or a line into the database. Okay, so let's start the application and test this one. All right, so the application is running right now, and let's first check the logs. We see that we have a first log from Hibernate, which is select next val from author seek, or like this is the sequence. So Hibernate will get the sequence or the next value from our author sequence. And then we see that we have an insert into author, age, email, and so on and so forth. And here we have the values. So here it's like just interrogation mark because it will not print out the execution, but here it's logging already that we are inserting something into the database. Now let's open our database and check that we have our data. So I will open this author table. First, let me refresh because we renamed a few staffs. Yeah, now we have our author table. Go ahead, open it, and we can see right here that we have this ID, we have the age, email, and so forth. So here, like the object, he got executed, this bean got executed, and now we see that we have some data within our database. So also this might be useful for you if you need to execute something at the application startup. You can use this command line runner. So we will be using it in the future, maybe to test a few things. All right, so yeah, that's it. Let's move on now and answer one small question. At the application startup, when we execute this block of code, or when we execute any kind of this code in service or in a controller or whatever, so I mean when we create an object and we try to make a transaction to our database, saving it, deleting it, reading, and so on and so forth. So we call this a transaction. But this is not the main goal of this part. But first of all, we want to understand what is the life cycle of an entity. Okay, and to understand this, let's go ahead and open this diagram right here in order to understand what is a life cycle. Okay, so in Hibernate, an entity is an object that is persisted to a database table. And the life cycle of an entity refers to the entity, to the different states that it can be in during its existence, from when it's first created until it's eventually removed from the database. All right, so let's go and check these 4 states of a Hibernate entity. Okay, so the first one here, we have the first state, which is the state transient, and this is the state of an entity when it has just been instantiated and is not associated with a Hibernate session. An entity in this state is not persisted to be the database and is not managed by Hibernate. This means what? Means when we have or we create a new instance of our author object, or we use the builder for that, so we move from the object to a transient object right here. So at this level, our object is still transient. It's not persisted and it's not yet managed by Hibernate. But once we execute one of the following methods, save, persist, save or update, so like this, we will move from the transient state to the persistent state. So the entity or this object will become a Hibernate managed object. All right? All right, let's talk about and explain this persistent state. So this is the state of an entity when it's associated with a Hibernate session and is being managed by Hibernate. An entity in this state is persisted to the database, and any changes made to its properties will be persisted to the database when the transaction is committed. So here, when we do or when we operate any kind of this operations right here, so the state will become persistent, and any updates, so if we make any updates to this author object and we execute one of them, so this change will be affected or applied to the database once the transaction is committed. All right, so now after this persistent state, we can move whether to the removed state or to the detached one. Let's talk about the detached state first. So to detach an entity, the detach is this state of an entity is when it was previously associated with a Hibernate session, but is no longer associated with it. All right. And an entity in this state is persisted to the database but is not being managed by Hibernate. Any changes made to its property will not be persisted to the database until the entity is reattached to a Hibernate session. So let's focus on this until the entity is reattached to a Hibernate session. So this means what? Once we execute one of the following methods, detach, close, clear, or evict, the state of the Hibernate entity will pass from persistent to detached. Okay, and here when the entity is detached, we have two choices. So the first one, we can go back to the persistent state, or we can just go to the garbage. This object will just move to the garbage right here. Okay, but let's first talk about this word that we said, until the entity is reattached to the Hibernate session. To reattach the entity to the Hibernate session, we can use one of the following methods: save or update, merge or lock. So this means what? Means within one method, we can save. We can create the object, so it moves to the transient, save it, so it goes to persistent, and after the persistence or after saving the entity, we can do some logic, and then we call the session, the Hibernate session .detach, so it will move to the detached state. Once it's detached, we can also change some properties, for example, and then we can call back this one of these methods, save or update, and so forth. So it will go back to this persistent state. If not, or if we don't execute one of these methods, so the entity will just go to the garbage. So it will no longer become a Hibernate managed entity. Okay, so now let's go back to this persistent state. So from this persistent state, we can move to this removed state. All right. So to move from persistent to removed, we need to execute a method or a delete method. All right. So the removed is the state of an entity when it has been deleted from a database. An entity is in this state, so in this state removed, is no longer persisted to the database and is not being managed by Hibernate. So once we delete an entity, so it passes to the state removed and then automatically to the garbage. Okay, and here let's talk about a little bit and explain this state or moving the object to the garbage. As you can see right here, if we create an object, it's in the transient state. So from the transient state, it will move to the garbage if we do not execute any of these methods. Okay. Once we persist an object and then we try to detach it, and then we do nothing, it will also go to the garbage. Okay. Again, from this persistent state, once we perform a delete operation, it will go to removed state. So the state will become removed and then it will move to the garbage again. Now we can go here from this state, from this author, directly to this persistent state. So this means what? This means when we try to perform a get operation, find all, find by ID, and so on and so forth, so we will directly go to this persistent state. So because here we don't need to instantiate any kind of data, but we just want to call our session management or persistence entity or entity manager to get or to fetch data directly from the database. So we move from this initial state directly to a persistent state, and then we can move to these different other states. So we can perform a detach, save, delete, or remove. All right. So this is the Hibernate entity lifecycle. But here's something really important to know about. So with using Spring Data JPA, we no longer need to care about all this lifecycle because it's automatically managed, first of all. Second, so this save, persist, detach, and so on and so forth is being handled in the background. So we don't need to automatically commit the transaction or detach the entity and so on and so forth, because Spring Data JPA will do the job for us. So now we know and we understood what is the life cycle of our entities. Let's move on and explore other important things. If you have any questions, as always, do not hesitate to drop me a message. Otherwise, let's move on. Previously, we've been playing around this author entity. Now, what about if we talk about this whole class diagram and how we can realize it? Okay, but before that, we see that we have relationships between the different entities. We have the many-to-many, one-to-many, and so on and so forth. But first of all, what is relationship and why we need relationships? In a database, relationships between entities can be used to represent the connections and dependencies between different pieces of data. And there are several types of relationships that can be created between entities, such as one-to-one, one-to-many, and many-to-many relationships. Creating relationships between entities allows you to model the real-world relationships between different pieces of data more accurately, which can help you better understand and analyze your data. It can also help you to enforce data integrity and prevent inconsistencies by ensuring that changes to related entities are coordinated and consistent with each other. In addition to modeling real-world relationships, creating relationships between entities can also improve the performance of your database. By using relationships, you can avoid storing redundant data in multiple tables and instead use foreign keys to reference related data in other tables. This can help to reduce the size of your database and improve query performance. Overall, creating relationships between entities is an important part of designing a well-structured and efficient database. It can help you to model real-world relationships more accurately, enforce data integrity, and improve the performance of your database. So when you work with SQL databases, always think about adding relationships. This is important to improve everything and ensure integrity or your data integrity. Now, before moving on and start implementing this class diagram and creating relationships between the different entities, let's explain one small thing. So here we have, for example, this course entity and this author. We see that we have one relationship here. It's many-to-many relationship because we said that an author can create multiple courses and one course can be created by multiple authors. So that's why we have the many-to-many relationship. All right, so here we have a question. This question is, how can this relationship be done? And the answer is, here we are not talking about annotations, we are not talking about anything, but the focus or the main focus in here is the type of the relationship. So here we can identify two types. We have a unidirectional relationship. This means that one entity has a relationship with another entity, but the other entity does not have a corresponding relationship within the first entity. This means that the relationship is defined only on one side of the relationship. This means what? Like when we talk a bit code right now, this means when we create, for example, the course entity, and we want to link this course entity as a many-to-many relationship within the author. So we create an attribute or a list of authors within the course entity and give it the annotation many-to-many. And that's it. So this is what we call a unidirectional relationship. So it's from only one side. Now, what if we want to make it bidirectional? So in a bidirectional relationship, both entities have a relationship with each other. So this means that the relationship is defined on both sides of the relationship. So first of all, we created a list of authors right here, and it's referencing the author. Now, to make it bidirectional, we need to create a list of courses in the author entity right here. So like this, we will ensure that we have a bidirectional relationship. In general, unidirectional relationships are simpler and easier to understand, but they do not allow you to navigate the relationship in both directions. Means you can navigate from course to author, but if you implement unidirectional relationship, you cannot navigate from author to course. So it only ensures one-way navigation. But bidirectional relationships are more powerful and flexible, but they can be a bit more complex and require more care to maintain the integrity of the relationship. That it also ensure a bidirectional navigation from both sides. So from author we can access the courses and vice versa. Now let's move on and start creating all these classes. Let's create and implement everything we have right here. Let's start now by creating our entities. So what we will do is we will create a Java class and give it the entity annotations for each of these classes that we have right here. But we will not do any mappings, any relationships. We will just create Java class course, for example, with an ID, title, description, and so on and so forth. So this is what we will be doing right now, and then we will move on and implement and explain in details all these relationships and annotations that we can use. So let's go back to our IntelliJ. I will close all these tabs, and within our models package, I will right click and create a new class. I will call it course. So here, like as we did with this author, we can use the same annotations right here. So we need the data, no args constructor, or all args constructor, the builder, and especially the entity annotation, because we need it to make the class or the course.java class an entity, but just I will copy paste them to make it much faster. All right. So this course right here, let's go ahead and create a few fields. We have an ID, we have a private string name, and we have also a private string description. And that's it. So here we have our entity. Next, let's add the ID annotation because we need it. And we have also the generated value. And just a reminder, always make sure you use the Jakarta.persistence if you are using the Spring 3.0. Otherwise, it's still javax.persistence for the previous versions. So generated value, and we will leave the strategy to Hibernate to decide which strategy is better for us. Next, let's create the section entity. So I will call this class section, paste the same annotations we used before, and now we need to create a private integer ID and private string name, the section name, and also a private int order. So we want to give an order for each section. All right. Okay. Now, as always, we need this ID annotation and we need this generated value annotation right here. Okay, so that's it within this section entity. Let's move on and create the next one. Let's now create the lecture entity. So right click right here, new class, and call it lecture. As always, just paste the annotations that we will need. And now let's create an integer ID attribute. And then we need also the private string lecture name. So that's it. We have only an ID and a name within the lecture. And now let's add the ID annotation and the generated value. So this should be an easy task for you. And let's move on and create the next one. Now we will create this resource entity, but for the moment we will not create this inheritance video file and text, but we will leave it for later when we will explain the inheritance within Hibernate. All right, but for now let's just stick to this resources entity and create the following attributes. So go ahead, right click on the models package, create a new class and just call this one a resource. Always paste the annotations, and we have here a private integer ID, private string name, resource name, and private int size. And we have finally private string URL. So this represents the URL of the resource. And do not forget the ID and the generated value annotation. So that's it. Now we have all our entities created. Let's now move on and start implementing the relationships one by one. Now let's start establishing and creating relationships between our entities. So let's start from here. Let's create the many-to-many relationship between the author and the course. And as we explained before, an author can create multiple courses, and one course can be created in collaboration of multiple authors. That's why we have the many-to-many relationship in here. Now let's go back to our entity J. And as we mentioned before, when we talk about many-to-many relationships or many relationships, the first thing that we need to think about is creating lists. Okay, so let's open our author entity and scroll down here, and first of all create a private list. The list is always from the Java util package, and we want to create a list of course. Okay, and let's call it courses. So this is the first step. Second step, go also to this courses entity, and in here create a private list of authors. Okay, author, and let's call it authors. All right, so this is the first two steps. Next, we are talking about many-to-many relationships. So let's add many-to-many right here, and many-to-many also on the course level. So now we defined, or we have our many-to-many relationships, okay? But now we need to define something. We need to define the owner of this relationship. So because we have the owner and the reverse relationship. And in many-to-many relationships in JPA, one of the entities is considered the owner of the relationship and is responsible of maintaining the foreign key values in the join table. And the other entity is considered the inverse of the relationship and does not have any foreign keys in the join table. All right. So to do so, once you decide which of them should be the owner of the relationship, just go to the other one that you wanted to be the inverse relationship and give it the mapped by attribute, like give it the value. All right. So for our case, we want the course to be the owner of the relationship. So the author is the inverse relationship, right? So within this inverse relationship, add this mapped by, and the mapped by should be, or we should provide the name of the attribute we have right here. So here it's called authors. Just go copy and paste it in here. Be careful about making typos. All right. So if you make some typos, this means that you can also have exceptions at the application startup. Okay. So now let's go back to the owner of this relationship. So for our case, the owner is the course. And now to define the join table of this relationship, we define it from the owner side. So here we will use this join table annotation. And here this means, or this has a goal of creating a new joining table between our author and courses. Okay. So for this join table, let's provide some properties. First of all is the name. The name will hold the name of the join table. Let's call it authors courses. Means the courses of authors, or like you can call it whatever you want. Next, we need to define the join column. And here we can define multiple join columns. Okay, so the join columns right here equals, and now we need to pass a list of join columns. I will just make it a new line so it will be more readable for you. And now we will use the annotation join column. Okay, it's always Jakarta package. And for this join column, we need to provide the name, and the name right here, let's call it. So this join column is the one responsible, or the one that will hold the information or the primary key of the owner of the relationship. So this one will be the course ID. Okay. Next, once we define the join columns, we need to define the inverse join column. So when we say inverse, we are talking about the inverse entity. So here, inverse join columns right here equals, and as the same way, here we need also to use at join column. So join column, and let's give it a name. And here let's call it author ID. So like this, or in this way, we just defined a many-to-many relationship between our author and course. And to check that, let's just restart the application and see the impact in the database. And also let's check the logs. So here we see, all right, so here we have one exception, and you see right here, because it's caused because of this syntax error near order, because in this lecture, in this section, the order is a reserved name. Okay, so let's just rename it to section order, right? Or position or something like that. Let's restart the application again and see what happens. All right, so let's first check the logs. Here we have everything is working fine. And here we are creating the sequences for each entity. You see that for each entity we are creating a sequence. And here we have the author. We are creating the author and the course. And also we are creating the author's courses, the join table that we created for this author and course entity. We have also the lecture, resources, and so on and so forth. And here we are creating all the constraints. All right. So, and also here we are inserting, because we still have this bin right here. So if you want to stop it, just comment this bin out. Comment this out and it will no longer insert data. So now let's go and check our database. So here, refresh it. And now we should see at least the author, course, and courses. So here we have our columns. So we see that we have this ID, age, email, and so on and so forth from the author, and we have from the course, we have these 3 columns that we just defined: ID, description, and title. And now from the author courses, we see that we have 2 columns, and you see for the primary keys, it's a golden key, but for foreign keys, it's blue key. So now we see that we have this course ID, which is referencing the course, and the author ID, which is referencing the author entity. All right. So this is how we can create many-to-many relationships. Let's move on and see how we can implement relationships between the other entities too. If you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. At this level, let's implement the relationship between the course and the section. So a course has 0 or many sections, or 1 or many sections, okay? And one section, if we take one section, it belongs to only one course. So here we have one course to many sections, and we have many sections to one course. So how we can also explain this? So when we create a course, we have the course, but every time we create a new section, we will have a foreign key course ID that will be associated within this section class. All right, so let's see now how we can implement this. So at this level, we are talking about the course. So, and we said that one course has many sections. So here, when we say that, we have one course and many sections. So list of sections, and let's call it sections. Okay, so this is the first step, because we have one to many. So it's always the current instance or the current object, which is the course, has many sections. So we create a list of sections right here. Okay, now let's go to the section. You can do command click or Control B for Windows and Linux to navigate to the definition of this. So here we said that many sections can figure out, or many sections belong to one course. All right. So here this means that we need to create a private course element right here, or a field of type course right here. Let's call it course. Okay. Now to implement the mapping, so we go back to this course.java where we have the list, And it's easy, like when we have the list, always think about one-to-many. So it's just as we explained it, it's one course to many sections. So one course to many sections. All right. And here, when we use one-to-many, we need to map it or to tell which mapping that we need to use. So here, mapped by. And this mapped by, it should be the exact same attribute name we have right here. So just copy, paste it, and be careful always about typos. So here we have this one-to-many. Now let's go and navigate to the section entity. So within the section right here, we said that many courses or many sections. So we said that many sections, they belong to one course. So we have many to one. And when we use many to one, we need to specify the join colon. So when we create a course, when we create a section right here, what should be the join colon name? All right. So here we need to add or to use the annotation join colon, and let's give it a name right here. And the name, let's call it course ID. Okay, so now we just created a mapping or a relationship between the course and the section. So let's restart the application and see the changes. So the application just started right here, and we see that we have all these entities. Now let's go and check our database. And now what I'm expecting is to see a foreign key called course ID within this section class. So let's do it, refresh the table right here. And let's check this section. So within the section, we have 4 columns. This is good. And we see that we have one foreign key. And this foreign key is this one. So we see it's FK. Let me make it a bit bigger. So we see that this FK stands for foreign key, and this is the ID of this foreign key. So the name or the key of this attribute is course ID, and it references to the course. Okay, so it references the course ID that we have within this course table. Okay, let's also check again the columns right here. So we see that we have an ID, name, section, and course ID. So like this, we are able to create or to make a relationship between two entities using one-to-many. Okay, let's move on and implement the next. And if you have any questions, don't hesitate to drop me a message. Now let's implement this relationship between the section and the lecture, and it's also one-to-many as we did for the course right here. So this, I think it's an easy task for you, and let's go ahead and implement it quickly. So from the section level right here, we said that the section has a list of lectures or many lectures. So let's go ahead, create private list lectures. Okay, and let's call it lectures. And now let's move to the lecture and create or reference it within the object that we have. So here we have private section, and now let's add the mapping. Okay, so we said that we have one section to many lectures, and this one is mapped by section. Okay, so it should be, just a reminder, it should be always the same name that we have here. Now from the section level, as we explained before, it's one section to many, it's one lecture to many sections, and here many lectures can belong, or they belong to one section. Okay, so here we have many to one, and do not forget to add the join colon and give it a name, and let's call it section ID. All right, so that's it. Let's restart our application and check the diagram and check that we have all the foreign key correctly created. And here, if we go to this lecture, I'm expecting to have this foreign key right here, which is section ID referencing the section. And also for the columns, we have the ID name and the section ID as a foreign key right here. So that's it. Let's move on and implement the one-to-one relationship between the lecture and the resource. Now, when we talk about a lecture and a resource, we talk about a one-to-one relationship, because one lecture has only one resource, and when we talk about one resource, it belongs only to one lecture. So that's how, or that's from where we got the one-to-one relationship. Okay, just as a reminder, this part we will see later on. Now let's go back to our code. Now, in order to implement a one-to-one relationship, so first of all, define your entities, and in here we have our section, and also we have our resource. So from the section level, let's create a private resource. Let's call it resource. Okay, so when we talk about one-to-one relationships, we can talk about one unidirectional or bidirectional mapping. Okay, so we can link the lecture to the resource, and that's it. So we will have the owner of this relationship is the lecture, and we can access the resource from the lecture. But when we want to go back or access the lecture from the resource, we will not be able to do that because we don't have a bidirectional relationship. So let's start with unidirectional relationship. Now, in order to define a one-to-one relationship, as I mentioned, create an object of the other entity. So in our case, it's an object of type resource. And here we need to use the one-to-one relationship. Okay. So here we have the one-to-one. We can also define the join column name that we want to use. And here, let's say resource ID. All right, so this is how we can define a one-to-one relationship. And then let's restart the application and see the impact of this. So now we see that the application started. Let's check the database. Now, if we go to the lecture, we see here that now we have two foreign keys. The first one is from the resource, the one we just created, and the second one is the one we previously created from the section. But here we need to focus, or we want to focus on this resource ID from the resource. Okay. Also, if we open this one, we can see that we have a new column defined here, which is the resource ID. Okay. Let's go now and implement the second way, or like the bidirectional one-to-one relationship. So just to make it faster, I will just copy these annotations, go to the resource entity, and as we did before, let's create a private lecture, and let's call it lecture right here. Okay, and now let's paste this one-to-one annotation and join column, and this one, let's call it lecture ID. So here, this means when we want to create a new lecture and a new resource, we need to link them together in order to have this bidirectional relationship. Okay, so as we mentioned before, like having bidirectional relationships make it a bit complex to maintain all the foreign keys. All right, so let's go back, restart the application, and check the database. So the application is starting right now. Let's open the database and see. Refresh it. And let's see now from the resource, we will see that we have a new foreign key, which is the lecture ID, and it's referencing the lecture right here. So like this, we just created a one-to-one relationship between lecture and resources. All right, so that's it. We just implemented all the relationships between all our entities and classes. Let's move on, and I want to show you how you can check that what you created is the same as your class diagram. Now, for the people having the ultimate version of IntelliJ and using this database to check the data and refresh the data, and refresh the database and check the tables, so there is one thing that we can do. So here, when you click on this database, you can right-click on it, and here we have in the bottom you have diagrams, okay, and you can show a visualization or you can show it in a pop-up. Let's show the first one, and here it will generate all the tables of our database. Okay, so you can also click on this icon to apply the current layout, and it will reorganize it. And here we see that we have our author. Right here we have our author table. Let's just try to organize it a bit, and we see right here within this diagram that we have the same one as we already designed at the beginning of this course. So we have the course and the author, and here we have the joint table between these two one because we have a many-to-many. We also have a relation between our course and section, and the same between section and lecture, and we see that we have this one-to-one relationship between our lecture and resource. All right, so like this, or this tool might help you checking if you have the correct implementation or if you did the correct implementation or not. So just go ahead, use it, and you can also compare it with this diagram that we just created. So just a double checking, we have author, courses, section, lecture, and resources, and it's the same diagram that we have generated right here. So this one, it will use the database and all the relationships that we already defined to draw this schema. So that's it about all the relationships. Now let's move on to a bit more deep and important stuff that we need to learn together. If you have any questions, don't hesitate to drop me a message, send me an email, or contact me on social media. And also you can go and ask your question on Discord. I will create a special channel for this course, so just go ahead and ask it. Otherwise, let's move on. Previously, we said that we will leave this part right here where we have this resource, video, file, and text entities to a further part. So now it's the time. So here, as we can see, so this is the symbol of inheritance, and we have this resource class. We have also these three classes: video, file, and text. So this means what? This means that a resource can be at the same time can be whether a video, file, or a text. So here we have video extends resource, file also extends resource, and same for the text. So in Spring Data JPA, you can use inheritance to define a base class of your entities and then create a subclass that inherit from the class or from the base class. So this can be useful if you have a number of entities that have some common properties and you want to avoid duplication code or duplicating the code. Okay? And when we talk about inheritance in Spring Data JPA, there are several ways to implement this inheritance. So we have the single table strategy. Also, we have the joint table strategy and table per class strategy. So we will see all of these strategies in details. But here we need to talk before we go and before we leverage inheritance, we need to talk about pros and cons for each one, for this inheritance. So the pros or the advantages of inheritance is, first of all, code reuse. So because inheritance allows you to reuse common code among multiple entities. Also, simplified queries. With inheritance, you can create queries that span multiple entities without having to write separate queries for each entity. Now let's talk about the cons or the disadvantages of inheritance. So first of all is the complexity. Inheritance can make the database schema more complex, especially if you are using a strategy like join table per class or table per concrete class. Also, we can talk about rigidity because inheritance can make it more difficult to change the base class or add new subclasses because it can affect the entire inheritance hierarchy. So this means every time you need to add a field or you need to add a new attribute within the base class, you need to really be careful about the subclasses or the derived classes that extends this base class. So this is mainly the pros and cons of inheritance. Before we move on and start implementing the inheritance strategies, I want to highlight something which is really important, which is composition over inheritance. Because both inheritance and composition are ways to achieve code reuse and modularity in object-oriented programming. In general, it is recommended to favor composition over inheritance, as composition is more flexible and easier to change. Because inheritance involves creating a subclass that is specialized version of a base class. So the subclass inherits the properties and behaviors of the base class and can also have additional properties and behavior of its own. This can be a useful way to share code among multiple classes, but it can also make the code more rigid and difficult to change. If you need to make a change to the base class, it can affect all the subclasses that inherit from it, which can be difficult to manage. Composition involves creating a class that has reference to one or more subjects and delegate tasks to these subjects. This allows you to combine the functionality of multiple classes into a single class without the inheritance hierarchy of a base and subclass. Composition is more flexible than inheritance because you can change the object that a class delegates without affecting the class itself. So in summary, it is generally recommended to use composition over inheritance because it is more flexible and easier to change. However, the best approach will depend on the specific needs of your application. So this is the comparison between inheritance and composition, and as I mentioned, it's always recommended or generally recommended to use compositions over inheritance. Okay, now let's go and dive into these inheritance strategies in case you want or in case you need to use inheritance within your application. So let me teach you how to use it in the correct way. Now imagine with me that we want to add some auditing fields to our entities. Means I want to add some information to track the creation and the last modification of each entity or of each line of my tables in the database. This means for example, this course entity or this course class, I want to add 4 fields like the created at, last modified at, and also created by and last modified by. Same for author, section, lecture, resource, and all the tables that I will create within my database. Okay, so in this case, I will have 4 fields, including this ID. We can count 5 in each entity, but this is okay from the database. But now when we talk about the code, our code, I want to avoid this code duplication and I want to organize it much better. Okay, here we can use one technique to achieve this one, and it's gonna be something like that. We will have a kind of base entity, or we can call it abstract entity or a parent entity. You can call it whatever you want, and in here we will move, or we will try to collect all the common fields between the entities we have, or between the Java classes we have. And for example, we have this created at, last modified at, created by, and last modified by. And I want all these fields to be part of all the entities I have within my database. So for this, it's super easy. Here we will use inheritance. We will create a class. We will call it base entity, and all the classes I have right here, they will extend this base entity. Okay. And this base entity needs to be annotated with a special annotation. And this annotation is called mapped superclass. So this annotation indicates that a class is a superclass that is mapped to a database table. And this annotation is used to define common properties that will be shared by multiple entities without creating a separate table for the superclass. This means the only existence of this base entity is within our code, but from the database side, we will not see any table called base entity. So now let me show you how we can do this. Let's go back to our IntelliJ, and here within this models package, let's create this new class. Okay, so let's create a class, call it base entity, or base class, or base table, call it whatever you want. So this base entity, first thing that I need to do is I need to give it a mapped superclass entity. And as you can see, it's always from jakarta.persistence.mapped superclass. So this means, and this will indicate that this class is a mapped superclass, and any entity that will extend this one will inherit also all the fields that we have right here. Okay, and for this I will create a private local datetime. This one, for example, created at. I want to add a private, so this one last modified at. And I want also to create two strings. For example, this is just an example, and you can create, or you can move all the common fields that you want into this base entity. So here I will create a string created by, so to track who created this entity, I mean like the user who created this entity, and we have also last updated by, or last modified by. Okay. All right. So here within this mapped user class, we can use all the Jakarta, all the persistence annotations like colon, last modified by, last created by, and so on and so forth. So it's a normal entity, but it's just within our Java code base. Okay. Now also let's check right here for all the classes, or for all the entities that we created right here. We have this integer value, this integer ID, which represents the ID of our entity. So also, if you have always the same name for all the entities, what we can do also, we can also move this entity right here to this base entity, right? We can use this field right here. So now we can see that we have this ID, generated value, and so on and so forth. I will also just go ahead, add some Lombok annotations to generate the getters and setters, and so on and so forth. All right. So I will just copy this one, and I will give you a small hint, which is super important here when we work with Lombok. So here we see we have all the getters and setters, but here within this one, this is going to be the parent entity, and we want to use a builder. When we use a builder within a derived class or the child class, we will not be able to access these fields right here. And to do so, Lombok, they created an annotation called superbuilder from the for now it's from the package lombok.experimental and might be moved later on, but the annotation is called superbuilder. All right, so here what we need to do first is use this superbuilder with all the entities that will extend this base entity, or in any case if you have inheritance between your classes and you want to use this builder annotation, just go ahead and use this superbuilder instead. All right, so now let's go back to this author entity, and we see right here this one is in red because we don't have the primary key. But once we extend our base entity, this error will move on. Okay, so this is now gone. All right, and also when we use inheritance and we use this data annotation, we need also to add the equals and hash code annotation. All right, and here it needs to call the super. So these are some hints for you when you want to use correctly all the annotations from Lombok and also from the JPA or Java Persistence API. Also, go ahead and check my course about Lombok and the useful annotations that you can use and also how they work. All right, let's move on right now. I will also make these changes to all the entities we have right here. And when we restart the application, we want to make sure that we have everything as we had before. Plus, I want to see these 4 fields right here. Okay, so I will go ahead and do it for all of them. So what we need to do, or the way we need to implement this, so let's first replace this builder with super builder, and let's extend the base entity. Next, we need to remove this ID field with the annotations. And that's it. So this is how we can extend, or this is how we can inherit from this base entity and keep everything working fine. Also, don't forget to add the equals and hash code annotation. Let's do the same for lecture. And so this one extends base entity. Let's move this ID field. You can skip this one like for the rest of the entities if you are familiar with that. And here, and I will also do adding equals and hash code. All right, so next one is resource. Same thing here. Let's also extend our base entity right here and remove this ID field. Next one is section. And then we will restart the application and see the changes. So let me remove this and extend the base entity. All right, replacing also the builder with the super builder, and here we also need to add the equals and hash code, and then you can optimize the imports to have your code as clean as possible. All right, so here what we have, or this is what we have right now. Let's go first and check the database, make sure that we have everything as before restarting the application. Let's make sure that we have the same structure and the same tables that we have right here. Okay, so now go ahead, start the application. Because I stopped the application, that's why we don't have any tables right now, because we have the property create drop. But let's start the application first. So everything is started and we have all the entities, but we don't see that we have a base entity getting created, and this is what we expect. Now I will refresh the schema right here, and we see that we have these 6 tables. All right, author, and this is the join table. And if I open this author, I see now I have 9 columns, including this created at, created by, and last modified. Also, I still have the same ID, and this ID is inherited from this base entity. So this is how you can group the common the common fields within one entity, and this can make your code a bit cleaner, and you can group. And if you want, for example, to change the type from local date time to, for example, just java.sql .date here instead of this local date time, you can do this change only in one place instead of doing this change in all the places. Also, for example, if you want to link this created by and last modified by to the real user table in the database, you can just update and modify in one place. So this is how the mapped superclass works. And as I mentioned, finally, before we end this part, using the mapped superclass annotation can help you avoid duplication of code and make it easier to maintain common properties in large applications. However, keep in mind that the mapped superclass does not have its own table, so do not forget this one. And if you want to use a mapped superclass entity, so do not expect to have a separate or its own table. And it cannot be queried or persisted directly. So we cannot query this base entity, and we also cannot persist this base entity. It can only be used as a base class for entities. All right. So if you have any questions, don't forget to drop me a message. Otherwise, let's move on. Now let's talk about inheritance within this part of our class diagram. All right, so we have here, just a reminder, we have our resource, video, file, and text. Okay, so let's first prepare and create these three classes. Right here, I will create class called video, file, and text. And then let's explain and see how we can implement the different inheritance strategies. Okay, so let's go back to our IntelliJ, and here again with this models package, I will create three classes. But first, I want to go and open these resources, and I will just roll back all these changes. I want to use this integer right here. Why? Because we cannot extend multiple entities or multiple classes using Java. All right, so this is the only and unique reason for that. So because our focus right now is the inheritance regarding this resource. Otherwise, I can also show you how we can do, or how we can implement multiple inheritance. All right, okay, so this is what we have right here. And now I will just go ahead and create my first class. I will call it video, and this video, it will have also the same without the entity. I will just copy these annotations, the Lombok annotations, but here instead, as I mentioned before, it will be, or it should be, super builder. And for this video, I will have right here a private int length. So it's just the length of the video. I will create another class like we have right here. We have file and text. Okay. Now I will create a file class. So this file, it also will have the same annotations, and here I will use the super builder instead. Do not forget also to update or improve the imports. And here I will have just private string type. So the type is just to say if it's, for example, PDF, TXT, Word, and so on and so forth. All right, let's create now the third class, which is text. Also, do not forget to paste the Lombok annotation and change this one to a super builder. And within the text, we have our private content attribute, private string content, and that's it. Now we have the three files, or the three classes that we have: video, file, and text. And now we can go back and start explaining and implementing the different inheritance strategies using Spring Data JPA. Let's first see the single table strategy. So this strategy is a way to map an inheritance hierarchy to entities to a single database table. This strategy is used in Hibernate or Spring Data JPA, or mainly when we talk about the Java Persistence API, so JPA, to define how inheritance is implemented in the database. With the single table strategy, all subclasses of the inheritance hierarchy are mapped to the same table. And then we need to talk about a discriminator colon is used, or we need to use it to distinguish between the different subclasses. So the discriminator colon contains a value that indicates which subclass a particular row in the table belongs to. And when the single table strategy is used, all of the properties of the parent entity class and its subclasses will be persisted to a single table. The discriminator colon is used to determine which subclass a particular row belongs to. Now, the single table strategy is the simplest way to implement inheritance in the database, but it can lead to inefficient queries and a large table size. It is best suited for situations where the number of subclasses is small and the inheritance hierarchy is not deep. So this is theoretically how single table inheritance works. Now let's try to implement this. First of all, to implement the single table strategy, so we go first of all to the parent class or the base entity, or whatever you can call it, whatever. And in our case, this is our base entity or the parent class. But first of all, here this one needs to be super builder, because if in case you need it later on. And now here we need two things. We still have this entity annotation, which we need, and we need also to add this inheritance annotation, and it's the one from always jakarta.persistence. All right, and within this inheritance annotation, we can define the strategy. And here we can see that we have joined, single table, and table per class. All right, but as you can see right here, by default it's using single table. So whether you precise single table or not, it will be by default single table. Okay, so you can just use inheritance annotation without the strategy, so it will take as a default value the single table. All right, so this is the first step. Now let's go to this video, file and text. And in here, optimize the import first. Let's collab this one. And now within this video, I will just add the entity annotation. Okay. So the same, and here from this video, we need to extend our resource, because a video is also a resource, right? And don't forget, with this data annotation from Lombok, when we use inheritance or we extend another class, we need also to implement the equals and hash code with the attribute or the property called super equals true. This is just a reminder for you. Let's go ahead and do the same for file. So here we need the entity annotation, and now we need also to extend our resource entity. And then we need to add the equals and hash code annotation. Let's do the same for text entity. Let's extend a resource right here. And finally, we add the equals and hash code annotation. All right. So here we have everything up and ready for us. Okay. Now let's restart the application and see what will happen with only this configuration that we wrote right here. So click on restart. So now the application is up and running, and we see that we have no exceptions. So everything is good so far. Let's move this one, and here let's go back to our database. Click here and update or refresh the database. So we have the inheritance within the resource column, and we see now that we have 9 columns within this class. Okay, so we see here that we have ID, name, and so forth, but we see here that we have the extra field, and we see here that we have the size. This one, this is the one coming from the file or from the video. We have also the type, we have the content, and so forth. We have also the length. And what happened right here with this basic configuration, so Hibernate, he grouped all the fields within the parent entity. So everything now is within this resource. And if we want, for example, to create a content and so forth, if we want to create a new instance of type text, we need to fill all the information, including all the information from the resource, including the content. Okay, now let's try to give some more differentiation between the entities. All right, so let's see what we can do as extra configuration to make this more clean and more beautiful to use. All right, so now let's talk about this discriminator value. This discriminator value will give a value that we will specify in advance to each type or to each derived class. So for example, if we give the value V for video, F for file, and T for text, we will add a column called type right here to the resources. And then this resource type, every time you create a new instance of video, this type will be automatically V, F for file, and T for text. All right, so let me show you how we can do that. So here we have our inheritance strategy, which is single table. Now we need to add another annotation, which is discriminator colon. And this one, it's just to give the discriminator colon name. And here for this name, by default, it's dtype. If we do not precise this colon, by default, it will be dtype like we have right here. Okay, so it's the discriminator type. But let's give it a special name. Let's call it resource type. All right. So from the parent class or the parent entity, we need to add this discriminator colon to specify the colon that we want to use. Otherwise, you can leave it to the default one, which is dtype. All right. Now let's go to the different entities. Now, after this entity annotation, just go ahead and add a discriminator value. So this discriminator value, let's, for example, as we mentioned before, let's give it V for video. I will just copy this annotation and paste it in the different entities, F for file, and T for text. So now if we restart the application, we will see that instead of this dtype colon, we will have our resource type colon right here. So I will restart the application, and here the application is restarted. Let's open the database and refresh it again. So refresh this resource table or all the database. So within this resource, we see that we still have 9 column, and now our column is called resource type. All right, and we have this name, size, and so on and so forth. Those are the attributes that we have from all the children classes. All right. Now, if we create a new instance, or if we want to persist a new file, we will insert all the data, including, for example, for the file right here, we have the type. We will say, for example, PDF right here and all the information, and automatically this resource type will be V. So the value of this resource type, it will be automatically F, sorry, not V, because F is for file. So it will be F for file, and it will be V for video, and so forth. So you don't need to worry about worry about filling this resource type, because every time you create an instance of the children or the child class, it will be automatically filled using this discriminator value. All right, so this is how it works. And in the next step, I will show it to you in action. We will insert, for example, a new file or a new video into the database, and we will see what will happen. Let's see now in action how we can, how this is gonna look like. All right, so I will close everything right here. And in this repositories package, I will create a sample repository for this entity called video, because we want to check only one of them. So here I will create a new class. I will call it video repository. So for you, in case you want to use inheritance, you need to create, of course, one repository per entity. Okay, and here let's extend JPA repository, and let's give it the type video, and of course integer for the ID. So this is our repository right here. It's ready to use. Now let's open our main class, or our JPA application class, where we have the Spring application repository, and I will inject right here our video repository. I will call it video repository. Okay, and I will bring back this bin annotation. Okay, so this is gonna save this author, but I will just comment this out because I don't want to insert any other lines. So now let's use this video repository to insert one data. So I will have here var video equals video.builder.build. So for this video, I will just precise or give some information like the name, for example, ABC dot length. Let's check our video right here. We have the length, and let's say, for example, it's 6 minutes or 5 minutes. It's also okay. And let's give it another information, which is I guess that's it. Okay, so let's give it just the name and the length. And here let's use our video repository dot save this video entity. Okay, and now all we need to do is restart the application and see what will be inserted in the video or in the resource table into our database. Let's restart now. So the application is restarted, and we see also that we inserted something into the resource table. And here we see that we have this resource type, but we did not precise it. Just to remind you, here we have only the name and the length. Okay, let's check this resource table right here. I'm going to refresh the database or the table, and then double click it to show the content. So we see the content right here, that we have, first of all, we have V for the resource type, and this is something that we did not precise. We have the ID, name, we have the size, which is 0 because it's an int. That's why it's 0, because int by default equals 0. And we have the URL type, and so on and so forth. Also, we have the length that we precised. So we have the name ABC, and the length equals 5, and the resource type is V. So if we do the same for file and text, it will be F for file and T for text. So this is how single table strategy using discriminator colon and discriminator value. This is how it works. So if you have any question, just go ahead, drop me a message. Otherwise, let's move on and check the next strategy. Now let's comment, first of all, this bin annotation, close this class, and now we will talk about the next strategy, which is joined table. This strategy, each subclass in the inheritance hierarchy is mapped to a separate table with a foreign key pointing to the base table. This allows each subclass to have its own table with only the properties that are specified to that subclass. Okay, so when the joint strategy is used, each subclass will use or will have its own table with a foreign key pointing to the base table. This allows each subclass to have only the properties that are specific to that subclass, which can lead to more efficient queries. However, it also requires more tables and foreign keys, which can make the database schema more complex. The joint strategy is a good choice when you have a large number of subclasses with significant differences in their properties and you want to optimize the performance of your queries. However, it's not suitable for situations where you need to query the entire inheritance hierarchy at once, as it requires multiple joins to retrieve the data. So these are, let's say, the pros and cons of this strategy. Now let's see how we can implement this. So let's go back here to our resource. Let's collapse this one and let's go back to our resource entity. So now instead of this inheritance, first we need to comment out this one because we don't need this discriminator colon anymore. And now for the strategy, instead of single table, we will use the joined one. All right, so this is the only required change from the base entity. So we have this entity and again the inheritance with the joined strategy, and no discriminator colon is needed. So this one I will just type it right here, only with single table. All right, so you don't mix when you directly check the code, you don't mix with this annotation right here. All right, so now let's go to the subclasses. Let's start with this video right here, for example. And now for this video, we don't need these discriminator values. So let's go ahead and remove them all, because now, as we mentioned, we will have a table per subclass. Okay, so that's it. This is how the join table works. Let's restart the application and check what will happen. So now the application is up and running. Let's open our database and refresh it. So refresh it right here. So we see now that we have this file, we have this text, and we have this video table. So let's check the columns. Here we have this content and the ID. Also, we have one foreign key, which is this ID, which is pointing to the resource. All right, so this text table contains only this content, which is the attribute that we specified right here. Let me make it in both sides. So we have only this content right here, and we have this ID, which represents the primary and the foreign key at the same time, because we see right here that we have these two icons, the blue one and the golden one. So they point to the same thing. So it's primary and a foreign key at the same time. And we will see the same thing if we open this video right here. So we have also the length and the ID. And now let's try to insert some data. We have already something in here within our JPA application. Let's bring this bean back. Let's restart the application and check what will happen. So now the application restarted, and we see here that we have two insertions. Instead, we just created a query, or we just inserted one element into our video table. All right, so here what we have this video.builder, and we precise the information of the video, but we see right here that we are inserting into resource and we are also inserting into video. So let me show you how this is represented as data in the database. So first of all, I will open the resource. Let me make this one full screen. So here we see that we have the ID, we have the name, which is ABC, the one that we specified, and we have this default values for the rest of them. If I open the video right here, I see that I have this ID colon, which is, as I mentioned, which is the primary and the foreign key at the same time, and we have the length that we specified. So automatically Hibernate inserted two elements or two lines into two different tables because we have our strategy as joined. Okay, now let me show you something you might also want to do in case, for example, you want to give a special or a custom name for this ID colon, which represents the foreign key. We can use an annotation for that. All right, so let me make it full screen. I will keep the bean for now, and I will just comment it out once we are finished with this join table strategy. All right, so within this entity, or within this entity called video, which is a subclass, here we can use an annotation called primary join colon. Okay, so this primary join colon, we can give it the attribute name, and here I will call it for example video ID. All right, so now when I insert or I restart the application and we will insert some data, we will see that this ID right here, this column right here, ID, it will now be renamed to video ID. Let's restart this. So first of all, we can see it already in the insertion query. So when we insert into video, we have length and video ID. Also, if you scroll a bit up and you check the code of creating the table video, we have length and we have video ID instead of ID. So by default, it will use the ID name or the ID name field of the parent class. So in this case, it will use this one. But if we want to customize it and have our own name for each entity, we can also use this primary key join colon. So let's open this video and we see right here, it's now called video ID. All right. So that's it. So this is how joined table works. Again, before we finish, let's go back to our JPA application and let's comment this out. And in case we need it, we will bring it back again. All right. So if you have any questions, don't hesitate to drop a message, write me an email, contact me on social media. Otherwise, let's move on. Now let's see the table per class strategy. So the table per class strategy, each concrete subclass in the inheritance hierarchy is mapped to a separate table. Abstract subclasses are not mapped to a table, and their properties are inherited by their concrete subclasses. So you may ask the question, what is the difference between this joined table or and also the you might ask the question, what is the difference between the strategy joined and the strategy table per class? So it's super easy. Let's check. Now we still have the joined table right here. So here we have the resource that contains the columns of the base entity or the parent entity, which is name, size, URL, and so on and so forth. And each subclass contains only its own attributes with the ID in plus. All right. Now, when we talk about a table per class, this means that we will have a table with a table video, for example, with all the attributes from the resource table joined into this text table. All right. So this is the main difference. This means that we will create a table per each subclass. So when the table per subclass strategy is used, each concrete subclass will have its own table with a copy of all the properties inherited from the base class. This allows each subclass to have only the properties that are specific to that subclass, which can lead to the most efficient queries. However, it also requires the most tables and can make the database schema more complex. So in case you have multiple inheritance or many subclasses, so your schema might be a bit complex than the normal. So the table per class strategy is a good choice when you have a small number of subclasses with significant differences in their properties, and you want to optimize the performance of your queries. However, it's not suitable for situations where you need to query the entire inheritance hierarchy at once, as it requires multiple tables to retrieve the data. Now let's see this in action. Let's see how we can implement this table per class strategy. So the implementation is super easy. There is not a lot of things that we need to change. So first of all, let's go back to our base entity, and here instead of inheritance joined, let's use table per class. All right, so this is the first change, and I will just go back to the video right here and comment out this primary key join annotation because it works with the joined strategy. So that's it. All we need to do to mention here that we want to use a table per class. Now let's see the impact when we start the application, and then we will see, or let's also comment or bring back this bin annotation, and let's see what will happen when we insert a new video within our database. So let's see the schema changes and also the impact when we insert data. So first of all, we see here that we have only one insert, which is inserting into video, and we have the lecture, name, size, and so on and so forth. Now let's see how this is represented in the database. So now I will go back here and click on refresh. And we see right here that we have this, for example, this video table right here. We have our all the attributes, and we have the size, and so on and so forth. So we have all the attributes from this resource table, and we also have the attributes from the video. All right, so if I open this video, we see right here that we have the ID, name, size, and so on and so forth. So we have all the information joined into one table per subclass. And if we check also, for example, file or text, we will find the same thing. So here we have 6 columns, and this is the content or the attribute that we have from the text. All right, so now this is how inheritance works with Hibernate. Let's go ahead and check a few issues that we might face when using inheritance and how to solve them. When we work with inheritance, we can also query the base entity. So we can define the strategy that suits us, and we can also, or we want, for example, to retrieve all the resources of our database. Okay, it's like select star from resource and that's it, or like using the find all method. All right, but we have one issue, is when we query this resource table, we want, for example, just to get all the informations or just the attributes of this resource entity, and we don't want to get any information about file, text, video, and so on and so forth. I just want the resources, not the subclasses of that. So this is this one, like in the background. So in the background, when querying the base class, which will return all the subclass records as well by using a union statement in the background. And the use of union can also lead to inferior performance when choosing this strategy. Another issue is that we can no longer use identity key generation. All right. So when we use this type of inheritance, we might face the issue of polymorphic queries. So as mentioned, querying a database class will retrieve all the subclasses entities as well. Now, if we don't want a subclass to be returned by the type of the query, we only need to add a Hibernate annotation to to say or like to exclude it from the definition. So for example, if I want to exclude this video right here, if I want to exclude this video entity when I want to query the resources, I need to add one annotation to exclude it from the parent when I query the parent. All right, so this annotation is called polymorphism. And here I need to give it a type. So polymorphism, and the type right here, it's polymorphism type dot explicit, because by default it's implicit, means when I query the resource.java, it will automatically query all the subclasses from that one. But if I say I want it to be explicit, this means that it will query this video only when it's required or only when I ask for it. Otherwise, it will not query it. Okay, so this is how we can solve the polymorphic queries issues. So just go ahead, use this annotation and exclude all the subclasses that you don't want to query. Okay, so if you have any questions, don't forget to drop me a message. Otherwise, let's move on. In this chapter, I want to teach you how to work with embedded IDs or embedded entities, generally speaking. All right. First of all, let's define what is an embedded IDs or embedded entities. Okay. So in software, we come across many use cases when we need to have a composite primary key to define an entry in a table. A composite primary keys are that use more than one column to identify a row in the table uniquely. So within one table, we can define more than one column to be the unique identifier of that column. Okay, so we represent a composite primary key in Spring Data JPA by using the embeddable annotation on the class level. This key is then embedded in the table corresponding entity class as the composite primary key using the embedded ID annotation. We will see all that in details. But first, let me give you a use case for that. So here, like I have this other table 1, other table 2. It's just an example to tell you that this is an independent database. So now let's take the case or the use case of a microservice. And now we will talk about the order microservice. All right. And here we have, for example, this order table. So this is just an illustration example. It's not a real life example, just for illustration. And here, let's go back and we take this order table we have right here, and we don't want to rely on generated IDs. Okay, I don't want to create a generated ID which is auto incremented to be my unique ID of this table, but I want to have my own ID. I want to create my own ID, but this ID, I want it to be composed. Why I want it to be composed? It's not just a want, but it's a need. Why? Because in real life, one user can order or can pass or validate many orders at the same time or in one day, for example. Okay. So in this table right here, we can find the same username multiple times. So this means that we cannot rely only on the username. Okay. So we have here order date, and the order date itself, we cannot just rely on this order date, because at the same time, even at the same milliseconds, we can find more than one user ordering something. All right. But when we talk about the composition, when we talk about username and order, both of them, this is unique. So both of this username, the combination of the username and the order date, it's unique. This means like the unique identifier of one order will be the username, for example, Alibu as a username, and the order date, let's say the 01/01/2023. at, for example, let's say midnight. Okay, so at this time, we have only one user, this Alibu user. He's the only one passing this entity, this order. Sorry, not the entity, but the order. But we can also find another combination at the same order time, but within another username. So like the combination of username and order date is something unique and we can rely on. So this is the use case, or one of the use cases when we need to use embedded IDs. All right, so now let me show you in action, let me show you in real life how we can create embedded IDs and how we can use them within our entities. In order to demonstrate that, let's first create and prepare the ground for that. So to use embedded entities and using the embedded IDs, what I will do, I will create a sub package within this models package, and there I will put all the entities and all the resources related to this embedded ID example. So right click right here on the models, and then I will create a new Java class. I will call it order ID. And this order ID, I will create it within the package embedded. Okay. So I will just call create a package called embedded, and within this package, I will create my class called order ID. Hit enter, and now we have our package, and also we have our entity. So now, in order to create an embedded ID, so first of all, you need to define the IDs or the attributes that you want to rely on to use that as an ID. And as our case demonstrates, so we want to have something composed of username and date, or we can call it order date. So I will first of all create a string username. And here I'm just assuming that the username is something unique. So we don't have two users with the same username. Then let's create a private local date time. Let's call it order date. So this is the username, or this is the entity. Well, actually it's an entity, but it's not a persistent entity. It's something like the mapped superclass, the example we saw before, but it's not a persistent entity. It's just a composition where we can compose multiple attributes and we can use them as an embedded ID. So first of all, we need some annotations. I will use the data from Lombok, all args constructor, the no args constructor, and here I will use one annotation which will make this one an embedded entity. So here the annotation is called embeddable, and this embeddable comes from jakarta.persistence because we are using Spring 3. This is just a reminder, so let's use this embeddable annotation. Using this embeddable annotation, we'll tell Hibernate and Spring Data, generally speaking, that this is an embedded entity. Now, how to use it, I will show you just right away. So within this embedded package, I will create my order class or order entity. Okay, so I will call it order. And here I will just copy this information. So these are the annotations that I will need. And of course, my class is an entity, so we need the entity annotation. And first of all, I will create a string. Let's call it order info, for example, and a private string, another field, because our focus is not about the fields, but it's just to say that we have few information or few fields within the order entity. So now we see the same error that we know here when we create or we map a class or a Java class with the entity annotation. So it will claim about an ID. So here it says that this persistent entity order should have a primary key. And here it's asking to add an attribute or an ID attribute. For us, as we mentioned before, we don't want to use an auto-generated or an auto-increment ID, but instead we want to use this order ID class we just created. So first of all, I will create an instance of that, or a field of type order ID, and I will call it ID. All right. So for now we have this order ID, but it's still not known as an ID for this entity. Now to make this one an ID, we use the annotation embedded ID. All right. So this embedded ID right here. So here we see we also still miss something, but first I will go back to this in a few seconds. First I want to show you, and I want to go quickly to the documentation of this embedded ID annotation. So here it says applied to a persistent field or property of an entity class or mapped superclass. So here you need to focus, it's entity class or a mapped superclass to denote a composite primary key that is an embeddable class. The embeddable class must be annotated as embeddable. So this is the annotation we already used. Also, there must be only one embedded ID annotation and no ID annotation when the embedded ID annotation is used. So this means when we want to use the embedded ID annotation, we cannot have another ID annotation within this one. All right. So next, it says that the attribute override annotation may be used to override the column mappings and so on and so forth. And this one we can also skip. You can have the time to read it. And here it says if the entity has a derived primary key, the attribute override annotation may only be used to override those attributes of the embedded ID that do not correspond to the relationship in the parent entity. Okay. And here also you can see an example. We have, for example, this employee primary key with this embedded ID. And here we see that we have this dependent ID annotated with the embeddable annotation right here. Okay. So this is a bit and quickly the annotation of this embedded ID. Now let's go back and check this error right here. Okay. So here it says that the class order ID should implement the serializable. So when you want to use an embedded ID, absolutely think about extending and implementing the serializable interface. Okay, so this order ID should implement serializable. So the serializable is the one from java.io package. Now, if I go back to the order, now the error is gone and I have my entity. So within this embedded package, I will create my order class or order entity. Okay. So I will call it order. And here I will just copy this information. So these are the annotations that I will need. And of course, my class is an entity, so we need the entity annotation. And first of all, I will create a string. Let's call it order info, for example, and a private string, another field, because our focus is not about the fields, but it's just to say that we have few information or few fields within the order entity. So now we see the same error that we know here when we create or we map a class or a Java class with the entity annotation. So it will claim about an ID. So here it says that this persistent entity order should have a primary key. And here it's asking to add an attribute or an ID attribute. For us, as we mentioned before, We don't want to use an auto-generated or an auto-increment ID, but instead we want to use this order ID class we just created. So first of all, I will create an instance of that, or a field of type order ID, and I will call it ID. All right. So for now we have this order ID, but it's still not known as an ID for this entity. Now to make this one an ID, we use the annotation embedded ID. All right. So this embedded ID right here. So here we see we also still miss something, but first I will go back to this in a few seconds. First, I want to show you, and I want to go quickly to the documentation of this embedded ID annotation. So here it says applied to a persistent field or property of an entity class or mapped superclass. So here you need to focus, it's entity class or a mapped superclass to denote a composite primary key that is an embeddable class. The embeddable class must be annotated as embeddable. So this is the annotation we already used. Also, there must be only one embedded ID annotation and no ID annotation when the embedded ID annotation is used. So this means when we want to use the embedded ID annotation, we cannot have another ID annotation within this one. All right. So next, it says that the attribute override annotation may be used to override the column mappings and so on and so forth. And this one we can also skip. You can have the time to read it. And here it says if the entity has a derived primary key, the attribute override annotation may only be used to override those attributes of the embedded ID that do not correspond to the relationship in the parent entity. Okay. And here also you can see an example. We have, for example, this employee primary key with this embedded ID. And here we see that we have this dependent ID annotated with the embeddable annotation right here. Okay. So this is a bit and quickly the annotation of this embedded ID. Now let's go back and check this error right here. Okay. So here it says that the class order ID should implement the serializable. So when you want to use an embedded ID, absolutely think about extending and implementing the serializable interface. Okay, so this order ID should implement serializable. So the serializable is the one from java.io package. Now, if I go back to the order, now the error is gone and I have my entity. Okay, so if I start my application, I should see my order class or my order entity created in the database, and I should see a composite primary key. Okay, so let's go ahead, click start and check these updates. So let's check the logs. Okay, here we see an exception. So the exception is we have a PSQL exception, and this is because we have a syntax error near order because the order is already a reserved keyword. So to solve this, you already know the solution. Let's use the table annotation. Okay, let's give it a name and let's give it underscore order. Right? So now restart the application and we should see everything working fine right now. All right, so the application now is running. We check, we don't have any exceptions, no issues. And also we can check the logs and you will see that we have our order table getting created. Okay, so now let's go ahead, check our database, refresh and see. So here we have this order table. Let's open it and we have already 4 columns. So for these 4 columns, we see that we have this order date and username. Both of them, they contain or they have this golden key icon. So this golden key icon is the primary, or is the icon of the primary key. So our primary key in this database is the order date and the username, both of them concatenated. All right, so if we check the keys right here, so we see that we have this underscore order underscore p key. So it's order primary key, and it's a composed key, and it's composed already of this order date and username. So this is how we can create an embedded ID. In case you need to create an embedded ID, now you have the knowledge to do it. So if you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. So now we saw one example or one usage of this embeddable annotation. I want to show you another one. Let's go back to our diagram right here. And for this order, for example, we want to have, or we want to add some information about the delivery address, but we want this information to be embedded within the same entity or the same table right here. So I don't want to store the address or the delivery addresses in a different table, but I want it to be within the same table order right here. You might say this is so easy to do. All I need to do is within this order entity right here, I just declare the information of the address, okay? But yeah, the answer is yes. But imagine we want to use the same address object also to store the address information with our tables within the same database or within the same schema. So like this, what I need to do is to duplicate the code in each entity, which is not good. Okay, we have a better solution. Okay, the second one, you might say I can use the mapped superclass and extract all these entities and just extend my entity with this address entity. I say, okay, this also feasible, but if you have multiple inheritance right here, if you already, for example, extend a base entity, or if you extend another, or you have inheritance within your database. So what should be the solution? The solution can be using the embeddable entities. All right. So within this package embedded right here, right click and create a new Java class, and let's call it address. Okay. So this address, first of all, we will need the same Lombok or the same basic Lombok annotations right here: data all args constructor and no args constructor. And now I will just create few dummy fields. So here I will have string street name, private, also another string house number, for example. House number, it's a string just in case you have 1A, 1B, 1C. And private string zip code. So it's also string, it might start with 0, and so on and so forth. So let's not focus so much on the fields right here, but our main focus is to understand how this embeddable works. So once we create and once we define all the attributes of our embedded entity, as we did in here within this order, we need to use this embeddable annotation. Okay, so let's use this annotation right here, and like this we just created our embeddable entity. Now I will show you how you can use this embeddable entity as an attribute within another entity. Now let's go back to our order class, and within the other fields that we created, I want to create a new field of type address. So I will create an address and I will call it address. All right, so now I want to tell that this address is an embeddable entity within my order entity. All right, so I already mentioned the solution. So let's use the embedded annotation. Okay, so here we have embedded ID and this is embedded, and let's check quickly what is this embedded annotation. So it specifies a persistent field or property of an entity whose value is an instance of an embeddable class. So the embeddable class must be annotated as embeddable. All right, so the attribute overrides, and so forth may be used to override mappings declared and default or defaulted by the embeddable class. So here you can also override some attributes when you use this embeddable class. All right, so this is the embedded annotation. Now let's go ahead, start and test it. Click on restart right here. So our application is up and running right now, and let's go ahead and check the database. So now I will just refresh the database and let's see what will happen right here. So within this order table, we see right now that we have 7 columns, and here we see that we have the house number, street name, zip code, and so on and so forth. So the fields of the address are now included or embedded within our order table. So if you want to do, or if you have a need and usage like that, or use case like this one, always think about using embeddable entities. All right, so embeddable entities will make your code much easier and improve the granularity of your code, and your code will be really reusable. All right, so because this address entity or this address class right here, we might use it in many places. So in order to duplicate, not in order, but instead of duplicating the code of the fields of this address class, just create an embeddable entity and use it or call it whatever you need. If you have any questions, go ahead, drop me a message. Otherwise, let's move on. Previously, we explained the hierarchy of the Spring Data JPA interfaces and how this helps us and provide us with methods and predefined methods to search data and query data from the database. So now we cannot talk about Spring Data JPA and not talk about querying data from the database. And querying the data means reading and writing and also deleting and all the interactions and the transactions that we can make with our database. The Spring Data JPA and the repositories and the JPA repositories, they provide us several ways to dynamically generate queries at runtime. So these are called query generation from method names, or also known as derived query methods. Okay, and these derived query methods, they allow you to define queries based on the method name and of the query method you are calling. So for example, if you want to find the author right here, let's first, before going to this method right here, let's just recap and remind about what we have. So we created before an interface called author repository because we have an entity called author right here. And this author repository interface extends already the JPA repository, which is a generic interface that takes 2 parameters. The first one is the entity in question, and the second one, the ID type that we use within this entity. Okay, so this JPA repository will use the author.java, our entity that we created. And just a reminder, with the author, we have these IDs, or these, sorry, not IDs, but these fields. We have an ID, first name, last name, email, and age. Okay, so here within this author repository interface, which extends already the JPA repository, as I mentioned before, we can create methods. Okay, so it's an interface, and you know, within an interface, all we need to do is the return type, whether it's a function or a void, and then the method name and the parameters. This is how we create methods within an interface. So as I mentioned, Spring Data JPA provides us a way to dynamically generate queries, okay? And we called it derived queries or derived methods. So this is how we can write it. So here, as I mentioned, it's the return type and then the methods that we want to, okay? So let's explain this example right here. We have this list of author. So our method will return a list of authors. And here we have find by last name. And we have our last name, or LN, as you can call it as you want, as a parameter. So what will happen in here? So this find by last name method generates a query that search the users or search the author with a specific last name, and this method right here, for example, this find by first name and last name will generate a query that searches the authors or the user by first name and last name. Okay, we can generate other queries like in here, for example, we can count. We don't have only the find by, we can also count. We can also delete. We can also do as many operations as we know in SQL using the derived query methods. Okay, so for example, if I want to count all the authors in my database by age, so all I need to do is to write the return type, and Spring Data JPA will take care of the conversion. Okay, so the count all by age, within the age, it will create a query that counts all the authors in this author table by the age and return this value. Also, if, for example, we have already the delete methods that we can use, or the predefined delete methods, but if we want, for example, to delete the list, or we want to delete a list of authors by age, all we need to do is delete all by, and then we have age, like by, and here it's followed by the property that we want to use. Okay, so let's explain a bit more. Here, in order to generate one of the methods right here that will create a query behind the scenes at the runtime, all we need to do is we have find by and then followed by the property. Okay, so this is the simplest way. So it's find by and then followed by the property name, and depends on the return type right here. Spring Data JPA will determine what to return exactly. So here we have find by, so it will search everything from the database and return the result set. Okay, but if we have, for example, here an author or an optional of authors, so I will explain the difference. So an optional is the design pattern null pointer. So this is a wrapper to wrap this author object within this optional class right here. So this find by email, Spring Data JPA will search the author by email from the database and then return a type of an optional of type author. Okay, so also the same here, we have this find by email, but in this case we will return the author. So Spring Data JPA will do nothing except creating an object author and just return it. Okay, so here, as I mentioned, we have the find by followed by the property, and then you can create as many methods as you want. Okay, so this is the first one. Also, we can use find all by, so they both work in the same way. We can use find all by last name, find all by first name, and so on and so forth. Okay, now we can also combine properties. Combine means what? We can use operators such as and or. So I can search the list of authors by first name and last name. Okay, so here we see that we have find by first name and last name, and we need to pass these two parameters. Okay, so fn for first name, ln for last name. Okay, we can also use, for example, let's go back to this method. I want to ignore the case when I want to query all the authors or the list of authors from my database. So here we can say find by last name and then followed by ignore case. Okay, we can also use other operators like not, like we can use find by last name like, so means this contains, and so on and so forth. Okay, so we will see all this in action. We will see how we implement, or how we can implement these methods. Okay, so I hope this part is clear. If you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. Now let's see all this in action. So first of all, I will teach you how you can write these methods. So as we explained before, first of all, we start with the return type. So here, imagine we want to fetch the list of authors from our database and from this author table by first name, for example. Okay, so when we say that I want the list, automatically think about having a list. Okay, so here you can whether work with lists, array lists, collections, and so on and so forth, but I always recommend using interfaces. Don't use classes, use interfaces, so in order when you want to change the implementation, it's easier. Okay, so let's go back. So here we have a list and then the type. So we want a list of author, and then you have this find by. So automatically when you type find by and you have the type as list, so it will automatically transform it or map it to a list of authors. You can also, when you work with lists, you can also use find all by. Find all means that you want to search everything. Okay, so they both work in the same way. So let's use find all. So then here, if you have the IntelliJ, the ultimate version, or for the people who are using another IDE which provides auto completion, so here when you do command space or control space, you will see that your IDE will propose the list of properties or the attributes that you have within the author. Okay, so and here you can have a look on the generated or the auto-generated properties, which are automatically detected from this author entity. Okay, so we can see age, for example, and even within the age, we can see that we have a lot of methods. Okay, so imagine we have all these methods within only the age property. For example, if I want to search all the authors where the age is null, so I only need to query find all by age null, age not null, age not like, not in, and so forth. So you can have a look on all these methods, and we will explain most of them. Okay, so here, for example, I want to search all the authors by first name. So all I need to do is to type first name. Okay, and within this first name also, I can see that I have a lot of auto completion. So after, before, between, by the way, not all of them are applicable, because when we say first name, after, here mainly we are talking about dates. Okay, before also dates, and between, and so on and so forth. So you need to be careful. Not everything auto generated here is usable or applicable for this specific property. Okay, but you will learn it by the time. So now this find all by first name is completely sufficient. Now I need to provide my parameters. So here you need that you have the same type like in here, and then just type any name. I will call it fname just to mention and to make sure that this works. I don't need to pass the same here, the same attribute name. Also, one thing worth mentioning, and it's really important. So you see this first name right here. If I go to my author entity, you see that we have the first name is written in exactly the same way. So we have first and the name with the capital N. Okay, so if you go back here, you cannot say like this. You cannot call your method like this. So it will not be detected. It will not be highlighted as an error. But within your IntelliJ or within your IDE, it might be highlighted as a warning, but not for other cases. But this worth mentioning. So here, the only thing that you need to change is the first letter, because you are using camel case. So what you need to do is just copy the field that you want to use, and until you get used to it, copy it, and then here just paste it, and then you change only the first letter to a capital letter. Okay, so like this, you will have the method, or the exact method that will work for you. And if I change this one to, for example, a lowercase, we see that it's highlighted, and here we see that cannot resolve property first name. This means that my IntelliJ or my IDE, he automatically detected that this first name property is not within this author entity. Okay, so here you need to always be careful about this. All right, so this is our first method, and this one will search all the lists of authors from our database by first name. Now let's try and see how we can improve, or how we can extend this method. Okay. All right, so let's try how we can extend and improve a bit this query. Just as a reminder, I want to remind you that this query is the equivalent of this one. Select star from author where first name, I will use it as in the database. Let's say this is a native query, equals, and here we have our first name as parameter right here. So this is the same exact query. Now let's answer the following question. What if I want to find all the authors from my author table where first name equals any, for example, equals this, and I have in my database the users are all in capital letters, okay, are all uppercase, but I want to ignore the case. I want even to pass, when I pass this Ali as value, I want always to query the data. So within this method right here, and this generated query right here, passing this value Ali and having all the first names in the database equals or in uppercase, this will not work. This will return an empty list. Okay, this will return nothing. Now let's try to extend this query and make it ignore the case. All right, so here we have find all by first name, and I already gave you the answer. We need to add one property which called ignore case. Okay, so when we say ignore case, now it will accept this query right here. Okay, and it will return some data. All right, so this is good. Now, what if I want to get all the data or all the authors from the database where the first name contains this one, for example, contains AL, all right? So, and also I want it to be also ignore case. In order to do so, I will duplicate also this method. So here we have find all by first name, ignore case. We can also add containing. So we need find all by first name, containing, and then ignore case. So as you can see here, we can concatenate and we can use multiple filters within the same query method. Okay, so here we have find all by first name. So this is the attribute name, and then the condition that we want to use, or the where clause that we want to use, containing. So containing will be the equivalent of this one right here. So it will be something like that. Okay, so it's gonna be like %%. So this is the exact same thing. And also we want to insist that we want to ignore the case. So here, be careful, it's property, condition, or where clause, and then the refinement if we want to refine our query. Okay. So now I want to, so this one, I hope it's clear. Otherwise you can drop me a message and I can explain it a bit more. Now I want to get all the authors where the first name starts with this, and also ignoring the case. All right, so in order to do that, let me just keep this as it is, and I will duplicate this method. So I will use it always as a base method. I will copy or paste this query right here. So I want, as I mentioned, to search all the authors from the database where the first name starts with this. So here, instead of containing, I will use starts with. So here, when we use this starts with, the query will be transformed or will be generated exactly like this. Okay. And also here we want to ignore the case. Now let's take another case. Let's play around with these queries because it's really funny. So here, instead of starting with, I want all the first name that ends with. Okay, that ends with, sorry, I just made a mistake. So starts with, it's like that. So it's AL and then anything, because this percent means anything, but ends with is the opposite one. Okay, so I'm sorry for that. So here I need all the queries or all the authors from the database where the name ends with AL. So it starts with anything and ends with AL. All right. So here I will duplicate the same method. And here, instead of starts with, I already gave you the answer. So I need to use ends with. And you can see that this ends with ignore case will transform and will create this exact same query in the background. Okay, so we can also add and play with so many attributes, and as I mentioned, like after the first name or after the property name within your IDE, you can click on Control Space and you will see so many methods. Okay, so starting with, ending with. Also you can check if the author or if an author exists with this first name. You can also use in and so on and so forth. Okay, so for example, if you want to generate this query, so I want the list of authors from the database where the first name in, for example, I want to filter only for example, Ali. I want to get all the authors where the name is whether Ali or Boo or coding. So here it's super easy. As we mentioned before, let me duplicate this method. And here, instead of ends with, I need to pass in. Okay, so, and also here ignore case. So I want to find all the names or all the first names from the author table where the first name is in a list. But here we need to pass a list of strings. Okay, so to pass a list of strings, so whether we pass a table or we pass a collection. Okay, so here we need to pass a list of string as the first names. I will call it first names. And this will generate behind the scenes this exact same query. All right. So you can play with these methods, with these filters, and you can generate awesome queries out of this. Now let's move on and try something else. Now, before moving ahead and going deep into these derived query methods, let's play a bit with what we created right here. So to do so, we will go to this Java application here where we have our command line runner bean, and we need to insert some data into our author table. So in order to be able to play with these queries. But here we face a small issue, which is that if we want to insert multiple data, I need to every time to create, for example, if I want to insert 50 authors into my database, I need to duplicate this code 50 times, and each time I need to change the first name, last name, age, and so forth. But to do so, we can use a dependency which help us to fake data. Okay, so this dependency is called faker, or called Java faker. So it will automatically generate data for us, including, for example, first name, last name, emails, and so forth. Also, it can generate address, and so forth. All right, so first of all, let's go ahead and insert and add this dependency. So open the pom.xml file and go down to the dependencies right here, and after the project Lombok, add the following dependency. Okay, so add the dependency tag, and within the artifact ID, it's called Java faker. So it's the second one, not the fixture, but it's the second one, Java faker. So select this, and then it's from com.github.javafaker. All right, and the most recent version at this time is the 102. If you have more or a recent version, just go ahead and choose it. Then click on this load Maven changes, and that's it. You will have the Java faker within your project. Okay, now let's insert some data. First of all, don't forget to bring back this bin annotation. Let me make this full screen. And then we need to comment out this one. And to comment this out, all you need to do is select it and then go to code. And here you have this comment with block comment. Okay, now let's bring back this code right here. And what we will do, let's create a loop. So I will do for int I equals 0, I smaller than or less than, let's insert 50. And here we have I++. And let's move this code inside. Now, instead of this first name and last name, I will remove the email, or let's keep it like that. The age, we can also keep it. But here, instead of this first name, last name, what we will do, here I will create a faker. I will call it faker equals a new faker. Okay, so this is how we can use our faker object. And now for the first name, I will use faker.name. We see here that we have this name object which returns a name. And from this name, we have first name, name, last name, full name, and so forth. So we need the first name last here. And also let's use the same one for the last name right here. So instead of first name, let's use last name. Okay. Now for the age, we can use our faker dot number, and here we can generate a number or a random number between 2 digits, for example. And the age, I want my author to be between, for example, 19 and maximum, let's say 50. Okay, so it will, like this, it will generate an age or a number between 19 and 50. Okay. All right, so now we can just run our application and make sure that we have all our authors inserted into the database. So let's go ahead and do it. Okay, so here we forgot that our email should be unique. So to do that, I will just do something like this, just to fix it quickly. And here I will concatenate it with I. Okay, so it will be contact 0, 1, and so forth. So like this, we don't have the applications. I will restart the application and see. So now we see that we have the insertion logs. Let's go ahead, refresh our database and check. Let me move this, refresh the data. And here we have our tables, and now let's go and check our author table. Okay, so we see right here that we have this email, and we see that we have this first name, last name, and so on and so forth, and the information that we provided, also the age. But now let's make this insertion permanent. And because here, as you remember, when we start the application and we made this DDL auto right here, like just to remind you the configuration, the DDL auto we created is create drop. So all we need to do is to make this one to update. Okay. So when we make it update every time we will start the application, we will not lose the data. So this is what we need to do. So in order to do that, just go ahead, make this property to update like this, and then what we need to do is to restart the application so we can insert the data. So just follow me on this, restart your application, and then we will have the data inserted. So here we have in our database, let's refresh it. We have this data right here, and this data will be persisted like always. Okay. And then we go back here. In order to make this data always persistent, just go back right here and you can just comment out this insertion, or you can also keep it. But here we want to play with this part right here. But let's comment out all this for loop. So let's use a block comment. So we no longer have this code getting executed. And to make sure that what you did is correct, just go ahead, restart again the application, and make sure that you still have the data. So here we should not see any SQL log telling that we are inserting. And as you can see, the application is already started and nothing happened. So also if I refresh my database, if you open the table right here, click this refresh button, you see that we still have the data. Okay, also let's just to double check, let's refresh this, open, and we see that we have the data right here. Okay, so now we have permanent data within our database, and now we can play with it. Now I want to give you a small exercise. So here we prepared everything, we have all the ground we need to run our tests. So now I want you to play within this repository, this author repository, and the methods that we already generated right here. So within this command line runner, or if you want, you can create a service and some endpoints, and you can play with these methods. But just go ahead and test this find all by methods and see the output. Okay, so I hope you like this exercise. If you face an issue, drop me a message. Otherwise, let's move on. Well done. After you played with all these methods that we created together, now let's move on and check something else. So here we have our author table already inserted with data, and we can see here that we have email, first name, last name, and age. And for this one, I just want to highlight one thing, because here for this email, what I used here, I used the faker.name.username, because I'm sure that this username will give me a unique username. And then I made a concatenation with the @alibucoding.com. So you can also do the same. Also for the age, you can use the faker.number and then number between, and it will give you a random number between 20 and 80, for example. All right, let's go back here. Now we have the data inserted. Now, what if I want to update, for example, the first one, which has the ID equals 1. I want to change the email, first name, last name, and age. Okay, so in order to do that, it's so easy. Here, we will keep this one, and also I will keep the bean, because in the application here, I have create drop. So this means every time I start the application, I will get my data inserted. Okay, so after inserting the data, what I want to do is I want to create, or I want to copy paste this one, or I can copy the whole code. And here I want to update author with ID 1. All right, so in this case, what I will be doing is I will create an author object, and here I will just change the data, and here I will make it first name Ali, last name Bu Ali, and the age, it will be my age, for example, and the email, I will move it back as it was. So contact@alibucoding.com. And then, of course, I will need, okay, I forgot repository.save here. And then I need the same thing here. So now this one, it will insert this, this author. But if I do .id here 1, so this means that we will update this author. And let me explain how this works. So this save method, first of all, it will check the ID. So if we have an ID, the first thing that it will do, it will try to fetch any object within this ID. So it will make select all or select star from author where ID equals 1. If the Hibernate can find data, what it will be doing, it will be merging or updating all these fields. Okay. Otherwise, if, for example, I pass an ID equals 1 million or 100,000, so it will not find any object within this ID in this author table. So it will decide that it will be an insertion or creation of a new input. Here, you need to really pay attention that when you pass an ID, the ID should exist in the table. You should already know the ID in order to update something. So now let's move on and rerun the application. So we will have all this information, but the element or the first one should be Ali Bu Ali, and with the email contact@alibu.com. All right. So here we see also that we have all this insert, and then you see here that we have a select and then an update. So the first select is checking if we have the author with the ID that you specified in here, which is the ID 1. And then we have update author, set age, and so on and so forth. And then where ID equals the ID that we passed as parameter. So now I will just refresh this one, and you will see that if I search for the ID number 1, which will be at the end, we see here that we have the urge34, alibucoding.com, Ali, and Bu Ali as a last name. So this is a way of updating the data. Now, what if I want, for example, just to update this one, or only I want to update age or all the ages of my table. So for example, what if I made a mistake and I want to fix all the updates, or I want to update all the ages of all the authors in the author table? So in this case, I need to write one query which will update everything. So I don't have a condition right here, like I don't have an ID. And if I want to use this method, I need first of all to find all the authors from the table, and then I have to loop over them, and each time I need to set the age, and of course I need to pass the ID and then repository.save. But there is an easier way, and we will see it just right now. So what I want to do now is running the following query. So I want to create a method or create a mechanism that will allow me to run the following query, which is update author, and then set, or let's call it set a.age equals 22, for example. And here, let's start first of all with where a.id equals 1, for example. So I want to execute this query. So it's exactly the same thing like here, but I want to use the JPA or my repository right here. So here I have the author repository, and I will show you how you can use this repository in order to run or to create update queries. So first of all, go to this author repository, and I can just copy this one. And then what I will do, I will create a void, or let's create an int method. So update author, just update author, it's okay. So in order to update the author, we need to pass an int age and then int ID, because we want to update the age of the author having the ID 1, for example. And here, as we mentioned, we want to run this following query. So in order to do that, so we will use the query annotation, and then this is our query. So it's update author a set a.age equals 22 where ID, and now the ID should be like this. All right, so this ID will refer this one, and the age should be also age. So this query does not support update methods or update instructions, but we need now to tell Spring Data JPA that this is an update query. And in order to do that, all we need to do is to add this modifying annotation. So when we have this modifying with this query right here, Hibernate will understand that this is an update query. So now if we go back here, and if I comment this out, and then if I do repository dot update author, and I pass, for example, 22 as age, and I pass 1 as an ID, and rerun the application, we will see that in the author table, we will find that we have an update. Okay, here we see that the application did not run, and we have already one exception. So we see that first of all, we started to insert everything, and then we got an exception, failed to execute command line runner, and then executing an update or delete through an exception. So let me explain to you what is the reason behind that. So the reason is that this update method that we have right here was not or is not transactional. So in order to do that, or in order to fix that, we need to make this modifying query transactional, because the modification or the update need to be within this same transaction. Okay, so in order to fix that, all you need to do, so here you need to put in mind that when you use the query and modifying, then you need also the transactional annotation. So with these three annotations right here, modifying, transactional, and query with the update query, we will be able to update our author. So now let's run again, and let's also check the output. So we see here that we have all the inserts that we have, but now we have no select as we saw before, but it's directly updating. So update author set age where ID equals something. So let's go back to our, and now if I scroll down and I see this one, so we see that the ID number 1 has the age 22. And also, if you want to make sure, you can just put one age equals 100, for example, since we know that all our authors ages are between 20 and 80. So now we can make sure that we updated the correct one, and also the update method or the update query is working as expected. So now we see that the age of this guy right here is 100. So our update query is working. Now, if you want to, or now let's try to update all the ages, or the ages of all the authors that we have. So first of all, I will create a void, update all authors, for example, ages, and here I will just pass an int age. And I will also copy this one, and all I need to do is removing this where clause. And now I will duplicate this one, update all authors, and I will set the age to 99, for example. This one we can comment it out, and I will rerun the application. Oh, we missed something already. So here we need to use the update all authors and the age 99, and I will remove the ID. So let's start again. Okay, so we see here that update author set age equals to something. And if I refresh right here, I should see all the ages equals to 99. So this modifying query and this modifying annotation right here is really useful if you want to do a bulk update and you want to update many things at the same time. So you don't need to loop over the data and set this, set that, set this, set that. So all you need to do is to create an update query, and then if you need, and also don't forget, if you need these workflows, you need to add it. Otherwise, you will be updating all your data. In this part, we will see together the named queries. So in Spring Data JPA, named queries are useful in a variety of scenarios for organizing, optimizing, and maintaining query definitions in your application. And some common use cases includes encapsulation, for example, of your query logic. So named query help you separate query definition for the rest of the application logic. Also, named query are reusable. They also help us optimize the performance of our application because the named query are validated and parsed and often optimized during application startup. So when you have a named query, it will be parsed, validated, and optimized on the application startup. Also, named queries are centralized. This means named queries allow you to store your query definition in one place, either with an entity class or an external XML file. This externalization simplifies query management and makes it easier to update and refactor the queries. Let me give you some specific examples when to use named queries in a Spring Data JPA application. So first of all, when you have complex queries that are used in multiple places throughout your application, when you want to optimize performance for frequently executed queries, when you want also to improve code readability and maintainability by separating query definitions from other application logic. And finally, when you need standard way of organizing and managing queries across your application. So these are the use cases, or some of the use cases of named queries, and the definition also of a named query, but you need to keep something important in mind. While named queries offer several benefits, it's important to note that they may not always be the best choice for every situation. For example, they might not be as flexible as dynamic queries. For example, when we use Query DSL or Criteria API. Also, when it comes to building queries based on varying condition or user inputs. It's essential to evaluate your specific use case and choose the appropriate approach for your application. All right, now let's move on and implement our named query, and let me show you how to do that. To create a named query, first of all, you need to go to the entity or to the model where you want to create that query. So here we have two options. First of all, we can use this annotation named query, or we can also use named queries. So we have two options, okay? Also, we have another one, which is named native query or named native queries right here. So you can also create native queries as named queries. So for this case, let's move on and let's go ahead and create JPQL named queries. So first of all, we will use a single one, and I will show you how you can use this named query, and then I will show you the use case or the usage of these named queries. So first of all, as I mentioned, when using named query, we need to give it a name, and the name, always think about having the entity name or your model name dot the name of the named query. So I will just say find by named query, and then I will provide the query itself. So let's say, for example, for this one, I want to do select A from author A. This is just the alias, where A.age is greater than or equal, for example, to the age I want to pass as a parameter. So now I have a named query, which will fetch all the authors by age, where the age is greater or equal than a specific parameter. So now, in order to execute or to use this named query, just go to your repository right here, and now we want to execute this query, so it will be return a list of authors, and then we have find by. And as you can see, IntelliJ is already proposing this one, And also you see that the icon is slightly different from the native one or from the predefined ones. So here we have find by named query, and also as you saw here we have it's a named query. So all we need to do is to pass our parameter using the param annotation and then age, and then of course it's of type int, so it's going to be int age. So that's it. And here you see already the difference that we have this icon, and when you click on it, it will navigate us to the named query. Okay, so now in order to use this one or to check it, all you need to do is to go here to the JPA application, and then after executing and updating and doing all that, what I will do a list of authors equals repository.find by named query. And here, let's say, for example, I want to fetch all the users having, or all the authors having an age greater or equal than this. Yep, so this one should be, or should go inside. And here it will be find by named query. And then I can do, for example, for each system.out.println. So I just want to print all the authors that will be here. I guess we can also remove this one. And now let's execute our application and let's see the output. So here we see that we have all the authors, and here we just forgot to remove this update, because by this we updated all the authors and we set all the ages to 99, so it will retrieve all of them. So now let's see, and here we have a restricted list, and as we can see here we have all the users where the age is 74, 71, and so on and so forth. So for example, if I change this one to 70 or 7, something like that, yeah, okay. And if we run again, we will see that we will get a shorter list. So you see that we have only 2 with the age 71 and 70. All right, so this is how we can create a named query. Let's move on and let me show you how we can create a list of named queries and how we can create another type of named queries. Now let's update data using named query. So let's try to recreate the same query right here, but using the named query. So first of all, I will just copy this one, and then I will go back to the author, and I will create another named query right here, and then I will give it a name. So the name will be author.update by named query, and the query will be the one I just copied. So here it will be update author set age where ID equals something, but here I will just remove this ID, and I want to update all the authors. So again, I need to go back here. So it will be a void update by named query. And this one, of course, we need a parameter, which is the age, and then int age. All right, so let's double check. So here we have a variable age. So we need to pass it. And this is what we did right here. Now let's go back after displaying all this data. Now update with named query. So all I need to do is my repository dot update with name or by named query. And here I will pass, for example, 12 as an age, and I will execute the application again and check what will happen. So it seems that it did not work. And now I guess, and I'm pretty sure that you know why it did not work. And the answer is, so let me first show you the exception, failed to execute command runner. And here it says expecting a select query, but we got an update. So the answer is that is the one you already thinking about. We need this modifying, and of course we need the transactional annotation. So even if it's a named query, if it's an update query, we need always to use this modifying. So let's run again and check. And now we see that we have this update. And then if I open my table right here, and I will see that all the ages now are 12. So that's it. Also, before Before we move on to the next steps, here you see, or we mentioned already, that we can use named query or this annotation named queries. The difference between this named query and named queries, actually there is no difference, because if we go to the source code of this annotation, we see that we have, or we can pass a list of named queries. So it's just a way to organize our named queries. So we can do something like that, and we can move these named queries inside. And that's it. So this is the only difference between the named queries and the named queries. So you can whether have them separately, or you can also group them within a list of named queries, and nothing will change. It will be always the same. Everything will remain the same. All we need to do is just group them with named queries. Spring Data JPA specification is a powerful and flexible feature provided by Spring Data JPA framework that allows developers to create dynamic and type-safe queries using the JPA Criteria API. It enables you to build complex queries based on various criteria, which can be combined and reused in different scenarios, providing flexibility and maintainability in constructing queries. And the core of the specification, the core concept of Spring Data specification revolves around the specification interface, which is a functional interface with a single method. So here we see in the source code that we have a bunch of static and default methods, but the main method, or the main important method, is this one, predicate to predicate. Here, the T represents the entity type on which the query is built, and the pred2predicate method receives 3 arguments. First of all, we have the root right here, which is the object that represents the root entity in the query, from which you can navigate to other related entities and attributes. And then we have a query, which is a criteria query of a type interrogation mark, which can be any type, which is an object that represents the overall query being built. These can be used to modify the query structure and or add additional constraints. Finally, we have the criteria builder, which is of type criteria builder, which is an object that acts as a factory for creating various query elements like predicates, extensions, and orderings. The toPredicate method returns a predicate, which is a Boolean expression representing the query condition. Now let's talk about how we can use this specification. So to use the Spring Data specification, you need first of all to extend your repository with this JPA specification executor interface, which provides methods to perform queries using specifications. The most common used methods are findAll and findOne. You can also create custom specifications instances by implementing the specification interface or by using lambda expression. So specifications can be combined using the AND and the OR method. As we can see right here, we have this AND and we have this OR. Also we have where and not. These methods allow us to build complex queries dynamically. In summary and overall, Spring Data JPA specification is a feature that leverages the JPA Criteria API to build dynamic and type-safe queries for your application. It provides a flexible and maintainable approach to construct queries based on various criteria, which can be combined and reused throughout your application. This approach is particularly used when dealing with complex queries that depend on user input or vary based on runtime conditions. Now let's move on to the action and let's implement our first specification query. The first step in implementing specifications is, first of all, you need to go to your repository where you have or where you extend your JPA, the JPA repository. Also, we need to extend the JPA specification executor. So here we extend already JPA repository. I will also extend JPA specification executor, and here we need to give it the same type author in here. All right, so now we have our repository ready to be used as a specification executor. After extending the author repository, we need to create a new class. So I will create a new package here. I will call it specification. And then I will create a new class, call it author specification. And now within my author specification, I will create two specifications, or let's call them two predicates. And these predicates, they will filter, for example, my authors based on the first name and age. So let's create the first one, public static specification. And my specification is of type author, of course, don't forget that. And let's call this one has age, for example, and this is gonna be our first filter. So first of all, it's gonna be int age, and then we need to return a lambda expression. So you know, when the two predicate method that we checked before, it takes root of type author, and let's call it root. And then we have the criteria query, and this one, as we mentioned before, it's going to be an interrogation mark. This is our query, and we have our criteria builder. Now let me just inline these variables so you can see everything. So here we have these are the parameters that we need, as we explained before. So we have our root of type author, we have the criteria query, and the criteria builder. So here what I want to do, or like what we need to filter out, is first of all, if this age right here, so for example, this is just a check, if it's less than 0, so I will just return null, because we know that we don't have any age or any person having a negative age. Otherwise, I will return my criteria builder dot equal, and then I need to pass the expression. So it's the root that holds the information of the entity dot get, and then I can pass the attribute name that I want to filter on, which is age, and then the age itself. So here I'm ensuring that this method has age right here will add a criteria, or will add specification that the age of the author right here, this variable or this field right here, should be equal the age that we will pass as a parameter. So just I need to remind you that what we are building right here is not the query itself, but it's just, or are just the filters that we want to use. So for example, I want to filter all the authors by age and the name containing or starts with. Okay, so next one, I will build a public static. Again, it's a specification of author, and then let's say first name contains or starts with. And here I need to pass my first name, and I will just copy paste this one. So here, if my first name is null, so I need to return null. Otherwise, here I want to do first name, and here of course I need the parameter. So as you know, in SQL, contains is not we don't have such method called contains, but we have a method called like. So like, I want to have this first name to be like the parameter that I want to pass. So now we just built two specifications, or two predicates. The first one is has age, and it will check that this author has an age that we will pass as a parameter. And again, we have this first name contains, or let's maybe call it first name like, to be more consistent with this method right here. And this will check that the first name that we will pass as a parameter contains or is like the first name that we have in the database. So now let's move on, and let me show you how to use this specification class that we just created. Now let me show you how to execute a specification. But first of all, let's prepare a few things. I will go to the application YAML, and here instead of create drop, I will make it just update, because I want to have some persistent data. and I want to check what we have in the database. So this is the first one, and then I will just keep this one for the first time. I will execute the application, and I will then just remove all this one. So I don't want to update the ages. I don't want to find anything. All I need is just to execute it for one time and make sure that I have some data gets persisted. So here we see that we have all the inserts, and if I check again my table, we have the data inserted, and then all I will do is comment this out, and now I can stop the application and we can now implement or run our specification. So in order to run the specification that we created, first of all, we need to create an object of type specification having a type author, and let's call it spec or specification. It's as you like. I will use spec as a short name, equals specification, and then dot where. So this is our where clause. So the first filter of our where clause is this one, this author specification that we created. So first of all, I want to filter by age and first name. Okay, so I want to get all the authors having the age equals something and first name equals something. So here I can use author specification dot has age, for example, let's say 34, let's just imagine. And so here we can use and or we can even pass another predicate, but we can rely on and or. So let's say and. Also, again, I want to use my author specification and then first name like. So for the first name, I will again refresh this list and take, for example, this one. Okay, so I want to fetch all the authors having the name, for example, starting with or containing this Mitch. Okay, I will say MI, just MI. Okay, so then once we are done with creating or declaring our specification, I will do my repository dot find all, and then within the find all method, I can now pass my specification as a parameter because our repository already extends or implements the JPA specification executor. So here I will just do for each and then system.out.println just to print out our result. So let's click and run the application and see what will happen. So we see here, first of all, we have an exception. And the first thing that we see in here that could not resolve attribute first name. And let me show you why. So this first name here, we said that I want to have the first name like, but let's check our author. So the author, it's first name with a capital N. So this is important to have exactly the same thing. All right. So now I will run again and check. So here we see that we have the select, but we don't have any result. And you may wonder why. I can tell you. So when we use the keyword like, when in the SQL, when we use this keyword like, we should always use like, and then it should be like this. So it should be %%, and then our filter right here. Okay. So this is what we are missing with the first name. So we need to do something like this. And then I will add % in the beginning and % at the end. So we need to surround this first name, the variable that we want to pass, with a %%. Okay. So whether we do it here or you can do it when you pass this parameter like this. But it's better to put it in the specification because like means that we have something like this. Okay. Now let's run again. And we still can't see our data. Let's first check the author. So we have our Mitch right here, and let's go back. Yeah, but Mitch, yes, that was the problem, but Mitch is 22 years old and we don't have any other Mitch within the same age. So now I will just change this one to 22 and run again the application. So here we see that we have at least one result, which is this guy called Mitchell, and so on and so forth, and having the age 22. So now, for example, I want to search only for the authors that the age is 22. So I just can comment this out and run my application again, or execute my query again, and this one, it will filter all the users that they are 22 years old. Or also I can do something else. So here, instead of and, I can say or. So find all the authors that are 22 years old, or the name is like or contains MI. So let's run again and check the specification return type. So here we see also that we have these two elements. So this guy is 22, and we have the first one is Mitch, and then we have this Paulita. So for example, also if I let's just play a little bit with the variables that we pass, and here I want to filter all the authors that the first name contains the letter I, and as you can see here, it's an I, it's an I, it's an I, and so on and so forth. So this is how you can create dynamic queries. And also the best part of specifications is you can reuse all these methods that we created. All these predicates or all these specifications are reusable, and you can reuse them to create dynamic queries. Okay. So for example, if you have a search or a complicated or complex search query, you can use specification in order to prepare and in order to create your query in advance.